Good morning, everyone. Welcome to this 114th edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing committee here. I'll quickly introduce the Zak World of Façades conference series for those who are attending it for the first time. We've been organizing the Zak World of Façades conferences from 2012. We've completed around 113 editions. This is edition 114. This is our fourth edition in Singapore, but the last one was in 2019. Almost 3.5 years. Of course, it was a forced break thanks to the pandemic and the travel restrictions, but we are back now. We've been doing events since March 2021 in countries where restrictions were eased. So it's almost 40 events since we have completed from when the pandemic began. So the events are all across the globe from New Zealand up until Canada. Lots of events, lots of information being shared on best practices in design, engineering, and executing facades. But I'd like to start off by thanking our event partners, without whom this wouldn't have been possible. So starting with our presenting partner, Schueco. Schueco is a global leader in aluminum door, window, curtain wall systems. They're one of the key pillars of this conference series globally. They've been partners with us since the beginning here in Singapore and Southeast Asia. Axalta are a liquid and powder coating manufacturer. They're participating with us for the first time in Southeast Asia, but they have been present with us in other regions. WHTB, the short form of Beijing Hua Tianbo Glass. They are a value-added glass processor out of China. Colt is a natural ventilation, louvers, smoke curtain solution provider, now part of the Kingspan Group. China Southern Glass, another high-performance value-added glass processor out of China. Envelon is BIP, building integrated photovoltaic glass provider, part of the Grenzebach Group. Florim is an Italian manufacturer of sintered stone, which is a sustainable cladding product. Jotun is a powder coating manufacturer. They're participating with us first time in the Southeast Asian region. Kinlong is a glass hardware fittings, tools, and we've got so many other products now. Basically a one-stop shop for accessories and fixings for doors, windows, and facades. Kurare is the mother company of the laminated glass interlayers, Throsifol, and Sentry Glass. Osaka Rubber is an Indian manufacturer of EPDM rubber gaskets. Renson is a Belgium company into natural ventilation and solar protection products. Seele is a high-end German specialty product contractor. Serge Ferrari is a French company. They have fabrics which can be used in architectural applications. They've also been with us since the first event here in Southeast Asia. SG Glass is again a value-added glass products specialist based out of Singapore. Technorail is an Indian manufacturer of modular railing systems. 2960 is a distributor of sealants, of ventilated cladding systems, of cladding products, and lots more. Vector Foiltec is a German company. They engineer ETFE structures. Vitro Architectural Glass, formerly known as PPG Glass, is a high-performance coated glass manufacturer out of the US. And our technology partner, Orgadata. Orgadata have a software for estimation of doors, windows, and facades. Thanks to Orgadata, all the people who have a red badge, the delegate badge, will have a USB stick. So we don't have a delegate kit anymore, so it's a USB stick. The USB stick has the brochure of all our 20 sponsors. So that's courtesy Orgadata. And our next few events, we're doing an event in Istanbul next week. We're doing Madrid the following week. We're doing Mexico City, so we've got events almost every week all across the globe. Then we've got one in India. We've got Birmingham later on. We've got Canada with Vancouver. And of course, our events in the Asia-Pacific region, we've got Hong Kong, Shanghai in the eastern, and Seoul in the Eastern Asian region. And then we've got Ho Chi Minh City, Jakarta, and Sydney left for the year in the Southeast Asian and Australasian regions. This is what we've been doing with the events globally. These are networking events, one-day events where we invite architects, consultants, contractors, product manufacturers to talk different things on the building envelope, what are the current trends. This is where we are at. I'm also your host for today. Unfortunately, our host, Mr. John Perry, was supposed to come from Australia, met with an accident. He couldn't make it, so I'll be stepping in from him. But before we get to our first presentation, just wanted to highlight a few things, what's happening in the last few years. We're meeting after 3.5 years. I think the most important thing now for designers, for facade engineers, is now calculating carbon, the amount of carbon spent in designing a building. So you'll obviously hear this term low carbon design, which is now a fashion word. Earlier we used to use sustainability, but now I think bang on, everyone's using low carbon design. And then another new term which has come up, which is very frequent in the last few years, is embodied carbon. So embodied carbon is the amount of carbon you use before the building is built. So again, these are new terms, things which were designed with operational carbon in mind are now being re-looked at from an embodied carbon point of view. So all these things have changed in the last few years. Climate change is real. We're having catastrophe events all across the globe. War, unfortunately, between Russia and Ukraine was something unexpected. So that has led to energy being looked at more seriously, which has then increased the use or probably the interest for building integrated photovoltaics. Investors are now more concerned about their building's energy and how they can store it. So I think photovoltaics have picked up. And I think the advancement in photovoltaics have also made it go in such a way that the prices come down, and then we've got nice colors and good options. So these are the few trends which we see across the globe. Obviously here in Singapore, both these topics, embodied carbon and BIPV, are well being spoken of. And I think, like always, Singapore is going to be the country which will set the benchmark in Asia for incorporating these technologies. So this is where we are planning to take the direction of the event today, to talk more on these new topics, as well as the classical facade engineering topics and other trends and innovations. So this is what the event's going to be like today. We don't have any questions. All our speakers will be present in the networking breaks. If you have questions, you can contact them in the break and take them forward. Our sponsors, all of them have a booth outside. Request you to please visit them in the break. We've waited for some time for this event here, so would appreciate if you can drop by and say a hello to our event sponsors. So without taking any further time, I'd like to call upon our first speaker for today, which is Michael Chin. He's a principal at the Arup Singapore office. He's going to be talking on the future of facades in a decarbonized buildings industry, which is exactly what I mentioned about what is embodied carbon and how we can count and calculate carbon. These are some things he's going to talk on. And Arup are probably world leaders, or I would like to say flag bearers, of spreading the word around on how to calculate embodied carbon, what it is. They've been doing this from the last 2-3 years out of their London office originally, and then all across the globe now. I think they have set a benchmark where they have made a lot of advancements in calculating embodied carbon. But we'll be hearing more about that from Michael Chin. And Michael, over to you, please.
Hi, can you hear me? Morning to everyone. Michael Chin, I lead the facade engineering business here in Singapore. So it's good to see so many familiar faces. I've spoken to some of you this morning. So all thanks to Zak and Ahmed and his team, for bringing us here, face to face again. It is something that we have probably lost touch a bit, over these 2 years that we are in kind of lockdown, because of COVID. But really good to see all of you, and I hope to catch up with you later, along the day. Okay, I won't talk so much about Arup now, and most of you will probably know, or if not, you can Google it. 75 years now, started due to this man, Ulf Arup, in UK. And now we have many offices around the world, 95 offices, 40 countries, and 16,000 plus professionals and counting. Right. During this period of pandemic, there was again organic growth. We didn't have to do too many reductions in terms of that numbers, but the numbers kept growing. So it is a resilient industry that we are in. So that's good to know. Facade, who we are about 300 people, all around. So we always pride ourselves in a sense. In Singapore, we've got about 30 people just doing facade. Globally, we have about 300 plus. Anything that we can't solve, somebody in the world, in Arup, will know the answer to. So that's where our strengths and a diverse team is all about. And we always pride ourselves in that. Okay, so today the topic really I want to talk about is decarbonization. You probably hear a lot about it. I think for the past 10 years or so, in Singapore, we started with the green mark, and sustainability. Initially, there was a bit of reluctance, not moving anywhere. But when government, BCA started putting some of these standards in, everybody kind of started to follow. And we've gone through many versions of green mark, and now we are looking even at green mark SLE. So many of our buildings, especially government buildings, are all SLE buildings, super low energy. Is that enough? No. We're taking it one step further, decarbonization. So most of you will know, in your companies, you probably have net zero emissions or carbon targets in your company. The Singapore government, we are talking about 2050. All the government buildings, in our next slide, will need to be net zero or net zero emissions by 2050. Right? Government, of course, here takes the lead. By 2045, all the government buildings will have a target of net zero. So we are definitely going in this direction, and there's no turning back. So how do we actually do that? Well, if you look at it, I think some of the trends that we have in our industry, it's quite real, why we need to do this. Well, climate change is visible. Our existing environment, our climate patterns have become a bit more haywire. We've got heat wave in Sichuan, and most recently in New Zealand we have floods, which took quite a lot of lives, and property damages. So it's actually a big impact in terms of what it does to our life. So if everything status quo, then things are just going to get worse, right? And we know it will be. This is already telling us. Then, of course, our sustainability investments is a lot more green bonds, green targets, that are now tied to your aspirations or your ESG aspirations of your company. So, if you want to get loans at a cheaper rate, you need to make sure your ESG credentials are right. Then, of course, in SGX, you've starting 2022, you actually have to declare some of this, what you call TCFD, climate disclosure. All right. So everyone is going in that direction. It's something that we really can't avoid. We need to do something about. So these are just some of the trends. As I talked about, GM, neighbor, green finance. We are being washed with these terms day in, day out. So yeah, it's going there definitely. And where we are, and I suppose if you look at that curve, 2050, we're supposed to go net zero. We are probably at midpoint now, 2030. So we've done, I suppose the lower hanging fruit, the easiest picking, you've done that. Now, for the next 2030 to 2050, we've got to do a lot more. Solutions, innovative solutions will need to be there before we actually come to net zero. And hopefully at the end of net zero, what you need to buy as carbon credit offset, and we call it carbon offset, will be very, very small. Okay, so just in terms of overall numbers, 39% of global energy related to carbon emissions are from buildings. Right? 28% are from operational emissions, which is your what we call, commonly known as operational carbon. 11% is from your material and construction, which is what we call embodied carbon. Right? Essentially, decarbonization means all of the CO2 that's being produced, and CO2 is a greenhouse gas, and this is causing the problem that we all face today. So, roughly the percentage is what we are talking about. Whole life cycle carbon, this is essentially how things actually look at when you start kind of doing your construction. That's where you will see a lot of the embodied carbon being used up, being released. And during operation, your 20, 30 years, as you go along, between the two peaks, or between all the peaks, you will see all the operational carbon. But it's, in the end, it works out to be that 29% versus the 11%, that we are talking about. So the whole life carbon really talks about, how much CO2 that you produce throughout the entire cycle of your building, all the way until material reuse. Again, this is just a simple chart, embodied carbon versus operational carbon. Don't worry about the scope 1, scope 2, scope 3. There's probably too much of data at this point. But essentially, this is how things are being broken down. Again, another one here, if you look at operational carbon versus embodied carbon, right? So that operational carbon piece, whenever we do, there's things that we do in our design, passive, active, the operational stuff, we can do all our smarts, and we can bring that piece down. And of course, there's the biggest elephant in the room there, which we are all trying to address at some point, the grid carbon. At some point, it will be better, it will be green, it will be on renewables, but at this point, it is either in Singapore, it's on gas, in some countries on coal, and of course, very little renewables in terms of hydropower. So that element there will always be there, right? And as you start going down, you start looking at transformation, building less, A&A works, how do you reduce your existing buildings? Those are the things where you are not actually releasing carbon outside, or to the environment. Then you are actually sequestering some of this carbon, meaning you are not actually generating new carbon into the atmosphere. All right? Again, at the end of it, after you've done this whole process, you get down to that purple square, ideal at the end. That's your certified offset. As much as possible, you want to reduce it, but if we are not going down on this 50 years path, with this kind of intention, you are not going to get there. Your purple will be one of these lines that you have between the first and the fourth line. Okay, so something that we've done quite a bit now, we're looking at carbon budgets. And of course, the budgets that we always look at is money. That's something that we are very, very used to. Everything revolves around costs and the cost benefit of using a certain material, using certain design. But we started to look at things like carbon budget. All right? So essentially, what type of budget, what kind of material, or in terms of superstructure and substructure, the facade elements, the building services, every one of these elements need to have their carbon target. And once you set that carbon target, then you can then allocate to the different elements and different design, so that you can meet the overall target, which is this number here at the bottom. What is that number at this point? It's still not firm. Of course, we draw from experiences around the world. Letty in London is obviously one of the front runners. Our UK colleagues. And we know, some of you who work in London and around Europe, it's been happening for the past 5-10 years probably. LCA, carbon counting. It's definitely progressed ahead of Singapore, and it's coming to Asia now. And these are some of the references that we draw from. So the first one is Letty, the second one is World Business Council. The third one, of course, Singapore started in a BCA with that 700 number. For SLE buildings, which is, again, if you look at it in comparison, we've still got a long ways to go. So what is then target for our buildings here in Southeast Asia and in Singapore, is something that we all have to work out. You're probably familiar with this, the life cycle division. This is in one of the manuals. But essentially, what I want to point out here is the definition. Right? Everybody talks about embodied carbon, and there are many definitions to it. Just here, we already have 4: cradle to gate, cradle to completion, and then, of course, cradle to cradle. And the last one is, sorry, I just moved this. What we call cradle to gate, as well as cradle to completion, and then cradle to cradle, meaning you go one whole round and cycle. But beware of the definitions. The definitions are definitely important. So sometimes when people tell you, what is this carbon number? This carbon number could be just from A1 to A3, or is it A1 to A5, which is actually to completion, or is it a whole life carbon number? So those are the things that are important. But bear it in mind, in this question, there's probably no answer at this point. Okay, so how is embodied carbon calculated? I think it's important, again, it ties back to what I said, level of detail, what is included, what is not, and what kind of data. I think the biggest issue that we have here, I would say around the world, probably less in UK than in here, is really the data and the accuracy of the data. You might be aware of some of these data, they need to be certified. If you say that your product is of a certain carbon intensity, then who certifies it? Some of these things need to be certified. And unfortunately, we don't have enough supplier in the supply chain that actually has this, what we call certification. So it is important, but we are not there yet. So in Europe, again, that's where things start off. The Euro codes are definitely our reference, and we've been using this for the past few years to actually calculate our LCAs and embodied carbon. There's frameworks around what we do, and obviously we're all going to draw on that data to actually derive or work out the way we calculate our carbon numbers. So this LCA, we call life cycle assessment. I think on some of our projects, we've already started doing it. But you'll find that, from some of you who've actually done it before, the amount of data, or the lack of data, I would say, is actually quite important. It's quite stark in terms of, some of these numbers. Where do we get these numbers from? Are they accurate, not accurate? But LCA actually states, part of this BS standard actually states that there's no single method that you can conduct LCA. So a lot of our procurement and the way we procure our products actually is quite different from our counterparts in Europe, for example. We get it from China, we get it from around Southeast Asia. If we can kind of prove how the whole process along the whole life cycle carbon of the production process, for example, then it is also acceptable in terms of meeting what's requirement in our life cycle assessment. So in Arup, we've made things a bit easier. Sometimes we always like tools, and along the way, while we talk about some of these things, we always think, what are the ways to make our life a bit easier, in terms of calculating some of this. And this is, possibly, in going into details, and as consultants, we will need to do that. One of these elements that when we do this system, for example, that you see here, the systems, the tool that we have actually immediately calculate the carbon intensity of that particular configuration. And a lot of times when we do optioneering, the architects in here and the rest of consultants, when we do, it's always option A, B, C, D, give me 5 options. And we always look at it in terms of perspectives, right? In terms of comparing different options. But we've never actually looked at, I suppose, carbon in its way, whether is carbon intensive or not. So this is some of the software that we've done, internally, just by looking at material, looking at element. We know the carbon content of our system. It gives you another parameters to actually consider, right? More things to think about. So this is just one of the systems. I think, when we start looking at different design, we are always looking at different systems, different configuration, spandrel, vision, window wall ratio. What is that carbon content? What are you looking at? Now, immediately, we can link them up. This is just one option that we have done. 3 different configurations, very common, right? We do optioneering, but what is the carbon that you're looking at? So option 1, option 2, option 3 gives you another parameter that you can consider in terms of carbon per meter square. May not be a big issue, but at least you know where does your carbon content sit. Refurbishment as well, we do that. Different options, always, but put into the software and we can generate some of these things very, very quickly. This is another one, looking at the performance side of things. Again, one of those software that we use internally to actually determine some, what is the configuration during optioneering process that we do. May not be exactly related to carbon in that sense, but at least from some of these site parameters, we can then look at everything in all aspects in one model. So like for this one, we said, average number of hours the shades are being deployed on this elevation. So then it gives you pictorially, from an image point of view, and everyone can see how things are working in the model when they are being shown to you live, instead of reading probably 30-page or 40-page report. Okay, this is the Google one. I just talked a bit about the facade. It's a shingle facade. Again, at the end, the shingle facade was chosen over the flat facade because the shingle facade actually have some self-shading properties. So in terms of performance, actually better. But unfortunately, because of the long elevation and the site plan, there's not much choice, right? So we got to be clever with that facade. So then, how do we then look at that optioneering, using internal software? It all helps towards what we are doing. So that's in construction. Image of that is probably way beyond that, almost finished by now. But it's a very nice building, as you can see here. Okay, so actually, kind of going one long way and then coming back. Hopefully you're not too confused by now. Why do we need to consider embodied carbon? I mean, everybody talks about operational carbon most of the time, right? And we said machine, 4 ticks, 5 ticks, very familiar to all of us. Our fridge, our aircon, 4 ticks, 5 ticks. All that deals with operational carbon. Embodied carbon is, you can say before that. And how does it affect operational carbon in some sense? This is a small chart of the relationship between design stage and the maintenance stage, right? So it means that the small green dots there, where you do, how much you spend in design stage, it gets bigger, it gets magnified. And if you don't do anything about it, if you don't make all your interventions early on, what it means is that by the time you actually run the building over that period of, let's say, 30, 40, 50 years, it multiplies by tens of folds. Right? In this case, it's 400%, but again, that's arbitrary. I'm saying is 1 versus 400. That's the kind of quantum you're looking at. And that's the reason why we need to look at embodied carbon. It's something that we have never looked at before because we're just focusing on the other part. So if you look at this chart, right, and again, I talk about facade specific, right, because that's what I do. The embodied carbon is different for each option. Right? And that's easy to understand because the different options from single skin to double skin, the embodied carbon will be in different. But when you start putting or piling up the maintenance carbon, how much you need to maintain, and of course the operational carbon in the end is also slightly different. So what you do, at the embodied carbon stage, actually sometimes, not always, affect your end operational carbon. Okay. Again, this is just one of those things that we do in Arup. Being engineers, we like to look at options, look at numbers, and breakdowns and things like that. And we start looking at this of our typical curtain wall configuration. So you look at the configuration at the bottom, right? All the different configurations that you can think of. Right? How much of that carbon is actually being generated by each option? So what this chart actually shows you quite clearly is the top contributor of facade element, facade curtain wall, by carbon content is always these three: framing, meaning aluminum, and then glass, and of course features and fin. Features and fins, again, could be aluminum. Right? So for those of you who know that, so these are the two that, in terms of carbon intensity, aluminum and glass are the major contributor, the ones that use the most intensive amount of energy to produce. And we all know why, right? The other thing that's not in here is steel, right, which is also carbon intensive, because you need the amount of heat to actually melt your sand, to melt your aluminum, to actually get to this point, before they can actually become the final product. So the amount of heat you actually generate, or the amount of carbon as a result, is quite intensive. So we have to really look at, in terms of that facade piece, beyond the target. And when I say beyond the target, means what? I'm looking at materials. Right? And frankly, you look at, on this picture, just different types of material that is quite common, right? You say the stone, terracotta, bronze, stainless steel, aluminum, and GRC. These are the common material that we use. Like it or not, if you go one big round, anywhere you go, likelihood is we will fall within some of this material, every one of this. Right? And why do we use this? Good reasons, because it's tried and tested, right? Glass, aluminum, right? For example, what kind of viable replacements, like for like, is there in the market at this point, right? Yes, you have potentially other material to look at. At this point, I'm going to be controversial, right? ETFE, PTFE, and you've got all that to represent some of this, replacement product. But at the end of the day, like for like, maybe not, all right? So let's think about how then we can look at this material from a different lens, I suppose. All right? A different lens means how do we then make it a bit more efficient to produce some of this material? And at the moment, we are looking at recycling content. We talked about existing buildings, A and A. Some of these things you can actually recycle. Many buildings in the world, later I'll talk about one Triton, where a lot of the structure has actually been kept. All right? By quantum, by quantity, structure, the RC that we use a lot in Singapore is actually most intensive. The amount of carbon generated is always the highest because of the quantity, not because of the carbon factor. Right? In terms of aluminum, or the facade, right, the aluminum and the glass, the factors are high, but the volume is still less. So in terms of numbers, quantity, absolute quantity is still small. Right? So if you start looking at this, if you use a bit smarter, when you start looking at materials and energy sourcing, there's the biggest elephant in the room, of course, which we cannot avoid, which is how clean your source energy is. Right? So a lot of times you hear, green aluminum, green glass, So these are the things that is being, it's already technology out there, but it's just not prevalent enough. But this material, like it or not, will continue to be there. So, as far as possible, we need to make it as neutral as possible. So I'll just talk about two materials, right, that I talked about. So the first one is glass recycling. At the moment, recently we had a factory, recycling plant in Singapore, which actually recycles glass. Whether it's upcycling or downcycling, that's another question. But essentially, glass recycling now is still very, very intensive. Right? You have to essentially make the glass clean. You've got to take out the laminate. You've got to split the DG. You've got to do all that. And all of that requires a lot of effort and, of course, cost. Yeah. The energy of recycling, this what we call the glass cutlets, if you put into the process, is efficient. All right? You only use 5% of the energy if you use to produce raw glass from scratch. But the process of actually cleaning the glass makes it very, very cumbersome, at least at this point. Right? So hence, a lot of the glass are not very recyclable unless it's coming from their own plant. All right? Aluminum, that's the other big culprit, right? We all know. So when you say low carbon aluminum, some of you probably already come across, and some of you probably in the room also represents some of these low carbon aluminum suppliers. Yeah. And I mean, the good thing about aluminum compared to glass is infinitely recyclable, so you can keep recycling. Unfortunately, we are using so much aluminum, it's not enough to go around. In fact, we need more. Right? And even things, Ahmed was talking about PV and all that, the frame is still aluminum. So the more PV we use, the more aluminum we are actually using. So there's a bit of, chicken and egg situation here that we're looking at. But again, there's huge opportunities that we can look at in terms of green and low carbon aluminum. This is one example of it, hydro. They've got products which are essentially low carbon aluminum. In UK, in Europe, we already started specifying it. In Singapore, probably not so much. I heard they've not enough to go around, because everybody's asking for it. But again, a lot of the suppliers around the world, our supply chain here in Singapore is quite different, right? We get a lot of our materials actually from China, from Southeast Asia, and a lot of all this, really, we've got to now start working with some of these supply chain guys to actually look at the LCA and look at their processes. One of the biggest advantage of why Reduxa or this low alum carbon is as low as it is because of the energy. Right? They are using a lot of hydropower, and as I said earlier, the hydropower, the amount of energy that you use to heat aluminum to actually melt them is actually quite intensive. If you use it from a dirty source, then obviously it's not going to be that clean. Right? If you use it from hydropower, you use it from renewables, then obviously it's going to be something like that. So long way to go, but we know we have a solution. So back to my whole life cycle assessment and the changing design. Really, the impact of whole life carbon assessment, it is important, right? We need to start somewhere. Unfortunately, we are just at the beginning end. We're just at the beginning, but we've already had many of this experience and track record that's being done by some of our counterparts in London, Europe, and around the world. Yeah. So it is a path that we need to move towards too. But there are some challenges, not to say there's none. These are some of that. You need to carefully deploy the carbon budget if you know the budget in the first place. Option studies considering embodied and operational carbon. Now it's no longer architect and a facade consultant, or architect and the acoustic consultant, for example. It's entire, everybody's effort around this room, entire cycle into the process. If you don't, you will not get to that final solution. Of course, aesthetic is always a concern, all right, and what is acceptable and what's not. Components earn their place on a project. And this is something that, whose voice is bigger, and sometimes it is very, very difficult to actually get to that final solution. Driving changes in supply chain, I talked about that, right? Everybody here will probably be concerned, this material coming from China, is it clean? What's the carbon content? Or that material coming from Malaysia, do they have an EPD? Do they have a life cycle assessment? Chances are you will get no as an answer. So, recycled content, this is quite common, whether we can use it. The reason for this is obviously when you recycle some of this material, we demolish a lot of our buildings. If we can recycle some of them, essentially, we are saving that carbon. We are sequestering that carbon inside the building, without generating more. So these are just some of this material that we can use to replace. Not 100% yet, unfortunately, but better start somewhere than none. Some examples, as you can see, a lot of these are experimental, at best. They show to be okay, can be used, but on a large scale, there's always going to be an issue. So how do we actually upscale and increase that level of complexity to actual building? It needs a lot of testing. Okay, I'll go very quickly onto this one, Triton. I think some of you may have heard a lot about it. It's a building that Arup recently completed in UK, owned by British Land. And on this project, they actually look at two things, the two principles. circularity, and also a principle of marginal gains. Right? They always compare it to a top-level athlete, or cyclist, they say, where essentially every single gain that you get from every part, cumulatively will work wonders towards that ultimate goal. Right? So optimization and all that. And on this building, most of the structure is being maintained. But I would like to talk a bit about the facade, right? So when you start once you, as I said earlier, once you kind of maintain the structure, and structure, the RC being the most carbon intensive, if you're not doing new stuff onto it, you're not building new components, you're not using new RC, not using new steel, then you're saving a lot of the carbon already, right? So the principle around looking at facade is just these three things. Find value, reuse, and make it reusable. Coincidentally, Arup was also the original designer on this building 20 years ago. Right? So there's this whole story about circularity, and then after 20 years, we actually took out the facade, clean it, check, and then see whether there are some things that can be used, cannot be used, and then we actually put it back. So as you see from here, Type 1A, the outer screen is actually being removed, extended, cleaned, in a factory somewhere in London, not London, outside of London, and then being installed back. The inner skin, they've had some refurbishment. They've replaced the glass, obviously, because of the performance. Right? So this is just pictorially. I will just go very quickly. Essentially, take out, clean, and then put it back. Not many, not common. So these are some of the credentials. Refurbished 35,000 panels. But I want to point you to that carbon footprint, right? Just now we talked about 500, 600, 700, which is like something for a new building. This building here is 136 kg of CO2 per meter square GFA. Very, very low. You can only do that with existing buildings, nothing else. Right? So don't look at a number and then go and ask your team to, hey, I want to meet this target. Not possible. Disclaimer. So yeah, around Triton Square, just some of these things that we did, understanding of material, understanding supply chain, accessible of components, availability of data. With our Singapore context and Southeast Asia context, these are all relevant questions to ask. This is just another one, Lloyd's. Yeah, they essentially had a glass that looks like that, which they run over rollers, but the rollers was no longer in use. So what they did, they want to have a bit more clarity. They took the glass out, they recycled the glass, put it into a DGU, and then on the right, that's what you get. Right, very nice. And some of the areas, they are doing all this novelty. I won't talk a bit about this. Okay, so last few slides, really, this is what we always say in Arup. The top of the pyramid, inverted, and build nothing, or build less. I won't talk so much about that. Obviously, that's an obvious question, but if we build nothing, then you and I won't be here. All right? So, really, I want to point you down to build efficient, minimize waste, and build low carbon. All right? Summary, I will just skip. But at the end, I want to talk about this. Our approach, very quickly, whole life carbon. Always ask about whole life carbon. Definition is the key, right? As I said earlier. Collaborative mindset, all right, is very important, and total architecture. Every one of us here is a stakeholder. And when we look at this carbon piece, there's literally, I can really say there's less of architect's role, consultant's role, contractor's role. No. Everybody sits together, brainstorm to get that final solution. It is most important. Right? Otherwise, it will not happen. Right? And of course, there are many things that we can do. All of these are just some of the nice to have. So what do you do above, which is your existing design? What you want to put into it? What benefits your project? And what about other stuff that you don't? There's so many thousand things that you can actually incorporate, but make sure they are beneficial, and every one of them earn a place in that final carbon budget that we have. All right. So yeah, with that, thank you very much.
Thank you, Michael. One more thing for designers to consider: embodied carbon. It's real. You've seen the data. You've seen what a difference it can make. So that's something for designers to consider. Okay, our next presenter, she's from London, Tina Key. She's a director at PLP Architect. She's also the director of the Singapore office of PLP. She'll be talking on a life-centric approach to design. Over to you, Tina. Thank you.
Thank you very much. Hi, my name's Tina Q, and I'm a director at PLP Architecture. And thank you, Zak, for inviting me here today. It's nice to see some friendly face, or at least one friendly face, Michael, which we've been enjoying working with on our project in Singapore. But I'm here today to talk to you about our life-centric approach to design through some of our projects around the world by PLP. I need to grab this little thing. But I'd like to start the presentation with an introduction about PLP architecture. We are roughly about 50-50 minutes split between female and male colleagues. There are 150 of us in that picture, sitting in our base home in London. And we are from all over the world, and we speak 45 different languages. And that's exceptionally important to us because that diversity allows us to work collaboratively across the world. Our main home is in London, but we have a studio also in Amsterdam, Tokyo, and now in Singapore. Our work ranges from master plan work to buildings for work, such as office buildings, life science labs, even broadcasting studios, a range of residential projects of all types and sizes, and hospitality projects. We are a heavily research-driven company, and 5 years ago we established something called PLP Labs, which is a separate research arm of our studio in London. And the PLP Labs looks at the intersection between technology, people, and the planet. We collaborate with a lot of smart people, and a lot of our research results in publications, and we share them with everyone so that we can be more collaborative and try those ideas. And all of our publications are available online. But a lot of our research eventually ends up in our projects in the studio. PLP Labs also looks a lot into smart technology, smart cities, vertical circulation buildings, but now even to product design and user interface experiences such as the ATM machine in the bottom right-hand corner, and even mobile phones. At the moment, we're researching into bio-based material in our lab in London. This is a video of mycelium growing. You can see from the bottom up, it's growing up the structure. And this is going to be used as a construction material for an expo pavilion in a few months' time. We also do a lot of work into developing new construction methods. This is working with Cambridge University. And the output of this research has been our ability to now build buildings up to 22 stories in timber. What are we doing now? And that's what I'm here to share with you. So from the inception of PLP architecture, we have always had a very specific focus into human-centric design and approach to our projects. As a result of what's happening to the world and the planet, we have shifted that focus to a life-centric approach. And what do I mean by that for us? So these are the 6 ingredients we have been using for human-centric design to buildings and cities: integration of business and leisure, enhancement of health and well-being, making places for culture and placemaking, and integrating sustainability, smart technology to promote social interaction with the community. But we recognize that there's been a significant shift in the relationship between human habits and nature and what's happening to our planet. So our shift has been to emphasize our focus on the sustainability and also the health and well-being, to now incorporate decarbonization, circular economy, adaptation to climate change, biodiversity, and we hope that that will improve community health, welfare, resilience, and inclusivity. So as we move to a life-centric approach, We are now focused more on the carbon reduction in our projects and our buildings for the environment and for the people. As I mentioned earlier, a lot of our research makes its way into our projects, and I'm just going to touch upon 2 research projects that we looked at that form the basis of our Park Nova project in Singapore, and that thesis is looking at connecting to nature. So in the studio, as part of the PLP labs, we looked at the importance of biophilia in the workplace. And what did we find? Not surprisingly, the more immersive the environment, the more productive and happy you are. The second piece of research is looking at the function and the changes to how we use our homes. The pandemic certified a lot of our research on that, but now, as we all know, the home is not just our home. It's our workplace, it's our gym, our social interaction area, our restaurant, cafes, library, and most importantly, our garden space. So Park Nova is a residential project that's now under construction on Orchard Boulevard, and we've been really enjoying working with our colleagues here in Singapore, P&T and ICN and JRP. And when we first looked at the site, we were very impressed upon the immersiveness of the existing building in the white in the center, submerged within this canopy of trees, and we were impressed upon the lush greenery. So we took upon extruding the building upwards to create the volume for the building. But what we wanted to do specifically was to provide that private garden to each and every single residence in the building. So we inserted balconies and garden spaces at every single floor. And we enhanced upon that by sectioning the building into 2 portions to create more communal areas that were green. Everyone, when they come to Singapore as architects, I hear that they want to bring the greenery up into the building, but we definitely wanted to embark upon that and bring the green up into the building and make that accessible for everyone. So the site sits in a garden, and we extended the garden up into the sky. There were 3 primary views that we took advantage of when we started the design. We like to think of that analogy as the butterfly to describe the wings and how the building flutters and fluctuates as we move up the building into the sky. That's the plan arrangement. There are 3 apartments on each floor, which are wrapped within the butterfly wings. And within those apartments, we created living spaces, juxtapositioned with bedroom spaces, all connected to outdoor private terraces, submerged within a garden setting. The undulation and the flutter, as we call it, of the butterfly is composed of an AB-AB composition of the floor plates. And as a result of that, you can see that, so a little bit about the composition. The red and the blue shows you the wings that flutter, and they alternate as you go up the building, and the apartments are constant. The flutter of the butterfly wings become balcony spaces and green spaces within the floor plates, and that's how the building evolves as you go up into the sky. From the inception of this, we wanted to make sure that the greenery had an added benefit, and as we all know from what I said earlier in our research, it creates immersive environment for one to be happy and productive, but also locally, the planters have added benefit of tempering the air, acting as a buffer between the noise and pollution, but also creates a tempered emotion against the windows. From the beginning, we wanted to stop from a separated indoor and outdoor space and move to a more connected one. So as you can see, some of the living areas always protrude out into the private terraces, and when the doors are fully open, there is a seamless indoor and outdoor transition. The undulation moves of the butterfly creates a both shaded and unshaded space. And in some areas of the balconies, you have double height volume to lessen the compression of the building. Those balconies always connected to a planter. And the planters varied in depth according to the use internally adjacent to the planters within apartments. To go up the building, we were able to create double height volume, both internally and externally, allowing natural daylight to be brought further into the apartments. There are 195 trees, 50,000 shrubs, and over across 35 different species. And the evolution and composition of those plants and vegetation was very important to us because the behavior of the plants, photosynthesizing from day to night, created a different kind of environment for the people using the planters, or when the doors were open from the balcony spaces between the evening and the daytime. That's the composition of the building, looking from Orchard Boulevard. We use very simple colors and materials so that we can enhance the greenery and emphasize the immersiveness of the green. The building has a very unique crown as you rise it up and has these breakout or double height spaces. And we follow that butterfly analogy all the way throughout every inch of the building. Has a very unique sense of arrival space, welcoming you into the building, that changes its character from day to night. And we hope that that's the building when it's complete. So Michael talked a lot about embodied carbon earlier in his presentation. I won't go into all the technicalities of that, but I would like to touch upon how PLP have been designing these buildings and projects against the issues of carbon and climate change. So embodied carbon, it's very complicated, but we know that it's an omnipresent issue. And at PLP, we have been benchmarking all our projects so that with each project, our embodied carbon is brought down, because obviously we can't stop building buildings, even though it's an intensive process. One of the methodologies that we are looking at, particularly in Europe and London, is the reuse of existing buildings. Because as you see, if you don't demolish the building, the embodied carbon is held within the building. This is a former derelict office building in Milan. This is the finished building, but it looked like this. And we reclad the building, amongst other things, to make it look like this. So the uniqueness of this particular building in Milan is that it lacked a podium and a sense of arrival. So we took the base 2 floors at the bottom of the building, where there was less value, and enhanced it with introducing a double height space, creating a piazza to come through and underneath the building, creating a sense of arrival. And what we did with those loads that we removed from the base of the building, we put it on top of the building. So it's a like-for-like replacement in terms of the structure. We took a very horizontal-looking building and made a vertical reading of it. And where the former top of the building was, we inserted a terrace, which is highlighted by the yellow on the top right-hand corner. We added a serrated facade, and we obviously put those 2 floors back at the top, where you created higher value. And on the flank walls, on the roof, we were able to put a lot of PVs and improve the operation of the building moving forward. That's some diagrams about how we had an existing facade, which is a compressed spatial expression horizontally, had minimal daylight bringing into the floor plates. We pushed the new facade and envelope outwards to create the serration, bringing more light in, and we were able to improve the daylight in those existing floor plates. So that's a technical drawing of how the new envelope was applied to the existing frame. And at the top, we were able to put new construction in and deliver floor-to-ceiling glass on the top 2 floors, where we increased the value of the building. At the base of the building, where we put in a new double-height reception space, we concentrated on using recycled material. So what you see is recycled bamboo. We like the look of concrete in Europe, particularly in London, so we leave it like that. and a lot of the steel is recycled. And all the material were all from local suppliers. Another important aspect to embodied carbon is the operational carbon when we finish the buildings. And in new buildings, typically we start at the bottom. We start with the low reduction. We look at the system optimization. And then we look at the renewables. Now, I know that's very tough in Singapore, but we do that a lot in Europe, where we can thrive on the renewables. But it's complex and challenging, and mostly very, very costly. So what if we turn that pyramid around, and we started off with renewables and what we can do to the new building? Then what that would fuel as a system optimization, and then look at the load reduction of what that delivers. Maybe that cost will come down if we think about it from the top down. This is Bankside Yard, and this is one project, one master plan project, I should say, that actually had that principle from the point when we, on the get-go. This is a master plan next to the Tate Modern. The investors of this, the three primary investors, are all Singaporeans, so if we don't do the kind of renewables in Singapore, we hope to take it elsewhere in the world. It's 8 new buildings with 8 new public spaces and 14 historic arches, which we reopened up as part of the regeneration. It's uses 5th generation heat network system, which reuses the waste heat from the office conditioning, and we use that to heat the hot water and heating for the residential buildings, and vice versa. It's the first UK's major mixed-use development that's fossil fuel-free. And the reason why it does that is that all of the 8 buildings as a collective are all electric because they fuel each other with the waste energy. And it runs on zero emission, but all of the buildings also use optimized systems, facades, and MEP. So almost 55% of this redevelopment is dedicated to public space, increasing the social value and enhancement of placemaking a culture, because it's next to the Tate Modern, so it really, really benches upon bringing people in from Tate Modern and the South Bank. And there's an image of some of the arches that we opened up. Each building has its own dedicated green space, creating micro neighborhoods and communities and life into those arches. The Arbor building is the first office building within the master plan that we've recently completed. And as you can see from this image, we've raised the building up above, and the reason for that is that the building is built over existing railway tracks. But the added benefit of lifting the building up was that we could now put in a activated placemaking, a sense of arrival into the building that integrated with the arches. It's a picture of looking down at the space with the arches to your right, and straight on is the office reception into the building. The building is now Platinum has received a Platinum WELL in certification, and it does that because it thrives on large format glazing. On all of the floors, we have 3 by 3 meter bay windows, which uses a smart CCF system. And 95 of the floor plates are within a 7 meter distance to a window. We have terraces on every single floor, including the biodiversity of the building, and we use a lot of smart metering and lighting and ventilation because it all falls within the philosophy of the fossil fuel-free master plan. On the floors, people have a flexibility to choose to work in an outdoor environment versus an indoor environment. And there's a big communal garden at the top of the building where people can come and engage with each other and share ideas. So all of those projects that I've shown today are some of our PLP's approach to how we approach new buildings in Singapore and also in the rest of the world. Thank you.
Thank you, Tina. Interesting presentation. So she showed us what you can do with an existing building stock as well as a new build and build sustainability, taking care of embodied carbon and operational carbon. Moving on, our next speaker is Matthew Penrose. He's Executive Vice President of Vector Foiltec. He's going to be talking about what is ETFE. His title is How ETFE Delivers High Performance, Lightweight, Structurally Efficient and Sustainable Building Envelopes. Matthew Penrose.
Hi, good morning. Okay, let's jump straight into the technicals. What is ETFE? So ETFE is the lightweight, large span equivalent to performance glazing. An example here is the Oculus, a 12-meter wide ETFE cushion right at the heart of Project Jewel at Changi. And ETFE is an acronym for ethylene tetrafluoroethylene. The key part to note is it's not a plastic, it's a fluoropolymer. Fluoropolymers don't come from petrochemical, and they don't have the problems of UV, sustainability, fire, recycling. Fluoropolymers are the good guys in this equation. Now, it was developed over 80 years ago by DuPont, heavily used in things like the space race, and other industries. And 40 years ago, it was our founders that brought ETFE into the architectural world, and we've been the leaders in that space ever since. Now, the principle is very straightforward. 2 layers of ETFE filled with normal air, welded at the perimeters, and fixed into an aluminium perimeter frame. And it's that air that gives the lightweight properties, high thermal performance, and of course you can have the dynamic and dynamic shapes. Now, an underside view of ETFE often just looks like giant panes of glass. Typically, the only way you see its ETFE is in the corner. You'll see an inflation pipe. But if we did our job well, you won't even see that. And again, from the top side, you tend to see the shape more. The prints for the thermal performance are always on the top layer for maximum performance. And these little wires on top is a typical Northern Hemisphere thing. The ETFE is self-cleaning. The birds don't like to stand on it, so this is just to stop the big birds we have, in especially the Northern Hemisphere, sitting on the roofs. Now, just because it's lightweight, it doesn't mean it's not high performance. Just a cross-section of a perimeter frame. It's airtight, watertight, allows for thermal expansion of the system and the supporting structure, plus as a secondary drainage channel. Now, we do have single-layer systems. My talk's largely going to be on double layer, and this is where you only have 1 layer of the ETFE, and then the pressure that's provided by the air is replaced by having cables, or you have shorter spans. And a good example of this is a project we just finished here in Singapore. It's a new pavilion at Kongmin San Monastery, and it was used primarily really for low maintenance, high speed of installation, and the low carbon footprint of obviously using the mass timber plus the ETFE. Now, is ETFE strong? Now, this is a very old video from 20 years ago when we just opened the Eden project. It's Tomorrow's World and a young-looking Kevin MacLeod. And it was showing that what's unique about when you have a cushion is that when you apply loading on the cushion, it spreads throughout the cushion. Now, if we did this on glass, of course, those point loads would crack the glass, while the ETFE can distribute that loading right across the surface. Now, projects we're most famous for across Asia, of course, is the Beijing Water Cube, currently the largest ETFE project in the world. About 100,000 square meters, and the cushions there are roughly 7 meters in diameter. Most people don't know it's a double layer of ETFE. You've got the ETFE for the building envelope to obviously protect it from the environment and the high pollution they have in Beijing. but also the ETFE is on the interior side, which also protects the structure from the typically corrosive pool environments. And the project you'll be hearing a lot about, this is now the world's largest ETFE structure, King Abdullah's Gardens in Saudi Arabia. It's a picture of the ongoing work, and these little dots at the bottom are actually excavators. That's the size of this project, about 120,000 square meters, but we'll be talking about this more next year. Most famous project in Europe, of course, was the Eden project, the biodomes in the old China clay pits down in Cornwall. And it was, again, a partnership with Seele looking at the structures. And what you have here, you have a low wind load and very efficient structure geometry. So you get these lovely 8-meter diameter cushions. And what that leads you to is very efficient steelwork. Most of us in Vector Foiltec are either architects or engineers, and a big part of our job is to make structures lightweight, elegant, efficient. And I think this is probably one of the best examples you'll ever see is at the Eden project. Just before COVID, this is probably one of the most selfied pictures around. This is Hudson Yards in New York, the biggest private real estate project in US history. And we did the shed, and it's a telescopic building envelope for an event space. And what this allowed was the actual organizers to hold all sorts of different events, but critically, it was the show. The developer wanted to have something very unique on his development. Taking that a step further, we don't just work with engineers and architects, we work with people like Disney Imagineering. This is the Tron ride in Shanghai. And that's a 6,000 square meter canopy. And if you think, what else could do this? You've got this warping shape that has to be watertight, has to give protection from the sun. And then at nighttime, become another attraction, a beacon of light. And what's nice about ETFE, because it's 2 layers, when you point light into it, the light bounces around, and the actual structures at night have this nighttime identity, where they glow. Now, a lot of talk, of course, about low carbon footprints. This was the USA Public Building of the Year several years ago. It was the first LEED Platinum transit station, multiple points of public transport conversion to one building. And the ETFE building envelope here greatly helped on that award for the low carbon footprint. It's the lowest of all the transparent materials. So the ETFE in the day is busy reflecting the heat, cooling the environment, stopping the glare. And at night, just simple LEDs pointing at the ETFE. It's not inside the cushion, it's just on the steelwork, helps that building become a beacon. Now, just going to run through typical uses of ETFE. We do a lot of building facades. This is in Singapore. This is ETFE cushions going about 13 stories high. For the Singaporeans, we are on the product listing scheme for both facades and roofing, so QPs can use our ETFE without seeking permission. And this building is quite unique. It's used for lots of different marketing events and community events. And having these long ETFE cushions really helped this building become quite an iconic space for unique events day and night. Now, some of you might have arrived or leaving, and hopefully you'll get to see Jewel. What you'll see at the center of Jewel is the Vortex, which is the largest indoor waterfall in the world. And right at the heart of it is a 12-meter wide ETFE cushion. And it was the only thing really Safdies could use to make this shaft of light, which came right down through the middle of the waterfall. Also, all the drop-off canopies, about 4,000 square meters there, in between Terminal 1 and Changi, is also all our ETFE. Now, a project you might have heard of, some of you might be working there already, is the Sabana Jurong campus. And it has 3 large ETFE roofs, but what's unique These are cable supported. No steel trusses, 30-meter spans on 20 to 30 mil diameter cables. It's the first in the region. And what you end up with is these incredibly lightweight spaces over the atriums. Now, when you talk about just moving into arenas, the longer the span, the greater the benefit for the ETFE. This was the first stadium to have a fixed roof with a fixed pitch. So the ETFE allowed the full natural grass to grow in a fixed, enclosed environment. We also did the National Stadium here at Singapore. It's a 20,000 square meter moving roof. We worked with Arups and Dragards right from the start to help them save as much weight in the steel structure as they could. And of course, integrate the lighting system to become Singapore's largest flag. And it also lights up to be part of the whole stadium event. And just as you arrive at the sports hub, you'll come under ETFE canopies, which link the indoor and outdoor stadiums and the MRT station. It's so successful, it's actually sponsored by OCBC, and it's used for a lot of community events and marketing events for the stadium. Again, another partnership with Seele. This is to show, because ETFE is lightweight, you can do a lot of retrofits to an existing building without having to do structural reinforcement. So this was formerly Amsterdam Arena, and it's changing the shape from concave to convex and making a new sort of window to the sky. Now, can we be used in high wind load conditions? So this is our latest project in Manila Bay. And any of you working in the Philippines know the code now is the roofs have to withstand 300 kilometers per hour winds, and then you've got seismic and all sorts of other problems. This is the first concept of having naturally ventilated, naturally lit public spaces between individual shop units. That was our little model at the end. We also worked with a company called MEL in Malaysia, who did all of the wind studies for us, and we incorporated that into our design. And we're happy to say these are recent pictures from the site. No trusses. One thing we hate is trusses, but in high wind load areas, that's typical. So our lightweight engineers pulled off some real miracles here to get the large spans working. And we were just playing with the lighting options on the mock-up there. You can imagine if that whole street has got all of this lighting moving on, it'd be amazing. Singapore, we do a lot of public spaces, so Tampines Town Hub rebranded our Tampines Hub. Again, a massive venue, ETFE right down through the spine of the building. We do a lot of leisure projects where you're trying to enclose the spaces, and again, a lot of these are with glulam to have that sort of low carbon footprint, low maintenance projects. Everywhere you go at Resorts World, you'll be walking under ETFE, including Universal Studios, where the ETFE is being themed. And of course, just simple lighting. There used to be a show on called a Fountain, Lake of Dreams at Resorts World. And one of our latest is in Hong Kong. Massive loadings. Whenever you deal with Hong Kong building department, you're going to have a lot of problems. We were in charge of the steelwork as well. And again, we were able to put in a long span roof without a truss. Really took a lot of effort from all involved. With 40 integrated smoke vents, again, a big part of our roofs is about trying to make them as architecturally pleasant as possible. So when everything closes up, you just see a beautiful roof of ETFE. Education, this is the largest preschool in the world. It's attached to the Australia and Stanford International Schools. You might have driven by it 100 times next to the CTE. Every single outdoor space is covered with ETFE. And again, we had to make it to the Australian standards of low UVA, UVB to protect the children. Again, lots of public spaces, Paya Lebar Quarter, and just really ramping that up is these massive malls that we do in the Middle East where you have sandstorms and all sorts of conditions. Those also include in Malaysia. This is the Aspen project up in Penang, this giant wavy roofs, and the latest in Malaysia. This is Pavilions 2, essentially. If you go to KL, I'm sure you've been to Pavilions. This is the new Pavilions on the outskirts, the 7,000 square meter ETFE roof they use for car shows and events, every outdoor event you can think of. Now, technically, how does this work? Right at the center, there's this small little white box. That's an inflation unit, and it's inflating all of the ETFE in the picture, about 1,500 square meters. We inflate the ETFE, the system turns off. I had 20 minutes, you dropped it to 15. I'll be quick. So our systems are fault tolerant, so they have electrical, mechanical backups, and 2 different motors. We have unique printing on the ETFE. Those prints, of course, can be changed in intensity and geometry, and that will change the thermal performance, and we have all these different tables giving all of the different solar heat gain and UV and everything you need for the design of your roof. We can also have color. Our roofs have been around for 40 years. Our earliest roofs we've took samples off, mechanically and chemically, they haven't changed in 40 years. They didn't age. But of course, the pumps at the center have to be maintained, which we offer. The ETFE is self-cleaning. And in fire, fluoropolymers are extremely well behaved. What's actually happened here is the ETFE has moved away from the fire, self-extinguished, no smoke, no dripping, and opened up a smoke vent. So in 40 years, 0 problems with fire with ETFE. And as I said, we're on the product listing scheme. We are the lowest carbon footprint. We are recyclable, the most sustainable, transparent system you can use on a building. I quickly want to run through what we've done at Clarke Quay. A lot of work here enhancing Clarke Quay, which I think we should all be familiar with. This is the team we're working with. There's 18 Angel roofs, original design by Will Alsop, about 10,000 square meters of ETFE. And what's changed is the old Liang Court on the left is now being replaced with Cannon Hill Piers. So now Clarke Quay has to change from a nighttime venue focus into a daytime and nighttime focus. So they have to enhance all the thermal performance. So we did a lot of work with Atelier 10 and Capital Land. Where should we put mock-ups? Right through the middle, where you're seating in the midday sun, we're putting in a much darker print on the ETFE. And the single layer on the perimeters, we're having slightly lighter print just to keep the overall light transmission high, but that morning and evening sun you're protected from. This is the prototype that we put up. And if I show you, let me just go back a second. What actually happened on the prototypes is even though the ETFE was darker, we had a better connection with the sky. By taking away that print, you could see the clouds and the blue sky better. We put in remote operating systems. So we've been actually measuring the performance for a year. Now, the first thing we did when we're upgrading the system, the ETFE is taken down using boom lifts, safety nets put up. Everything has to be remeasured. Never believe 20-year-old as-built drawings. The material comes all prefabricated, and those boxes are then reused to take the old ETFE away for recycling. Again, we had 360 on the material. All the steelwork is then checked, repainted, made beautiful. Aluminium frames installed, all on the nets. Prefabricated ETFE is fixed in, inflated. Quite sure. And that's it. Thank you very much.
Thank you, Matthew. Any questions on ETFE? You can ask Matthew and his team. They have a stand outside like other sponsors. Okay, moving on. Next, we have Andreas Geyer, who's the Managing Director of Seele in Southeast Asia. He's going to be talking on complex 3D shape steel and glass structures. Over to you, Andreas.
So, good morning, everybody. So we all know that Southeast Asia is still an extremely price-driven market. So today I'm going to the other side of the planet, to New York, to look at some projects and to what extremes the clients are going there to fulfill architectural visions. So first, some words about Seele. We are a German company. We were founded in 1984 in Gersthofen in Germany, which is close to Munich. And I think I can say we are the world leader for complex cutting-edge steel and glass constructions nowadays. We are here, our subsidiaries all over the world. We are also represented in Australia. John Haralabakos is sitting behind there in the audience. So if there are any questions about Australia later, you can discuss with him directly. So what we are doing, I would say it's business as usual, but what is maybe outstanding on Seele is that we have a very, very strong R&D department as well. So we are looking deep into new technologies, also into decarbonization, etc. So this is where we are definitely outstanding. Here are some projects. On the left-hand top, you can see Chetstone in Melbourne. On the right-hand side, the Iconceum in Bangkok, which we finished in 2018, I think. Our partner of these days is also here. Kun Anapat is somewhere here in the audience. Very nice to see you. Then we do cable truss designs. That's on the bottom left here. That is also Iconceum, the Wisdom Hall, and we do unitized facades. This is the European Central Bank that you can see here. But we don't offer unitized facades here in Southeast Asia. We would simply not be competitive price-wise. So we are focusing here very much on special constructions. So let's go to New York, the 33rd Penn Street station entrance there in New York, and let's have a look what is behind the construction of this design here. So here are some basic images. We have 105 tons of steel, 277 square meters of cable net. It's 13 meters high, and we have 139 anti-clastic shaped glasses. We will come to that. Here you see the different elements of this construction. We have six steel elements, main steel elements here. We have the cable net and the glass decking. The steel here is fixed by saucers that are holding the glass in their corners. Not too long ago, or you still see them today, we had the typical point fixing in the glass, where you had the drillings in the glass, and actually Seele invented this kind of fixing here already in the late 90s, where we used it in an airport in Germany, in Cologne-Bonn, where the spider was first 45 degrees turned originally with the holes in the glass. Then we turned it 45 degrees, so the fixings got in the joint between the glasses, and then we shrunk it together to the scissor that you can see here. Let's have a quick look into the steel fabrication. This is here in the Czech Republic. This is where Seele has its cutting-edge factory for very, very complex steel constructions. Here you see the manufacturing of the edge beam and edge beam component. And here you see some of the spandrel panels that are below the glass constructions within the entrance. Those spandrel panels are all 3D shaped. They are not just curved, they are also twisted to a certain degree. And to the right-hand side on the background, you can see one of these huge hockey keys, we call them there, that are going up then in the construction to the crown. Here you see the manufacturing of the crown itself. The holes on the left-hand side you see in that crown, they are used to fix the cables and to tense the cables. We will come to that later. And on the right-hand side, you can see the crown in its finished surface-coated condition. And you can also see from here that this is not so much maybe typical facade engineering. This is already very, very close to mechanical engineering, what you're doing there. Let's have a look at the testing and pre-assembly. Of course, we are doing the typical glass testing here. On the right-hand side, you see one of these anti-clastic curved panels there. That's a permanent load test that you see here. We have also impact testing and so on. This here is a very interesting one. You can see that massive bolt going through these two steel components. So we need to have a very specific clamping force between these two elements to later connect these steel components on site. So what we are doing here on the left-hand side, you see a hydraulic cylinder fixed to that bolt. There's an inner thread in the bolt. So we are fixing it to that bolt, and then we are extending the bolt exactly as much as it needs to be extended to provide the clamping force between the steel elements. And then after this extension is reached, then we just fix the nut, and that's it. Then you know exactly that you have the targeted clamping force between these two steel elements. Here now you see the test build-up. This kind of constructions we normally do as a test build-up in the factory here in the Czech Republic. And you see it, I mean, it's 13 meters high. That doesn't sound too big, but when you see it in real life, it's a massive construction. So on the right-hand side, on the left-hand side, you still see the non-stressed cable construction. On the right-hand side, it's already pre-stressed. So here it is extremely important. In New York, you don't have a lot of time for installation. Everything needs to go super fast, so everything needs to be prepared perfectly. So on the right-hand side, you see the pre-stressed system with these nodal fixing points there already, and all the cables are marked exactly in the right position. So we use a 3D laser tracker to determine the positions of all the nodal points. And then when we pre-stress the system, we are already marking each of the cable clamps on site to know later, when we install it on site, exactly the positions of these nodal fixing points. Now here you see the view from the ground downwards, and what you can also see is there the tensing of the cables on top, and in each cable there is a sensor inside, and this sensor can tell us exactly the stress in the cable. And this is still there in the final project, and we can read the data live in Germany that are provided by those sensors in this cable thing. So what the advantage of that is also that when we install the whole thing, we can know exactly what stress do I have now in each of that cables, so we can make sure that the nodal points which are marked on the cables are exactly on the right position. So we cannot start playing with tension forces on site anymore. All of that needs to be clear before we arrive for installation. So here you see this the computer with the measurement tools inside and the software inside to see the tension forces in the cable given by the sensors there. And of course, this also enables us, in case of earthquakes or whatever happening there, to see what is the actual condition of this whole construction, whether everything is right or whether there is an issue and we have to readjust the cable tensing force, and so on and so forth. So let's have a quick look into the installation. To the left-hand side, you see that hockey stick coming in. Then after the hockey sticks are installed, the crossbeam is coming in. Then we put the crown on top of that. Here you see now on the left-hand side again the process of the cable pre-tensioning, and then the glass installation is starting. And here we are already installing the last glass panel and these 3D spandrel panels that I showed you in the factory in the Czech Republic before. And later, New York then was putting a print onto that, which is giving you a New York City map. It's laminated onto these steel elements in the entrance. So this is the final product then. And on the bottom left-hand side, you see that red dot with the structurally most challenging point. That is exactly where we were using this pre-stressing of the bolts that I showed you before, where the steel components were connected to each other. And you can imagine what forces occur in that area there. Let's have a quick look at a video, the making of it. Czech Republic. You see the complexity of the 3D elements here. as I mentioned, is more mechanical engineering than classical facade construction. Obviously, a lot of milling involved. Installation process in Pilsen. So, now let's have a look at the second project in New York, the Moynihan Train Hall. You can see here 5 glass roofs, and this is what we are going to talk about now. Finished in 2020. 5,000 square meters of freeform steel glass roof, 3,384 insulation glass unit, and 670 tons of structural steelwork. Interesting regarding carbon footprint here is that the glass sizes here were determined to minimize the wastage. That played a major role in the determination of all this design and the sizes of the glasses, minimum cutoff of glass. So on the left-hand side, we are again now in the Czech Republic in our steel factory. You see one of the painted steel letters fabricated there. Then the aluminium works were all done in Gersthofen in our headquarters, close to Augsburg. You can see all the components, of course, have individual ID numbers, etc. On the right-hand side, you see the Kanban system where we all pre-assemble the stuff. First, we have 0 repetition in the whole project, you can imagine. So all the components are collected there and then pre-assembled. Here, a quick view into the pre-assembly of the whole thing, the connection of the frame components with the glazing. Then here on the left-hand side, again in the Czech Republic, the ladders are prepared for transportation to New York. And also on the right-hand side, the aluminum glass elements are going into wooden boxes to be transported to New York. Then here on the left-hand side, we are already in the installation now in New York. You see the scaffold, respectively the propping of the whole construction, the installation of the first ladder of the mid-block, and then the completed ladder installation on the right-hand side. And here we go on with the glazing on the mid-block. You can see on the right-hand side again the pre-manufactured aluminum glass elements. They are structurally glazed actually, and they are relatively complex because a couple of them is also 3D shaped. You will see that later on some more pictures how here on the left-hand side you see the glass is having a smooth surface from element to element. On the others it is, I don't know the word in English now, but you will see what I mean. So here the finished product, and let's have a look a bit in the technical background of it. For the structural system, as you can see, the dome itself is extremely high here, so it's not self-stabilizing. So in order to stabilize it, we had to introduce for each of those shells here 3 spider cable elements. That's what you see on the right-hand side here in red. And then we come to the testing. The testing here plays a major role for that project. You see the test mock-up being done here in Gersthofen in our headquarters. We had a testing sequence here of 5 months testing to run through before we could give the go-ahead for production, and then finally installation. So you can see what kind of testings we are doing here: load-bearing test, thermal cycling, condensation, air tightness, water tightness, static and dynamic load-bearing tests, asymmetrical loads, load-bearing of connection points to the building structure, and 150% load-bearing tests. Here just a quick look into the thermal cycling. This is something that we can be very happy about here in Singapore. We don't need to do these temperature extremes, or we don't need to test them, but you can see here we are having minus 18 degrees to plus 66 degrees. That is quite a difference from winter to summertime here. So all of this needs to be tested. It needs to be checked that the whole construction can survive it without any mechanical damage, because that's quite a delta T we are dealing with here. We do 3 cycles. We do the condensation tests here. with outer temperature of minus 18 degree and an inner temperature of 21 degree. We have to be sure that the critical dew point is not reached, which obviously was not reached then. And then we had the measurement instrumentation here is 70 temperature and humidity and temperature flow sensors and 10 displacement transductors. So here you see the casing we had to build for that, since we had to simulate the minus 18 degrees on the outside. So that is also happening now in Germany. So you can see also a separate control, of course, of the inside of the mock-up is necessary, outside and inside. And here you see the generator on the left-hand side. Here, everything is frozen. We are using nitrogen for that. And then the thermal cycling tests are done, and they are permanently monitored by infrared cameras, obviously. Condensation test on the right-hand side. Then the wind pressure test is coming here. We do 2 wind pressure tests, actually. Air and water tightness static and air and water tightness dynamic. Here are some pictures of the testing. You see the propeller simulating the wind together with the rain simulation on the right-hand side. And here we have the final product then. So you can see these clients go really to extremes to make their architectural visions reality there. And let's have a quick video of that as well. That's the headquarters in Augsburg, Germany. The design process, everything in 3D, obviously. All the components that are used with their individual IDs. Assembly in Augsburg. A lot of aluminium welding, obviously, here also necessary. Now we come to the structural glazing process. Czech Republic again. The pre-installed ladders. Finally, the glass installation. Here you see the glass surface is not really smooth between the elements. Now one element is higher than the other. Extremely complex 3D structure. And the sealing process. So that was a quick look into our activities on the other side of the planet. And I thank you very much, and we can talk in the break later. Yeah? Thank you.
Thank you, Andreas. I think now you all know where to go for your complex project needs. We'll take a break, 20 minutes. Right. Moving on to the next topic, we have a unique material, which is fabrics, which can be used on the facade. And we have world leaders for the same. Serge Ferrari, the General Manager for South Asia, Mr. Arun Madappallath, will be speaking on using tensile fabrics for architectural applications, especially the building envelope and the building facade. Mr. Arun.
Yeah. Thanks, Ahmed. Good morning, everyone. So we are happy to announce our 50th years of manufacturing flexible composite membrane. So this is a special year for Serge Ferrari. I will go through the presentation. So Nitin Govila, the Managing Director of Asia Pacific, Middle East and Africa, was supposed to do the presentation, but unfortunately he could not join, so I have to fly in to do the presentation. And we have Kelvin. He is a Sales and Specification Manager based in Singapore, looking after Southeast Asia market. And myself, Arun Madappallath, General Manager for South Asia for Serge Ferrari Group. It's a small corporate video about our group. Develop, manufacture flexible composite membrane for light architectural systems. We are world leader in 4 strategic markets. Tensile architecture, this is a key market across the world. Modular structures, wide span 10. Solar protection, internal, external, blinds, awnings, canopies, and furniture and yachting applications. So this is about our company. So we'll go to the subject, today's topic. So of course, our CSR plus is equal to 0 is our approach. We already covered these 4 markets where we are present in Serge Ferrari. So why fabric as a facade? So this is a topic which we are discussing today. So we have different key points to cover. First is thermal insulation and visual comfort. As you can see, the membrane can be used as a secondary skin or a primary skin of a facade building of a facade. The advantages is that outside visibility is really good. We have 30% openness to 55% openness factors. Thermal comfort, since heat is cut outside the building, you will have good thermal comfort for your working atmosphere, glare control, and natural light inflow. So about natural light inflow, as you know, the working environment or your living environment has to be really comfort and well-being. So this fabric can be give a best option to have the natural light inflow. So natural light into the building. Then the second chapter is unique identity of your structure. So with fabric, we can do different possibilities. You have 3D designs. As per your architectural visual requirement, you can build the facade accordingly. LED can play an important role in the building, and textile printing possibilities. So LED lighting, the uniqueness of the building will appear when you have a different LED lighting possibilities. Then 3D designs and textile printing. So printing is possible. We have a special varnish on the fabric to give you a special printing performance. So the next chapter is energy savings. So there are two possibilities of use the fabric internally and externally. As you can see here, if you are using the fabric internally, the light or the sun is hitting to the glass and then to the fabric. So, but if you are using the fabric externally, 80% of the light or the sun is cut outside the building so that you will have good thermal comfort while the fabric uses external skin. And you will have a good performance for the HVAC as well. So this is a case study, Southby real estate project in US. So the fabric facade, actually the original building was without facade and there were a lot of issues in the building, a lot of heat coming inside. The HVAC consumption was very high. So we have proposed a solution with the external fabric solution. And after the erection, you can see that the building appearance has changed and a lot of savings in the energy. So you can see that before and after how it looks, the building, when you use the textile facade. Okay, so we comply all fire codes, international standards, and Singapore standards. We can give you more details about fire performance in our booth. And we have two types of fabric. One is made of glass yarn, coated with PTFE, which is a fire-resistant fabric, because basically the glass yarn is non-combustible. And then we also have PVC, PVDF coated fabric, which are flame retardant. Okay, it's a self-extinguishing fire properties it has. And we follow all international standards. Just a comparison between conventional system and the fabric system. As you can see in the picture, your outside visibility is not blocked. The fabric is used externally. Lightweight, because fabric is lightweight, it's less than 1 kg per square meter. With the system, it will be really a lightweight structure when you are using the fabric. And conventional system, the visibility is not as good as the fabric solution. So some also possible is the retrofit and renovations. You can see that in this project, before and after the fabric system is installed. This is before, and you can see after the complete architectural feature of the building has been changed when you use the fabric as a facade external application. So a few examples of renovation, retrofit or renovation. Okay, so cassette panel construction. This is an Airbus project in France. Okay, fabric has been used as a three-dimensional structure outside the glass. A large panels possibility because of the lightweight nature of the fabric. And you can see the internal, the light coming inside. It's not blocking the light and not blocking the visibility towards outside. So you can create a unique workspace for your, working environment. This is Burj Al Arab Tower, constructed 25 years back. You can see that the white structure is PTFE, glass fiber PTFE fabric. You can, after 25 years, still a very good functional membrane. And this is used as a light projection during the night. So this shows the longevity in harsh climates as well about the membrane. Okay, monolithic construction possibility, German pavilion, more structural support system. We have different types of fabric facade, breathable mesh. So breathable mesh is 20% openness factor to 50% openness factor possibilities are there. Then we have opaque waterproof fabric, which was you have seen in the Burj Al Arab project. Then we have high translucent waterproof fabric possibilities. And then the final one is the transparent single skin possibility as well. So this is a new development from Serge Ferrari, very strong fabric, type 2 fabric, with a good strength of more than 4,000 Newton, 4,000 Newton per 5 centimeter. The advantage is that this transparent skin, the outside visibility is as good as a glass. So multiple fabrics we have to choose from: resistance to weather, good mechanical resistance, low maintenance, color fade fastness resistance, resistance to all weather, and finally design support. So Serge Ferrari Group now, so these are the product portfolio. We have PTFE mesh, 21% to 52%, 10% openness factor, then the PVC coated material from Serge Ferrari. And the final one is STFE. Serge Ferrari has in-house designing support, engineering support now. We do the rendering, design model, GS drawings, and connection details. So whenever you have a project, we can support you with all the engineering support. Systems, yes, we have a tie-up with a company called Facade Textile International. They have a different system. You can find it in our booth. Different types of profile possibility. The profile can start from 4 square meter to 60 square meter panel construction possibilities, single panel construction possibilities with the system, suitable for 3D designs, and wind resistance up to 250 km/h, which is tested, and very cost-effective solution. We have certification, environmental product declaration. Then we have Green Guard compliance, gold certification, LEED certification as well. Key projects, hotels across the world. Then key projects, offices, culture centers. So you can see all are different and unique in its own design. Education sector, and stadiums and sports centers. So we have done many stadiums across the world for the roof membrane as well as for the facade membrane. Car parks, multi-story car park, it must be open car park, so you can have a fabric facade solution for the multi-story car parks, printing possibilities, LED lighting. Locations, we are present worldwide. Our factory is in Laterdoupan, and we have a factory in Krefeld in Germany, and representative offices worldwide in Serge Ferrari Group. So that's all from my side. Thank you. So if you have any questions, please come to our booth, and we can assist you. Thank you.
Thank you, Arun. As he said, Ferrari have a booth outside. You can see the products and the samples over there. Another lightweight material. Our next presenter is also going to talk about a lightweight solution. Thomas Fruhmann, he's from Schueco. He has a new designation now, which is a technical brand ambassador for G2S, which is the grid-to-shell product. Again, another lightweight solution. Thomas Fruhmann, over to you.
Good morning. Yeah. So when I arrived in Singapore yesterday, we had brainstorming with our colleagues how to start the presentation. And we said, I had my traditional way of starting the presentation. And then my colleague said, no, just you need to catch and engage the audience. So why don't you throw some pictures at the wall? So I did both, the best of both worlds, because I said good morning, and in the background you see some pictures of work we do as Schueco in what we call the pre-construction service on a product which I had already told you. Now, if you see those pictures, what material would you associate with these type of constructions? Probably material Andreas was talking, and their product is really, really amazing. However, we at Schueco, we have now a product, and it's not steel. These structures are now possible to be done in aluminium. Because, and why? Because we are an aluminium company. And what you're going to see is this new product and how we have applied it, and some technical, let's say, details around it. And yes, and on top of that, we have heard from Michael at the beginning, carbon footprint and all these things. And again, this product, since it is aluminium, we have done that study on a project, it does actually save you carbon emission. Due to many factors, and as Michael said in his first speech, you need to be very careful of how you're going to calculate, not calculate, but what is the basis of your calculation. And if you compare something, you need to always know what is the basis of the comparison. So in that case, we compared our aluminium, 100% aluminium structure with and usually typically a steel structure, where you have much more weight. You have hot works associated with it. And if you look and if you take all these things into consideration, you actually save with our product not only on CO2 but also on costs. And why that? Because the speed of installation is also much quicker, and all your lifting and site logistics are much lesser. As a company globally, what we aim for is that we have our carbon CO2 emission cut by 30% in 2025, disclaimer, based on what we did in 2018. And by 2040, we as Schueco want to be full carbon neutral. So I think it was 2021, we were under the top 5 in sustainability ranking from EcoVadis. So just to give you a brief about the company. Now, going in medias res, as the Latin-speaking community amongst us would say, we thought about, if you think about free-form structures and how to make it more accessible for the wider design community and clients. So what if we had a system? A system for that. A system that is parametric, a system that is versatile. Obviously, if it is parametric, it is versatile. It is out of aluminium, and you can recircle it in your in the life of the product. It gives you, because it is parametric, it gives you freedom of design. So you are free to do whatever design you may have. It is easy to fabricate, because that is another thing. You know, we as a system manufacturer, our clients are our customers actually are the metal fabricators. So we actually need to think of how can we help them? How can we ease their fabrication? So it's easy to fabricate. It is easy to install, another thing. And why is that so? Because it is lightweight, and you can, in fact, pre-assemble modules of it. So it gives you also this kind of flavor of modularization, unitizing systems to a certain extent. I mean, obviously, if you think that on a 30,000 square meter roof, I mean, you can't have it like a unitized curtain wall, but you can pre-assemble things. And with all these advantages, also, it is cost effective. Why so? Because time on site spent is very expensive. So we thought, what if we had a system that goes from the grid lines of the designers to the structural shell of our engineers, from grid to shell G2S. And that is the product Schueco has developed over the last 3 years. Not only developed, we have implemented it on projects. It is globally already implemented on 150,000 square meters. And yes, the actual global launch will be on the BAU, which is the biggest construction fair in Munich next month. So what does the G2S include, or what components we have. We have, obviously there is a design aspect to it. After designing, so we start with creating a mesh, or not creating the mesh, we take a surface model. If it is freeform, we take any type of digital surface model, and we create a mesh. And from that mesh, once the mesh is approved, we then start to model the whole 3D of the structure. And after modeling the 3D, it starts to generate the components. The components are the nodes and the rafters. And because, as I said, we are also looking to make it easy for our customers who are the metal fabricators, the design is done in-house with Schueco. So we do the design, we do the structural calculation. We do have as a handover point the reaction loads of our system to the structure, wherever they may be. So for example, if there is a perimeter upstand, a perimeter wall, a ring beam, whatever, we have the reaction loads on that vertically, horizontally, depends on the shape of the construction. And if we have something with supported by tree columns, we also do the design of the tree columns, because we don't hand over on top on the branches, but on the trunk of the steel trees. However, we don't produce them because they are of steel. Nevertheless, we do the design completely. Now, the nodes, and this is something I think all of architects and designers and even clients would appreciate. The nodes are milled out of aluminium. And because of that, aesthetically, they are quite extraordinary. You will see that you will have one sample out there. So what have we actually done? We have combined, traditionally, if you go for big spans, you would have a primary structure, and then on the primary structure you go with a secondary structure, which is aluminium add-on system, or you put a stick system on top. What we have done, we have combined those traditional two elements into one, and have developed an extrusion, and with that extrusion, this extrusion is a different alloy than your 6063 that you usually use for curtain walls or unitized systems. It's a more high strength, it's tempered T6. And then the next the component is the aluminium. So since we mill the node out of solid aluminium, we can what we call it star-shaped. And what that does is actually you see the arms, the rafters going to the nodes, yeah, and you can't from a distance even distinguish where the node is, because it looks like a star. We grave all these things out, and because it is aluminium, it has an additional advantage, because you can powder coat. If you do it in steel, you always would have the issue of not issue. It's you need to use multi-layer coating protection. Here it's powder coated, it's the same color like on the aluminium rafters. It's and the node, since it's milled, it always looks aesthetically the same. So the node itself can be very individual, but aesthetically they are looking the same. Testing. It is a system, we are a system house, so for us testing is essential. And this system has been tested up to 4,500 Pascal. And testing, why is testing important? And the previous slide you saw is our testing facility in Germany, which is the biggest in-house facility, testing facility in Europe. It's like 30 meter wide, 18 meter high, and you can test either one sample of that size or multiple samples at the same time. And why is testing so important? Because what we have learned is that you need to test a system to, and Andreas had it very beautifully in his previous presentation, you need actually to test what you're going to build. So if you have a system and you're going to apply it vertically, you need to test it vertically, horizontally. This system has both. So you need to test it horizontally and vertically, just in order that you understand that the system is performing under the same circumstances as it will be built in. Now, it can be glazed. We have seen it in the beginning. We started from that system to be parametric and fully glazed. However, we also use this system in many other applications. For example, structures. We have a project done where the architect intention was, it was a shopping center, he wanted to have this courtyard with alfresco dining, so outside seating, and he had this structure spanning over this courtyard. It's like a horseshoe, and he had steel and glass in his mind for the shading. And when I talked to him, he said, okay, glass, you know, if you want to get it shaded, you need to make it printed, you need to design the print pattern, G value, all these things. So then we said, okay, why steel and why glass? And the previous speaker, Serge Ferrari, so we used their product, which we have as a facet, and we implemented fabric on that structure. So what our designers or technical department, technical backup office did, they took the facet system, again a system of Schueco, and combined it with our G2S system to something new, to where the G2S system is actually the carrier for the fabric. And this is the rendering, and this is how the project actually looks after being finished. Now, you're going to see how happy the client was on that job.
At Schueco, we strive to provide our clients with the best possible technical solutions, and our latest innovation system, Grid to Shell, or G2S, is the epitome of aluminium engineering. Clients' and architects' free-form geometrical desires can readily come to life. The complete parametric aluminium skylight or facade is designed and engineered in our 3D software in a fully digital process from concept design through to fabrication.
Now there should be the layover of the voice of the client, who was very happy actually with that product, because it was the first time a 100% aluminum structure of that size for a single layer structure was implemented in UAE, in Dubai, and yes, Dubai being the city of the firsts, he was very pleased with that. Yeah. Yeah, I have to a little bit rush because there are some more slides, and this is why I'm speaking very quickly, because there's a lot of content I want to get across to you. Installation. I said, you know, in the beginning, one of the key advantages is the installation, the method of installation. Why is that key? Because we are talking aluminum, we are talking lightweight, we are talking, as I said, you know, you can pre-assemble things. Now, traditionally, if you would do big span skylights like that, you would have in steel on the right side, you know, you would have checked up a temporary platform, and from that temporary platform you would work. Crowding the access, for example, if you think of a shopping center, crowding the access at the ground level. Now, here we pre-assemble. So this is a part of a method statement which we developed for a project, where you can see we pre-assemble parts of 200 to 300 square meters, and we lift them into place. 200 to 300 square meters are quite easy to lift with that product, and you only need a very small lifting arrangement, nothing big, nothing heavy. And here you see one of the skylights, you know, being pre-assembled on the roof and then lifted in place. Now, if you think about doing the same, and one of the key advantages is we can use actually the tower cranes that are on site. And you know that tower cranes, they have a limited lifting capacity, so you are actually happy if you find a tower crane on site with a reach of 80 meters and a lifting capacity of around 4.5 tons. Now with 4.5 tons, we can actually lift quite substantial parts of our system into place. Yeah, and that gives you a speed of installation. It actually also, and this is part where it starts to reduce your carbon footprint, because no heavy lifting equipment is required, and so on. So all these things add up in being a very competitive product by all means, and wherever angle you look at. And if I get a bit of my passion of that product to you, then I have achieved everything I wanted to achieve. Now, we have done spans of 40 meters, 45 meters. We are now implementing in Saudi Arabia a project. We're actually 2 projects, both of them 30,000 square meters, with the biggest span on one of those like 48 meters. The biggest single dome we have lifted in place was 1,000 square meters. It had a diameter of 34 meters. We assembled it on the ground, and then we lifted it up in its final position on top of the building. As I said, it's very versatile. Facades, you can make, we did parametric facades with it. This is why we have 2 types of openings. So if you see outside, the model has an opening on the side. However, on facades, vertical applications, we can actually open the system, and this is what we do, through the front, where we have the gasket and there's a special cover. And so you don't see the access to the system, because it's all screwed, nothing is welded, it's all bolted. And usually, I mean, if for the side, if you have a skylight, we make a side access window. There is a cover. Now we have a cover that is extruded aluminum, so it slides in. It's spring loaded. Very neat, very easy. Yes, vertical application facades. It can be a facade. It can be a roof. It can be everything in between, and all these things without the need of having having the need of a support. And we also do have pedestrian bridges developed with it. Yeah, just concluding on that, fully parametric, gives you freedom of design, and still it is a system, but defying the boundaries of a system. IOF. I'm not sure if you have heard about it, but it is our Internet of Facade. So what traditionally on the left side you see a window. Now with IOF, your window becomes not smart, because the windows are already smart, but it becomes your source of information. So all the information you wanted to associate with an element, with all the elements on your facade, on your building, you can put through IOF to that thing. Be it the time of when it was produced, the last time it was serviced, which glass there is in. You can put the drawings into it, and it can be read by a mobile phone, by whatever device that has NFC, or you have a QR code. So all this information is where the window, where the application, where the door, where the facade is, and you can read it on spot. And all the documentation that you want to have there, you can get out of that, which is very important, for example, for maintenance people, but also if you need to change a glass, you don't need to go somewhere in your archive and see what glass was in there. You can actually put all this information into the IOF.
Digitalization is changing how we build, but the vast majority of building management is still analog. With Schueco, Internet of Facades, and now our IOF ID, we can leave pen and paper behind for good. Windows, doors, and sliding doors will no longer be independent elements, but rather links within a digital network of buildings, turning cities into smart cities. Schueco IOF ID is a small tag with a big impact, giving one access to all the relevant product information and making mountains of specification documents a thing of the past. Storing this info digitally saves time, space, and money, and ensures maximum transparency. With IOF, building maintenance is more efficient and sustainable. Which handle was installed? When was maintenance last carried out? How can old components be recycled? All this information is available in the digital twin. It can be tracked anytime, anywhere. For clients, investors, and facility managers, this means more data and ultimately greater control. The future of the digital building envelope starts here with the new Internet of Facades ID from Schueco. For facades that can do more.
Yeah, now we have seen the big things that Schueco cares about, but the really amazing about this company is also the company cares about the little things in our industries, the little things that probably other people don't have the time to look at. And yes, we know it's not a door, so I don't need to explain that to you, but the message is important that sticks on that window. It says, don't open it. Now, why has that happened? One of our employees came to the office and was met with that situation. And it is a situation that we know is all around the globe. Wherever you have the urge of having outward opening windows. And we know that, not many people talk about it, but our top management has said, okay, if there is something like that, we don't want to be on the wrong side of such a catastrophe. So guys, develop something, do something. What can we as Schueco do to make that industry more safe? So now, where do you start with something where there is no standard for? So you have to develop it. So we pulled our brightest minds together and said, okay, what is the real world scenario in that, you know? So you have winds, the wind will come, if it fails, it will swing, and then it will dangle on whatever it's catching. So now we have identified these three main things, and then we had to find logically what kind of tests could be done with that. I got 1 minute more, probably I have another. Aha, I just said before you bounce the bell. Because my aim is not to get the bell, and I achieved it every time. But okay, so we had to develop a drop test. So obviously first you make a structural test that the cable is going to be strong enough. So once that component was designed, we had to find, okay, how do we test the thing if it is failed? So we made a test.
380 kgs. Start.
And so where we let the window or whatever, the thing mimicking the window dangling on that, then we had what can cause a sudden the sudden jump of window out of its frame. So we had to develop a test, which we did. 4.5 kilopascal suction and then sudden release, and then it behaved like that. So the window bounced out and it hung on the rope. And after that, after having the window blown out, having it hanging for a prolonged time, like I think it was 48 hours, then we did the test for, because there could be still wind gusts if that happens. And yeah, this is the little device that came out of the whole thing. And I find it very, very helpful and smart, and it also shows you the ability of this great company. Takeaways of today. G2S, your free-form structure You can offset even your carbon emission with that. IOF, the little tag that makes your smart window even smarter, and the safety restraint. And with that, thank you.
Thank you, Thomas. That was informative. We'll move on to our next presenter, Nicolas Medrano. He's a design principal at SOM. He's going to be talking on rehumanizing our built environment. Over to you, Nicolas.
Thank you. Great. Hi, everyone. Nick Medrano from SOM, part of a growing, small but growing Hong Kong office. I come from New York, but have relocated recently to Hong Kong to build our studio. I've had the privilege of working here in Asia Pacific, largest and densest cities for almost 15 years, on a wide range of projects, and you see a few of them on the screen here. And today I'd like to talk about what we call a rehumanizing of our built environment. I'd like to open with a simple concept that life will find a way. Upon arriving here in Asia Pacific, I've become keenly aware of the constant struggle between nature, humanity, and our cities. From the barrage of summer monsoons and fall typhoons that force us to shut our windows and sandbag our doors, to the Chinese banyan reclaiming its territory in every other city block. Before man's ambitions to rule the natural world, our instincts as a species were to tread lightly. Not only did we have a low carbon footprint, but we lived with minimal physical footprints. We found ways to create tightly knit communities, to live off the land, to take only from it what we needed. We allowed nature to occupy our spaces. Our houses, communal spaces, and village squares were permeable and adaptive to multiple needs and uses. This pictogram of Old Shenzhen in Hong Kong illustrates the vibrant mixed-use nature of our former communities, where our structures were intertwined and interconnected. Open shop fronts inviting community to take part in daily life, noodle shops next to workspace on top of art studios, the smells and sounds of community permeating every corner. But our ambitions as a species led us to a desire for more. More roads, more housing, more natural resources. We marveled at our own ambitions. Almost unbelievably, we found a way to land a plane between 7 million people in the middle of a tropical rainforest. This post-industry world has connected us across borders, but has also created a shift in how we live, work, and be with each other. Populations have boomed, and many of our buildings have become single-use, isolated from city centers, closed off from the environment and community, requiring more travel, more energy, more resources, simply to reconnect with each other. And in this rush to build quicker and more efficiently, we've ignored our instincts as a species. We've created a striking duality between the natural world and our own urban desires. Thankfully for us, our own forefathers at SOM gifted us the spark that started a powerful idea. And that idea is that our own immortality is not judged on how much or how tall we build, but how we make peace with the environment and create places for people. So you've noticed by now that this isn't a typical facade presentation. Rather, it's a presentation that proposes ways our buildings can play a role in rehumanizing our built environment. Today, I'll speak about 7 principles of design that, when applied to buildings and building enclosures, can transform the way we live, work, play, and learn. So the first principle is to create transformative gathering spaces within our public realm, focused on equitable community space, a meaningful space for people. Schueco Tower, as many of you may know, is a large-scale mixed-use development located above the Tanjong Pagar MRT station here in Singapore. The development is located at a critical intersection between the southern edge of the CBD, Tanjong Pagar district, and the new southern waterfront, an inflection point of culture, business, transport, and nature. So while the development is one of Singapore's densest, the focus was on the public realm, Tanjong Pagar Park. Drawing inspiration from the nearby Maxwell Hawker Center, the intent was to create a new community, flexible yet vibrant and active day and night. And at the heart of this space is the city room, which is supported by retail, F&B, gardens, and performance space. The space is further broken down into smaller rooms to create more intimate meeting points, places to rest and reflect. Yet the critical piece of this space is the city room canopy, which acts as a massive shelter for the program below. Shelter from the sun, yet naturally ventilated to maximize airflow. And the particular challenge here was to reuse the already structure built below grade above the MRT station. The canopy was constructed upon this existing structure, which minimized disturbance to the station below. The enclosure is made of BIPV glass, acting as both a shading device from the harsh sun, but also an energy generator for the development. And the retail units were built around the existing station vent shafts and clad with perforated metal to allow them to breathe. Shop fronts were seamlessly integrated into the facades to activate the public space and create a human-scaled experience within the city room. And today the space is used for fitness events, musical performances, farmers markets. It's not always buzzing, but there are moments when the experience walking through the space is quite tranquil and quiet. But this space demonstrates the importance of a well-positioned public space and the role great enclosure systems can play. And I encourage all of us to think about the next version, how we can use our knowledge through more unconventional facade design to shape meaningful public space. The second principle is to allow our buildings to breathe. Before our migration into hermetically sealed glass buildings, we lived with more direct connections to the outdoors. We used cross-ventilation and natural cooling methods to live and work comfortably. This project, under construction in China, is WeBank, a new bank headquarters in Shenzhen. From the outset of the project, the team was interested in creating an entirely new solution for a bank headquarter building. Following the mantra of the bank, WeBank does not operate like other banks, so the HQ should not look like another bank. And so began the erosion of the building envelope. Rather than an efficient taut glass facade, glass and aluminum structure, we sought to erode, shift, transform the boundary between inside and out. We created multitudes of exterior terraces with gardens, workspace, fitness areas, and 2 pools, which reflected the demographic of the bank's young workforce. We eroded away the interior spaces as well, creating multiple living rooms that are triple height, quadruple height within the interior space. And the workspaces blended with informal areas, gardens, and circulation space to further confuse the division between work and play. We also undertook exhaustive CFD analysis to understand the air velocities and temperatures needed to create ideal overall comfort. And so the building is packaged into 4 to 5 floor segments so that rising warmer air does not stagnate or remain in circulation for too long. Interior atriums facilitate passive ventilation when warm air rises and exhausts out the top of the atriums, pulling the cooler air at the bottom. And the building breathes through larger secondary mullions surrounding the perimeter of the building. Outside air is mixed with interior treated air when appropriate temperatures and humidity levels are reached. In Shenzhen, this can be up to 5 months out of the year. And users can individually control the level of outside air circulation in their immediate areas. The secondary mullions are shaped and clad with perforated metal screens to allow free movement of air through the outer surface. The inner surface is a simple hopper panel that extends 100 millimeters to allow outside air to flow around the panel. And to achieve a higher level of control and comfort, natural ventilation is supplemented with VAV economizers. Additional sensors in the building will monitor and adjust the VAV system in real time. Our future buildings should also adapt to their surroundings. This new Alibaba HQ building in Shanghai, currently under construction, will do just that, using the latest AI and adaptive learning technologies. We've all heard of smart buildings. We're now living in an age when technology where our buildings can learn and grow smarter over time. Named the Cloud Building, the structure is designed around the idea of optimizing human performance, learning and adapting to the interior and exterior conditions, learning about its human occupants and their daily habits, measuring their productivity, downtime, focus time, and movements throughout the day. The building is located adjacent to the West Bund Arts Center to the north, and Alibaba's Parcel T building to the south, a taller structure to the west, and Riverfront to the east. And the building intelligence is really built around the ideal teamwork module. Teams of 50, 200, and 500 can combine or detach based on the project task. Each building module can then adapt to its team as a unit, creating the ideal environment for the team. Smart glass and AI-controlled window systems adapt to the interior lighting, conditions in real time, adjusting and optimizing energy output to support daily tasks while maximizing energy performance. As the facade adjusts, so do the mechanical systems and interior lighting systems. The push and pull of the facade module also creates a self-shading geometry, further reducing solar heat gain on the lower portions of the building throughout the year by nearly 40%. AI-powered natural ventilation systems open and close the spandrel mullions, creating cross-ventilation and allowing fresh air into the building in the evening hours. Multiple roof gardens act as retention ponds, further cooling the building's surfaces and allowing for a larger water volume to be stored. Water can be stored within the blue roof sandwich when needed for insulation during hot hours, or slowly released into the irrigation system when needed. Our buildings must also honor their immediate context and culture. Otemachi 1 in Tokyo is a new mixed-use complex directly adjacent to the Imperial Palace in Tokyo. The project draws upon the heritage of Japanese architecture and the traditions of the past, honoring timeless construction methods of stonework and timber joinery. So rather than creating a high-tech steel and glass building, this building facade seeks to blend into its surroundings and its past. The design challenge was to create a facade that was stacked together like stone blocks, but also represented the delicacy and craft of timber joinery. The challenge was also to create a systematic repetition of typical facade panels to minimize cost and minimize time of construction. And so the building is composed of three main wall types. Wall type A1, which faces towards the palace grounds, A2, which faces north and south, and A3, which faces each. Each wall type is clad in light granite to accentuate the horizontality of the building. But the west wall is a bit more complex. The glazing line is set deep into the facade, into the structure, creating optimal shading conditions for the interior space. An operable cavity wall system allows for outside air to enter the cavity and insulate during winter. In the summer months, an interior shade can be lowered to reduce glare and heat gain. The facade expression is then carried into the interior spaces. The lobbies, corridors, and common spaces are clad in the same limestone, broken down in scale and combined with other materials to create a holistic experience throughout the building. Our buildings of the future can also foster collaboration. Elementum, which is in One North here in Singapore, is a biopharmaceutical laboratory built around the idea of collaboration, wellness, and innovation. The building is the third in a series of buildings with complementary office space and science program, working as a campus overall to create a village atmosphere with green space at its center. Metropolis 1 and 2 are primary office program, while Elementum is a lab space supplemented by a new plaza and a new park. The great advantage is its location against the rail corridor. The design challenge was to create a learning collective, a place for the community and the scientists to interact and commingle. The ground floor was eroded away to its minimum footprint, creating an internal public square for learning. The building itself is a highly modular and repetitive bar building that simply bends around the site to conform to the site boundary. Each lab floor is then eroded away to allow outdoor collaboration space for the scientists. And the internal program is then broken into smaller neighborhoods of collaboration. Smaller labs of 200 square meters at the base of the building and the lower floor plates, and larger labs of 600 square meters in the upper floor plates, supported by office space at the very top. And the ground level is intended to be a social interaction and gathering space for the community. Here you can see the ground level, which is an open, naturally ventilated collaboration space which will host events, industry events, and a place for the community to come together. And finally, the typical facade enclosure folds to create a self-shading geometry. We use scripting software to determine the best angle and depth to balance ideal shading and glare for the interior lab spaces. Highly sensitive work surfaces within the lab require very highly controlled lighting coming into the building. And with this facade angle, we're able to eliminate 90% of the interior shading within the building. As our cities continue to grow, we must be aware of how we densify and densify smartly. 8 Shenton Way will be the new tallest building in Singapore when finished in 2028. This is a true live, work, play, learn vertical neighborhood with public space, retail, office, hotels, service apartments, and residences. The tower's massing started with a simple base envelope and was further shaped by the programmatic pressures and distinctive floor plates and the requirements for each of the programs. Green common terraces are formed as the massing steps back, and the bundles are then softened at its edges on the east and west sides to create a softer geometry. And the diversity of program is also reflected in the common areas and how the facade erodes away to create multiple common sky gardens. Performance space, collaboration areas, fitness zones, quiet gardens, entertainment areas are all densely populated with greenery. Trees and plants were carefully chosen to create microclimates to attract butterflies and birds and to support the local ecologies and migration patterns in the area. The podium levels were also eroded away to create a large communal space, another city room, shaded from the intense sun and naturally cross-ventilated throughout the year. And on the upper levels you see here in the podium are accessible by the public, and it's really a restaurant collective called The Grove. The Grove is designed as an open garden street, allowing restaurants on both sides to completely open up to the elements. The trellis above also reacts to the weather by opening and closing during rainy weather. And the building geometry further erodes as you step up into the massing. Each of the building bundles creates a super bay window for the interior office space, extending the corner office views throughout the entirety of the floor plate. The high-rise buildings of the future will begin to need to think about how to erode, how to remove facade, and create occupiable spaces for people. 8 Shenton replaces nearly 120% of the site area with common green space for the public and its occupants. High-rise buildings of the future will also need to address the human scale. So let's start thinking about our enclosures and how they are now places to inhabit, to do work, to play, to be within nature. Perhaps we need to build less facade and invent more permeable materials and surfaces that can support greenery. That leads me to the final principle for rehumanizing our built environment, and that's to decarbonize. Urban Sequoia is a research project by SOM that poses the question, what if our buildings could act like trees? What if the systems and materials removed carbon from the atmosphere and produced enough energy to be self-supporting and support other buildings in the community? This project looks at 5 key components that, if designed properly with the technology we have today, could save up to 300% carbon over the building's lifespan. Over the last 100 years, we have been predominantly using concrete and steel to build our cities. But we can significantly reduce building carbon emissions by as much as 50% by simply opting for existing sustainable materials like timber, biobrick, or concrete additives like hemp or cork. Bioconcrete and low-carbon concrete has made significant improvements over the last few years and has been implemented here in Singapore. If we think of our buildings as purely modular, we could reduce materials, improve quality, reduce time on site and disturbance to the surrounding neighborhoods and ecologies. We could begin to rethink our vertical transportation mechanical systems to be modular as well. If we consider an ecosystem of these urban sequoias, we can begin to imagine how the production, exchange, and consumption of resources becomes more local and efficient. Energy, food, building materials, you name it, can all be produced locally with natural materials. Waste can be used to power our buildings and broken down in a more sustainable way. So I'd like to end on a video of Urban Sequoia and to show you what we're up to in the next few years.
What if our buildings were more like trees? Last year, SOM posed this provocation as the concept for Urban Sequoia, a building that absorbs carbon. And for the past year, we've been developing this concept beyond a building into a holistic design approach. We asked ourselves, how low can we go in emitting carbon in construction? How high can we go in carbon sequestration? And how long can we go in extending the typical building's lifespan? Tall buildings are one of the largest and most ubiquitous building types in our cities today. They are also additive by design, starting with the structure, then adding multiple materials and systems, which increases embodied carbon and lowers efficiency. We need to transform the tall building into a tool to heal the environment. By reducing the mass of our structural shell, inverting and consolidating systems, and using revolutionary building materials, we achieve a radical reduction of carbon and waste. We also generate clean energy on the facade by using technology such as solar glass and photovoltaics. We go further by using stack effect currents with direct air capture technology to remove carbon dioxide from the surrounding air. Lastly, we extend the building's lifespan from 60 to over 100 years by making the design more timeless and flexible so that it can adapt into the future. SOM's new approach removes 100% of a building's carbon emissions within 5 years and continues to absorb over 300% of carbon throughout the life of the building. This approach can also be applied to many different building scales and styles, so multiple structures work together to lower the impact of our cities on the environment. Urban Sequoia reconsiders every aspect of design and construction, from building materials to structural design to mechanical systems. It's no longer a vision of the future. It is a holistic approach that turns concept into reality.
Thank you.
Thank you, Nicholas. Great buffet of projects you showed. Thank you also for the sneak peek into Ancient and Way. I think we are a landmark project once it's completed in 2026. Okay, next up we have a panel discussion. This is on designing low-carbon facades for a more sustainable future. I'd like to call upon the panel moderator for this, Ben Moore. He's the Built Environment Director, Built Environment Sector Leader for ASEAN and East Asia at Mott MacDonald. Ben will be moderating this panel. He'll be introducing his panelists also. Just to recap a few things, we won't be taking any questions from the presenters. For the panel, if you've got time, we'll take questions. We've recorded this event. We will share the YouTube link with you a week from now once we have permission from all the speakers to share their presentation. We have the USB sticks on the delegate badges, which has all the sponsor brochures. So no more the bag. The USB stick has the soft copy of all our brochures. I think we are ready now. I'd like to call upon Ben on stage, and Ben will introduce his panelists.
Okay, good afternoon, everyone. Always, I think we've got one more coming. Always tough when we're standing in between you and lunch, but fortunately we have a very interesting topic for our panel discussion today, designing low-carbon facades for a sustainable future. So we'll just wait for our final panelists to come up. But I guess without further ado, just purely in order, so I'm Ben Moore, I'm the Built Environment Sector Leader from Mott MacDonald, and obviously moderating today. Just introducing through order. Firstly, we've got Mr. Theodore Chan. So Mr. Theodore Chan is a Senior Director at PLP Architecture, where he was instrumental in the design and implementation team of several award-winning healthcare projects, Mount Elizabeth, Novena Hospital, NUHS Medical Center. Yeah, sure. Yeah, sure. We've been asked to move along a little bit. So Mr. Derouen Chan. Thank you. Next is Mr. Oi Wei Yap. He's Director at SAA Architects in Sabana Jurong. So welcome. Following is Tan Soo-han. He's currently the Head of Sustainability and Deputy General Manager and Sustainable Urban Renewal at Keppel. Did you see her? And finally, we have Ms. Lee Chiao Yan, who is the Principal ESG Consultant at Sabana Jurong. So just to open up, to keep it pretty light, the first question, before we move into a bit more kind of content, what is your personal low carbon goal for 2023? Maybe, Chiao Yan, I'll start with you.
Lady first. Okay. Yeah, I do have personal goals of a low carbon. Yes, as a sustainable consultant. In personal, my life, it's beginning of the years, there's a New Year resolution. We have a New Year resolution for low carbon target for our families and also my work. And then, in the past 2 years, it's very hot topic that every companies, every project they are talking about, what's my long-term, short-term, low-carbon target. So we also have a low-carbon target for our family and myself as well. Yeah, that I apply the same methodology to myself as well. Like we starting from low-hanging fruit. So I think that was for myself was my low-hanging fruit is maybe I need to wait back to my pre-pregnancy weight to lose 4 kilos, so I can use all my old clothes so to save the plant. And then for my family, is I always monitor my household consumption and make sure that it's far below the average. And also, coincidentally, something related to facade is we found that a whole hanging fruit for our family is we need to make full use of our window for the ventilation. That because actually we don't really need air conditioning, but because in Singapore that we live in low floor, and then the big issue is the mosquito bite. You can imagine how excited it if your kids is disturbing in the night by the mosquito bite. That's why I found a solution that we can cut 40% of our household carbon emission is by just install a wire mesh.
Okay, so yeah. You've got a lot of goals. There's no goals to 2023, so sorry to cut you off, but we'll keep moving. So, Soo-han, what is your personal low carbon goal for 2023?
All of the above, man. All of the above, except for the pre-pregnancy weight part. Although I do want to eat less, that is true. Yeah, I'm on the wrong side of 40 now, so that probably cuts carbon and probably improves my health. Fantastic. Hopefully, we'll see.
Fantastic. Wei Yap?
Yeah, I'm just dropping the car and taking public transport, and that's the simple step that we can do. And on top of that, do a lot of cycling around places, and probably not very productive for practice is to try to carpool towards a meeting. So, it's probably good for the younger generations as well.
Fantastic. Theodore?
Yeah, so sustainability to me is like religion. Okay, so I think everybody here, if you really want to adopt this sustainability approach, you've got to believe it like a religion. So for me, I have not been using air conditioning for the longest time already, right? It's such a simple thing. And the next thing is when I choose my clothes, I buy clothes with fabrics that do not need ironing. And that's a very big thing, because, you just go into washing, you take it out, you wear it. Because I think that will save a lot of energy. And professionally, I've now gone into designing houses for people, and wherever possible, I try to sing the song of natural ventilation, skylighting, planting coming in. Yeah, so very simple ideas like that. Those are my sustainability goals.
Fantastic. Thank you for sharing. So just maybe to set some context, more and more governments are now making pledges to commit to national decarbonization targets. As a case in point, Singapore government has a 2050 net zero ambition. So it's clear from today's presentations that technology and digitization is increasing in sophistication. There are some fantastic presentations today. My question to the panel is, how do we think we can translate these technologies into tangible decarbonization outcomes? Anyone to go first?
Yeah, maybe I'll take that question first. Yeah, I'm really amazed by the presentations and all the work that has been coming out here. It's fantastic designs and very exciting times towards facade designs. But I've always asked myself, when I was serving as a Singapore Institute of Architects president about 10 years ago, Singapore is in the equatorial belt. I wouldn't say even tropical, equatorial belt. And we are blessed. We have a very strong government, strong institutions. But yet, we have not been able to pool together this wealth of knowledge that's been going around the world to formulate a kind of a guideline or a standard that we can actually use for industry and especially for the younger architects, those guys who are studying university, coming out as to what an ideal equatorial facade can be like, right? Because our challenges in the equator are very, very demanding, especially in Singapore. I deal a lot with healthcare buildings, and you will realize that all the hospitals, especially for the general wards, they require natural ventilation. So how do you bring in natural ventilation without bringing the occasional haze? Thankfully, the haze has been sort of under control already lately, but yet you have to worry about rain coming in and sunlight and glare and all this. Yes, there have been lots of efforts and improvements being carried out by all the various architects, but I don't see a concerted effort, and this is something which I think it would be very valuable if all of us came together and come up with a kind of a guideline, right, that can be used, almost like a building code, for an ideal equatorial facade for various types of buildings.
Yeah, I appreciate that. I mean, that I guess kind of begs the question, do we feel that it is possible to have an ideal facade? Is that a goal which is possible?
Yes, I'm sure it is. It's a question of just coming together. And even maybe not an ideal, but if you could have 4 or 5 prototypes, and if the architects in Singapore and all our international experts could come together, sit down, and even morph it over the years as we go to respond to climatic changes, I think that would be fantastic for everybody, and things would really go very fast and very efficient, and it will also bring down practice costs, I believe, which is one of the main drivers in how to sustain an architectural practice.
Sure. Yeah. So just expanding on that point a little bit, obviously in design, there is some level of control when we're designing, but the overall carbon footprint, obviously, in addition to the operational, is the embodied. So there is going to be this hand in hand with design as well as procurement and even circularity of the materials. If perhaps to the panel, how do we see procurement playing its part in decarbonization, and where are the kind of pinch points? Maybe we take that one.
As we all know, in the building industry, it's not linear, it's multifaceted, and I guess the challenge is about alignments. We are looking at politics, we are looking at policies, we are also looking at labor costs, and of course, when we talk about carbon footprint, where does the material come from? Those are embedded challenges that we are facing. In reality, to bring it together in the globalized world and economy is almost impossible. So, from that point of view, being a PROMIC, how do we address it? I guess what we are looking forward is about the possibility through digitalized transformations, especially with industries where we have the ability to bring different integrated informations as one. I'm saying in light of probably Sabana Jurong, where we are a practice that we have multifacets, or in fact multiple disciplines coming to one. So I think likewise, within an organization is how we bring the best to facilitate for the world in general, rather than to make ourselves work as silos. So the cross sectional integration is important, and likewise, as a global economy, working with our regions is equally as important, to make that happen. And to put that in context, for example, if we look at embodied carbon energy, especially in a European country, they are making use of what they have in terms of technology, like robotics for Volkswagen,
making it using that technology to facilitate innovation such as CLT, and therefore creating an economy that works within that region. Likewise, in Singapore, we do have that capacity to do so, especially with our Malaysians, our Indonesian partners, and even Australians. So I guess out of this whole discussion that we are having and framing is not about what we can do as individuals, but rather what can we do as one united built environment force, for environment, because the world is dying. And we are the one who can actually make it happen by finding solutions around it.
Yeah, absolutely. Now that's very well said. It's not going to take a whole bunch of individuals, is it? We come together. That said, as we know, I guess the way the world works, whilst there is, more and more social ambition, right, to drive forward, at the end of the day, there are still some key enablers. Things like regulation. I think Singapore, as we know, is very good at regulation. Where do you think we're currently sitting in that space? Are we doing enough in terms of regulation, or do you think that it's going to be driven by commercial, between the two?
All right, maybe I'll give it a shot. I think a lot of why we use what we use is because of the market forces that determine, for example, cost and also accessibility of these materials. So when it comes back to procurement, what we really need to do is to set, I'd say, responsible design values, or even certain boundaries, or I'd say hinterlands within which we can procure material. We can account that, of course, back to the amount of carbon that's spent in transporting these material and how it's produced. These can be sort of either informal or formalized guidelines, meaning if your project is within a certain vicinity, then you can only procure materials from within X hundreds or X thousands of kilometers from where your site might sit. Now, that would then remove, I think, some of the challenges that the economics of the situation might bring. For example, but I want to get it from somewhere out that's way further out because it's a lot cheaper. But hey, you can't because it's regulated, and it's sort of captured within a certain carbon expense, right? So I think setting these sort of baselines is crucial. And when it comes back to the equatorial facade that Theodore spoke about, it really is because of the absence of, I'd say, manufacturing of such materials. For example, I mean, fins and so on are out there, but for more specialized types of equipment, for more responsive types of equipment, we don't have a ready supply in the supply chain. And that is why the easiest option is to go for full glass, right? Not that full glass is bad by any means, as we've seen in many of the examples this morning. And finally, I think a national or a global database of facade performance baselines is then required for us to be able to set these targets and the regulations that will come thereafter. For sure.
Yes, and also post-COVID, there's a new need and new regulations need to meet this need, like the post-COVID, that people have a more a requirement on the indoor air quality and also on the infection controls. So the regulation on the facade on this part will also need to be updated.
Sure. Now that's all good points. And I just wanted to pick up on both those points. You talked about a national database, and we also talked about regulation. When we look at embodied carbon and trying to quantify and benchmark, there's a lot of work being done around how we quantify and how we can prove, where we stand. Xiaoyan, maybe I know you've been doing a bit of work on embodied carbon, how we calculate it, making sure that the factors we use make sense. Maybe you can elaborate a bit about where the industry is at the moment with regards to embodied carbon and understanding it.
Yeah, so in Singapore, actually embodied carbon is still new. And also the database we use is mainly refer to UK or US. And then the data, that embodied carbon is evolved from the original, so from for example, for the wood, where you get the wood from the forest, and also the transportation, the processing, and then also on-site construction. That's why the data is mainly on US or UK based. So we need localized data because the major materials, building construction materials in Singapore is from Southeast or from Asia. That's why the data transparent on this part will also need to be updated and important.
Yeah, that's fantastic. That's great.
Yeah, there's a lot of talk about the embodied carbon, but I venture that the operational carbon is actually a lot more significant in a ratio of about 7:3. So the operations of the facade in this case, right, during the building's life cycle would be also very crucial, and that means it just has to be designed appropriately, designed correctly, right from the beginning.
That's a good point. That balancing of the operational and the embodied. I guess just throwing to we and Theodore, as architects, how are you embedding the, if we look at that iceberg analogy, right, from the day it's built overall, the whole life cycle of it, what techniques are you looking at in ensuring that there's that whole life carbon, through your projects?
I can think of two things. So for our office, what we try to do is we exhaust all passive strategies first. Yeah, that is something which we are quite passionate in. Right? So after exhausting everything, then we look at the M&E aspects. Right? So that kind of strategy of design, I think, will land well in sustainability. Now, the second strategy, of course, you try to use products which are low carbon, green certified. But here's the tricky thing, you see. I think all of you all know that there's no really one standard of what a green product is, right? And how much carbon does it use and all this, right? Zahan pointed out something very good, the distance. Procuring something which is around your vicinity would cut down the carbon a lot. So I really wish, because I think I speak for all the architects here, we really got no time to go and look into all this. What we need is a solid rating tool to say that you use this product, you're guaranteed, right? So this is something which I think the industry, the manufacturers have to work with our local authority, Singapore Green Building Council, right? Right down to the point where it's always becoming like sanitary ware. Now sanitary ware, when you select sanitary ware and air conditioning, it's very simple. You just look for the number of ticks, right? And then you specify it. So so I think that is the way that the manufacturers, the experts who do their research, and the industry can come together to assure us that this rating tool that we're having is rock solid and is meaningful.
Sure.
I guess if I look at it from two different viewpoints, which is one being where the client is coming from, or the end users, and the other one which is us as a service industry, what do we do? There could be a point where we are able to find a soft touch point. And what I meant by that is about us being able to understand things like what are the value propositions of what we do. And our value propositions and the service to the client being either the end users or the built environment is about doing the right thing. And doing the right thing is about identifying your value add in quantifying that effort. And therefore, as a consultant practice, as what we are also probably because we are a little bit lucky from the fact that from a larger organization, we have the economy of scale. So we do have a research entity that help and support us. Yes. And we have partnering, or in fact in-house. Xiao Yan is our in-house ESD consultant. That have the database. And therefore, as an architectural practice, is about bring all these informations together to develop a value proposition currency in which the end user can benefit and the client can understand the return on investment. So what we are doing is, in fact, to look at AI and digital tools to quantify the value of our proposition by design. And in doing so, for example, if we have more shading in this day, and that way, if we add these shadings, it gives you this value, it lowers the exposures of heat load to the facade, and therefore saving X amount of cost for the facade proposition. We are no longer talking about things like whether it's beautiful or not, but rather to use a scientific approach, as a data-driven approach in designing to quantify our proposition. So I think bring both together is also about what is the future practice and how do we enable it. So I think there are a few things that I'm talking about that we do need as an industry to find the alignment again, to move forward.
Yeah, that's very true. You talked about value proposition, right? I think we kind of touched on it a bit earlier, but to unpack it a bit more. With carbon, with decarbonization, there is a real social responsibility push, which goes beyond, the commercial value proposition. Perhaps, maybe Silhan, maybe from a client or developer side perspective, how are you seeing that shift in value proposition between, pure energy or cost versus, increasing social responsibility?
Yeah, so we are an asset manager as well, and asset owner, and I think other in the market, you know that rent prices are high. So the challenge really is not so much in terms of sort of charging a lower rent and hoping people come into your building. It's about what your building can bring to the tenants in this case, many of whom are actually corporates as well with their own inherent ESG goals and that they need to report back to the HQ, or they could be HQ'd here themselves. Now, the one question that maybe I'll put to the audience is that if you're an architect or if you're a consultant, when was the last time you actually asked the tenant of your building what they want the facade to be? The answer is probably quite rare, to be honest, because I too am a consultant or had been one myself. And you always ask the developer, so what do you want your facade to be like? It could be this, this, or this. Pick one, right? And then you match that against the cost and more recently against the embodied carbon. The thought now here is this, do your tenants actually like the facade that you're actually providing for them? Or do they come in and do they start sort of putting all sorts of film, putting all sorts of advertising, putting all sorts of things to cover up that facade anyways? So here's one aspect of value proposition that we can bring. Run a survey, determine what kind of facade, what kind of environment they actually want. Sure, you talk about the interior finishes, you talk about the furniture, the layouts, and so on. The facade should be part of that conversation as well. The larger, I suppose, sort of bleed-on aspect to that would, of course, be aspects of thermal comfort, visual comfort, for example, glare. I can't see you right now at all, Ben, because there's a light in my face. Just imagine if they're there and you're nodding your head. Same with you, Theodore, but I can see the hair. So anyways, so visual comfort, thermal comfort, that translates to, of course, a better power bill eventually. That translates to your own tenant also having a more decarbonized state of operations. Everybody wins in theory, right? And that feeds up to a sustainability report, that feeds up to a landowner or landlord's, not a building owner or landlord's report, and all that sort of ties in pretty nicely. But it all needs to start from the fact that it's specified, it's designed appropriately, and it's sourced appropriately as well.
Fantastic.
That's actually a very interesting point because, I only just came back from Australia. I've been practicing overseas, and the current trend at the moment, right, especially with what we are facing now, which is the cost of living, is accelerating, and it's not dropping anytime soon. So, even you go to the supermarket, you go and get a banana, it's going to cost probably double or triple the price that it used to be. And what it also means is that the awareness of the end users are now even more acute, needing to know that, okay, if I'm going to buy this apartment of mine, am I going to still be spending this X amount of dollars? So a lot of what we do or what you're talking about is about the end users also have a response to the product they are buying, right, in that sense, and therefore the influence of the end user is starting to become very strong. And the currency is, in fact, so strong that in Australia in particular, the buildings that we are starting to produce is no longer about whether it's the right location or not, but rather what's the performance of the building. What am I getting? How much saving am I getting? Because these are reality that is really kicking into society.
Absolutely.
Yeah.
Absolutely.
So what if it's a BTO, a build-to-order kind of model, based on performance as opposed to based on how you want to live, right? In the case of a HDB flat. Yeah. And that model is successful for HDB. Yeah. And if there's anywhere that can be done, it will be Singapore.
Yes, actually, I think this is already happened, but maybe people may not be aware of it. Just like when we choose a unit by ourselves, that was your top priority, besides location. that your top priority, for example, for myself as a EC consultant, my top priority is the cross ventilation and daylighting. And the other most important is have a external shading on the facade, so I can open the window anytime, no matter it's raining or not.
And especially as society matured, you're much more affluent in terms and also knowledgeable. So all these type of things does inform how you make decisions as well.
Yeah, so because Veronika right there is staring at us in the panel, there needs to be mention of built-in photovoltaics as well in facades, and maybe there could be schemes in which the tenant also does benefit from the renewables, and you can write that down into your green leases, you can write that down into even your energy performance contracts and so on, right, where the tenant also gets a rebate, gets maybe a better rate as a result of buying into these types of practices.
Fantastic. So, I mean, I guess the key theme here is that there's plenty of drivers now, outside of your traditional value proposition. And I think that is really pushing things forward. I think now probably a good segue to kind of maybe, if we have time, just to give the floor an opportunity to ask the panel some questions. So is anybody have any questions to ask the panel? Everybody wants lunch. That time is lunch.
Maybe the question is, what's for lunch?
What's for lunch?
What's the carbon footprint of it?
Come on, guys, this is an opportunity now. Okay, everyone's very quiet and hungry, so we won't.
Ben, I'd just like to make a point, since there are no questions, which I feel very important, quite passionate about. Actually, it's the training of the students who are studying to become architects, environmental scientists, and all this. I think I don't know what happens in other countries, but there's a very big divide between what they learn in the university and when they come out and they practice. The divide is so big that some of them get disillusioned, Yeah. So when I was growing up in the university also, I found that there was a divide. But when I was a student, I knew that I have to bridge the divide myself. I got to learn about technology, I got to learn about building details, construction, and all this. And this is where I think, well, for me at least, the manufacturers, the suppliers, and all those experts who have done your research, the wonderful frames and glass that you see early on, you need to go down to the universities to actually tell the kids there that when you come out, this is what you're going to face. This is very important. And so, of course, when I say go down to the university, you've got to talk to the dons, you've got to talk to the professors and all this. Because unless we do that, then this mantra of sustainability is going to be not ingrained. It's going to be something which is, when I come out, then I worry about it. But if you really, that's why I said, it's almost like a religion. You really got to believe in it, right? So I really hope that, and really, I mean, I'm speaking from the standpoint of the past president of the Singapore Institute of Architects. So this is where I think the manufacturers can actually go down and talk to the Institute, talk to the Institute of High Learnings, talk to the Institute of Architects, and see how they can bring the technology, the very simple understanding of what makes a good facade, what makes a good detail in terms of sustainability and keeping the weather out and all this, down to the universities, so that when the kids come out, they will be better prepared and they become better professionals. Yeah, so I just would like to make that point.
That's a very good point. That connection between academia and industry, right? That's obviously very vital. I mean, you do a lot of teaching in Australia, in Singapore. I mean, what are you seeing in terms of trends and that linkage between industry and academia? Do you want to share a little bit?
I'm not sure about Singapore because I've not been around for a while. I've been teaching since 2003, so you can guess my age, pretty young. But what I'm trying to get towards is that, okay, first of all, there's generational shift, right? I can see 3 cycles. We are in the 3rd cycle now, considering I started teaching in 2003. The main thing is about finding a common point, right, in a way, and a purpose of allowing our younger generation to understand why they need to do certain things. And in Australia, what we tend to do is to have practice research embedded within studio, which is within practice with university. So that allow them to have live training within practice itself. And of course, the benefit is a shared IP, in developing not only ideas, but rather also to develop research capability. So I think there's, and I know that SUTD is starting to do so, and I think NUS also have done that. But as what Theodore said, right, it really needs to come from the roots, because they are in fact they are our future. And if we don't invest in our future, right, what will we be, right? So I think as practitioners, we have our social responsibility that we need to give back to the industry by teaching and whatnot. So that could be an avenue.
Fantastic. Yeah, I just wanted to add a point to the point of operational carbon and envelope thermal transfer. And whilst I see BCA right there, Jeffrey is there. Hi, Jeffrey. I think there's an aspect of thermal transfer that we don't talk about too often that we need to talk about, and that's thermal bridging. And a lot of heat is actually lost, or rather a lot of the cold air is actually lost through the mullions and the other joints within a facade. And insofar, ETTB also, or rather always only looks at the glass and in this case the concrete or the masonry, right? So if we can add, not to make everyone do more work, but if we could add a layer, in this case, of the effectiveness of thermal bridging into the ETTB equation and make that regulated, we actually could stand to gain quite a bit in terms of energy savings towards the whole decarbonization journey. Now, that has absolutely nothing to do with what they have just said, but just a thought that came, and it's only 10 minutes left.
Justice is important.
Yeah, but it's totally relevant, because you see, what you have identified, right, is an issue. The question is, how do we prove it? What's the proof point? And therefore, research is an aspect that allows us to do so.
Yeah.
We have been lazy through the last few decades, primarily because materials are cheap, right? Technology haven't caught up. As energy is becoming a problem for us, it comes to a perfect point where we do need to revisit where we are. And in particular, now that to be able to achieve the so-called technology that we are looking at, it becomes more economical. So the question, and therefore the value proposition is, how do we use research to prove that it is actually the case, and then we'll drive the industry forward, right? In that sense, like previously, if you need to do super high performance things, which is facade, which is what a lot of European countries are doing, it wasn't possible because it was expensive. Why do the European country go for it? It's very simple. It's that their energy bill was up the roof if they don't deal with it. We have been lazy, but now land cost is not cheap. The cost of the labor cost is not cheap anymore. So it's a perfect storm that is about to brew.
Sure. Yeah. Maybe I'll ask you. I mean, back to that point on the calculation and making sure that we have a good understanding. Right now, with our current tools we have, in terms of when we are analyzing, facades, etc., how far off do you think we are from getting actual real-world, values? Do you think there's still work to be done in our methodologies, or do you think we're there?
Yes, do. Actually, in the past few years, the whole industry has put a lot of effort on improving passive design, but I think the impact on facade is still underestimated, because you know that 50% of the building energy consumption actually related to facade, direct related to facade. So lighting 10%, and then aircon 40%. So for other energy system in the building, you can only based on you further improve the efficiency, but you can close it. You can reduce close to zero, but never be zero. Only the facade that you can reduce to zero. For example, how we improve the design to fully remove the reliance on air conditioning, and then totally remove the reliance on artificial lighting. So this only can be done through facade.
Actually, it's interesting because if you think about it, right, if you do a cost plan, facade is 15% of the cost plan. So if you do the right thing at the 15%, you actually gain quite a lot, which is 50% for what you do. And through that optimization, you in fact have lower the M&E dependence or generation, right? Generation of the energy. So you can see the trickle-down effect if we kind of put all these numbers, put a beautiful pie chart, man, we are on the way.
Yeah, because other system is you create the demand and then you try to reduce it.
Correct.
But for facade itself, you can totally dismiss.
Yeah, you kind of deal with the first problem. It's like, you know, you put blind into the inside and say that, oh, it's going to be all right. But in fact, right, it's easier to kind of just deal with it right from the first surface.
Yes, true.
I feel like I'm sitting between like two colleagues in a project meeting. I guess I am.
Okay, we only have a few minutes left, so I was probably going to maybe just go through, well, one last call for any questions from the floor. Oh, yes. Okay, yes, please do.
Just you know, closely related to what Theodore mentioned, and it's also quite closely related to my heart. I mean, I'm still young, obviously, not as young as way up, but I think one of the issues that we have is we need younger talent, right? And yes, we need to go down to the industry, but you know, the current trend seems to be showing, you know, construction industry, built environment, no longer sexy, you know. It's not the stuff that younger graduates want to do anymore. So in the first place, we look at it, you know, back in the days where we were studying, you know, when we go into universities, it's still not what we call dumping ground yet. But now, you know, civil engineering as one of the disciplines is like Goya. You know, you don't do any other engineering, you end up in that engineering. So, you know, at the end, what you get is that, you know, rubbish in, rubbish out. You will end up in a situation with graduates coming out which really don't want to do engineering. So, you know, I think part of that is teaching, but also, you know, potentially how do we kind of, you know, chicken and egg, but how do we make the industry a bit more sexy, and so that, you know, essentially our young will come in and, you know, I mean, I'm happy to see all of us, you know, but then it's, you know, it's usually the same faces, and we are getting older, you know, fatter, you know, this kind of things, and we always end up in this kind of situation. So, you know, perhaps we should all put our thinking hats together. You know, what are the things that, you know, I suppose on a positive side, you know, that I suppose you guys are doing, the panel is doing, that you think, you know, can change the situation a bit more?
Yeah, I think, no, that's a very good point, Michael. I think, you know, right now, especially in, I guess, in the Singapore context, the fight for talent is, you know, is very difficult. So, you know, that is actually a good question. I mean, we're diverging a bit, but it's important. You know, what are we doing, you know, in terms of the, I guess, the fight for talent? You know, maybe if you can share, you know, what, with the panel, you know, what trends are you looking at to attract talent into your respective organizations in our industry?
So I think one way we can do this is to inject more meaning in what we do. This question on facades, I mean, especially in the realm of residential buildings, you know, landed properties, I think if I can use the word, we need to signs up. We need to say we need evidence-based, you know, because so I really dream of a time when I can tell the client that if you follow my facade, if you do this, I can prove to you that I can save so much of energy and you get so much ventilation and all this. But right now, and I'm sure we have the tools and the intelligence to do that, no? We're not doing it, okay? It's more like, wow, I got an interesting pattern, I got interesting detail of the sun shading, and that's the thing that's been selling it, right? So I think if we can make it more, if the architects can be more technologically more savvy, a meeting of the minds between the engineering thinking and the artistic thinking, right? It will make the profession more meaningful. The public will see the value, and the esteem will go up. And I think that will attract more talent into the industry. Yeah, so to summarize, I would like to say that the architects need to sign up with evidence based on their facade designs, rather than just it's a form and it's a very interesting look.
Yeah, I agree. Because walking down this long and very cold corridor to this room, there's another conference that's happening, and that's the Data and Analytics Conference. And I almost wanted to step in and see, hey, what's that all about? Right? And it does interest you, right, as to what this can do. But if you layer that on top of our industry, I think you're going to gain a lot more interest. But I think I will venture to, again, suggest that the motivations that the young graduates today have aren't too different from the motivations that we had when we were graduates in our own time. It's just the externalities that changed, right? So what do you want to do? What do you want to get out of a job? You need meaning. You need money, right? Of course, that's skewed a bit because maybe the next generation of graduates are a bit more affluent, their parents are a bit richer, therefore they look for purpose a little bit more. But it's really the externalities have changed, and Singapore sort of developed at this point, and it's very different than when we were growing up, when we're still sort of developing for some of us. It's not really the fault of, in this case, engineering or architecture, that it cannot keep up, because it is what it is. It's about the physical environment. Where we do fall short is that we might not be embracing new things quickly enough, things like AI, things like data and all these things. Whilst that's happening, it's sort of reticent that, oh, I can't help it, and therefore this happens, while we're still standing ground that, hey, architecture and engineering is still the best thing that you can do. And that's a myth, because it no longer is, right? That there are so many things out there that you could achieve the same thing, i.e. money and purpose.
Fantastic.
Right? So I think coming back to facades once again, how do we make facades sexy? I mean, I don't think it's ever really been about sexiness, to be honest. It's always been about what is relevant for our time, what is equitable for our time, and what is purposeful. Yeah.
Great. Okay, I'm mindful of time, and we're sitting between lunch. So I guess just to wrap up, I'll maybe just go to the panel and have some parting final thoughts. Choyang, I'll start with you.
Yeah.
Something to leave us today with what we knew over our lunch.
Yeah, and then lady first also. Okay. Yes, I think for the facade part, like as I mentioned, that is still underestimated, no matter the embodied carbon part, especially the embodied part. Yeah, in the past, I think is underestimated, and also the operation part, we can do more.
Yep.
Yeah.
Okay. So Han, any parting?
No,
thoughts?
nothing beyond what I've shared.
Okay.
We all have something to contribute, so I think we all can work together.
Yeah. Wean yourself off air conditioning.
Okay, I think I'll wrap that up. I mean, I think we've covered a lot of ground, from regulation to technology to carbon, sustainability as a religion. So if you could just join me in thanking our panel today. Okay, thank you. And I think now is...
Yep. Yes. Can I request the panelists to be seated? We'll take a photo after this. So ladies and gentlemen, we're taking a lunch break. See you back around 1:50, 2 o'clock. We'll start the session. Can I request Mr. Benedict to come on stage? Can I request Nicholas and the other speakers, Mr. Arun, Thomas, to come on stage? We'll have the mementos given to the speakers and panelists of this session. Thank you all, and see you around 1:50, 2 o'clock. Thanks. Right. Our next presenter has flown in all the way from Amsterdam, Kyo Suk Lee. He's a director at MVRDV, one of the exciting architectural firms around the globe. He's going to be talking on what's next facade. So please give a round of applause for Mr. Kyo Suk Lee.
Okay. Thank you for having me here today. It's very interesting to discuss about the future facade together with you, the provider, contractor, engineer, also even our competitors. Facade traditionally mediate the inside and outside. As we know, the contemporary urban environment getting more and more complicated. There are many conflicting value and the demand that we need to satisfy with our design. I think the facade has a key role to mediate those conflictions. My lecture today is about how MVRDV has been exploring next facade beyond this dichotomy. Next facade could mediate the nature and artificial. Let me start with one of my favorite Dutch painting by Bosch. He depicted the human merged into the natural element. If you zoom in, people become the tree, animal become the human. He beautifully breaks the division between the nature and the artificial. For almost 30 years, MVRDV has been trying to make a building as a nature itself. Could the building be the tree, or could the building be the mountain? And this building is our latest effort in Amsterdam. Could the residential tower become the vertical oasis in the high-density CBD area of Amsterdam? Key design ambition is maximizing the proximity to the green to each housing unit. Like a valley in nature, it has a very natural shape. Actually, every floor plan is different. It sounds very scary factor for designer and the contractor. But this form is not just mimicking the nature, but it is the outcome of the synthesizing the parameter for better living environment. During the design process, whenever we change the design to make a shape, GFA got automatically calculated, also terrace area got evaluated immediately, and then we maximize the sun hour for each house, and then we reduce the heat load. In the summer, we maximize the heat load in the winter. And then bring the enough daylight for the every room, and then make the cantilever distance within the structural safety. And then most importantly, we also keep the privacy, though we make the natural shape. And then also need to satisfy quite complicated regulation of the Dutch government for the daylight. At the same time, all this weird shape of the corner get automatically optimized into the constructive angle. As a consequence, comparing with the normal building, box-shaped building on the left side, our belly tower has around 20% more sun hours. Final design is the result of the thousands of the automated tests to aim the maximum number of the terrace of the building. So the nature-looking randomness of the shape has scientific artificiality behind. This mountain is not only for the people who is living there. By stair from the public street, people could access or climb to the roof garden on the 5th floor. So building become the part of the city. So the skylight bring the daylight into the interior atrium below that we say grotto, like in the nature. And plant is a very important element of the facade. We install the proper installation of the water supply, drainage system to make the tree survive in the harsh climate of the North European city. So this is the typical view from the A residential unit. As mentioned, every floor plan is different. But what we did try here is that we standardize the utility zone, the kitchen and bathroom, as uniformized as possible. And we make a dramatic space on the living room and the master bedroom relate with the terrace garden in front. As you could see, green plant box strategically located to provide the privacy from your neighbor unit to your terrace. or from the unit above. From terrace, you could look down the urban activity around and below, and people could invite the family and friend in the sky garden like a suburban house. So most artificial way, we want to give the most nature vertical garden to the city. Next facade also mediate the public and the private. Again, one of my favorite painting from the Belmer shows how facade function as a beautiful psychological border between the public and private. Market Hall project is our interpretation of this tradition. Ambition is extending existing outdoor market to the indoor and combining with a very private housing. This is the expected shape according to the competition guideline from the city. Commercial podium and the typical residential tower or slab on top. But we think it's not enough. We flip the building and make the market with a very high ceiling space and covered with housing. Structural engineers said it's not possible because the span is more than 50 meters. And then we make the traditional arch shape to solve the structure, and then the MEP engineers say, it's not possible to have a core. So we end up with this shape, with a flat shape to have the structure and the MEP works. And this is how it looks. From the side, it looks like a typical slab housing. In the section, we add a very large parking space in the underground to bring more people to the city center, to the market. First two levels on the ground is for the food market. And the housing located from the second level to the penthouse over the market. Main design challenge, again, how to continue outdoor market to the indoor market hall. In other words, how to make a most transparent glass facade wall with the minimum structural support. We are inspired by the tennis racket. As cable of the tennis racket push the ball away, cable structure could react to the wind pressure. Strongest wind could push the entire glass wall 1 meter inward. So it's a moving structure. So this is the transparency of the structure hidden behind of the joint of the glass. This is the view from the typical apartment, living room to the market. And this is from the penthouse living room down to the market. We call this window as a glass carpet. As an interface between the market and the housing, ceiling, also important facade of the project, it is slightly larger than the two football field. We invite a young graphic designer of the Rotterdam to make the huge wall painting with the theme of the food, nature, and Rotterdam history. In the printed panel by panel, this pattern has a camouflage effect. It makes the people not to focus on the window of the privacy of the house, but to focus on the overall image. Now you see the very transparent glass wall who mediate the climate, and the ceiling who mediate the privacy between the public and the private. Next facade could also mediate the concentration and distribution. It's about the urban issue. This is a painting showing the Dutch tradition of the making compact city to make the city compact and the surrounding area as open as possible. And this is still obvious in the land use pattern in the metropolitan area. Comparing with any other European metropolis, Randstad, Netherlands has a quite network of the compact city. When City Museum of the Rotterdam decided to make the art storage in the middle of the park, this confliction of the concentration and distribution was a hot topic of the public discussion. Museum need more space, but citizens complained to lose their green park space. So this was the amount of the program they asked in the competition. In plan, we make a circular shape to minimize the interruption of the circulation on the park and view. In the section, we make a bowl shape to minimize interruption of the green space. and make a roof garden even bigger than the footprint of the building that we lose in the ground floor. So it provides even more green space, double amount of the green space, and it makes the park more three-dimensional way. And we designed the building not as a sculpture, but as a part of the park landscape by adding mirrored facade. It also showed the activity inside here and there. We assumed the art reflects the society, and the museum could reflect the city. Since this is a mirrored building looks differently according to the viewpoint. It looks green, and also according to the weather, building becoming the white in the snowy day of the last year. In the center, circulation atrium provides the very unique experience of the people. People could walk through the art, looking below and above, from front and behind. You basically walk into the art. You're becoming the part of the art collection of the museum. Around the atrium, there are storage rooms. The normal museum only shows 10 or 15% of their collection. Here, you could visit every single art piece. So this is, again, very important space of the rooftop park to compensate even more green space we lose in the below. Next facade mediates the individual and the collective. In his famous painting, Rembrandt tried a very new method, emphasizing the individuality without losing dynamic composition of collective figures. We applied this idea our housing project in very early stage. Each individual unit has its identity and make a dynamic overall composition of the complex. In Seele housing, we make the high-density housing out of the 20 mini neighborhood. Each neighborhood has a 10 to 20 unit with a very specific lifestyle and the housing typology. Facade is not only the expression of the difference or individuality, it also contains the niche for the collective activity, such as share the street for the senior. They can socially interact with the other senior on this neighborhood. And then even the residents itself find the niche space by the collective effort to use as a living room or the collective gym. Project we are now realizing in Singapore is a continuation of this idea, how to make the collective composition without losing individuality. We are inspired by the climbing plant and bring the Singapore landscape on towers. We take the frame as a main motif of the project, and each frame has a various function and appearance. And it contains a unique vegetation from Singapore climate. So this is how it look like. This is a view from the garden, the fantastic Singapore skyline. It continues to the sky roof, where it makes a very interesting semi-outdoor experience with the view. Now it's on the construction in a very efficient way. Each frame is being prefabricated in the factory and added on the tower one by one. I hope this building gives a new way to react to the demand of the individuality and, again, collectiveness in Singapore, especially related with your advanced prefabrication construction technology. Last subject is about how next facade mediates the tradition and innovation. This painting shows one of the very most dramatic moments of the Dutch history. After being free from the Spain and Catholic power, Protestants invade the church and destroy the Catholic icon and sculptures and painting. Of course, this is a very tragic moment of the destruction, but also at the same time, it's becoming the starting point of the innovation of the art. From this moment, instead of the drawing the religious subject, artists start to draw the nature and people and the everyday life. And that's the beginning of the golden age of the Dutch painting. In MVRDV, we respect the tradition, but try to add innovative technology on it. In all the village center of the Skynder, we want to show their proud of local farm housing typology. We realize that many of them is disappearing. We visited and document around the 200 farmhouse around the Skynder, and we Photoshop the characteristic aspect of those houses. So if we make one ideal houses who contains the memory of the 200 disappearing farmhouses. And we print it on the glass, and we test the transparency, and we blown up to the 200% scale to fit to the given program. And it is reacting to the local architecture culture there, but also reacting to the programmatic necessity of having show window as a shop. From inside, you could see the detail of their farmhouse and make the interesting interaction inside and outside. At night, it makes a dramatic fusion of the history and contemporary life inside. In Amsterdam, PC Hoogstraat is the luxury shopping street like Omotesando in Tokyo. But this is part of the UNESCO heritage. Shop owner always have a difficulty to have a big show window to the street because they need to get a permission to break the building. Together with the client, we brought the innovative solution to make the facade with brick, but transparent brick. So product and brand could be exposed to the people on the street. Crystal brick is made in Burano, in the Venezia, in Italy. They make the brick out of the glass. We find the glue in dental clinic. It is perfect solution for the joint because it's transparency and safety for the people. And most importantly, it is very strong and cheap. Like a typical masonry building, we stack brick one by one on the site. We also combine with the real brick to make the gradient effect. And this is how it looks from the street. To gradient effect, it also reflects the sky into the facade. With respecting the, let's say, local culture of the brick construction and reacting to the UNESCO heritage preservation regulation, by reacting also responding to the client wish of the having good show window with a specific demand, we brought the new innovation of the facade. So this is how MVRDV designed the next facade as a mediator of the conflicted value. I hope that our project could inspire even more creative way to react to the future demand of our city and the globe. Thank you.
Thank you, Kyo Suk. Interesting set of projects. Okay, our next presenter, we have a slight change on the agenda. Agnes Colte is running late, so we will have Nancy Somera, Managing Director of ALT, presenting now. She's going to be talking on simplifying complex facade design.
Good afternoon to everyone. The topic of this discussion is about the simplifying complex facade design. Actually, we were thinking of what topic to discuss because we've been the last speakership with Zak that we have done is actually 5 years ago in Manila. And ALT with 30 years of experience, we thought of sharing you the design approach of simplifying complex facade design. But before that, I would like to discuss and talk about who is ALT, very briefly. ALT has been in the business industry as a facade consultant for more than 30 years. And we have offices in Manila in the Philippines, Hong Kong, Shenzhen, Shanghai, and we have also representative offices in Malaysia and Indonesia. And also, we already put up an office in the USA. We have completed more than 450 projects with all over 30 plus in the countries. And these are just the locations and the mapping of where are the projects we have done. So as of 2020, we actually, 8 out of 20 of the super towers, ALT are involved on those projects. And the consultancy services is our core business, and we have other services like the facade access consultancy, facade thermal analysis, which is more into the ETTV, RTTV, and lead requirement, sustainability consultancy, building information, and architectural design services. So now, today, I'm going to discuss the key points for this meeting, or for this presentation. First is the evolving trends of the facade design. Second is how we address the complex design to a simpler approach. And third is the redevelopment of existing facade design. When I started in ALT, the designs of our architects were very simple and straightforward. We were just using AutoCAD 2D back then, and a few hand sketches. And the designs of the buildings were like from flat walls, aluminum cladding, stone claddings, vertical or horizontal features that was really commonly used back then. And these are the samples of the simple facade. The Marina Bay Financial Center, which is a unitized curtain wall system with high-performance glass and horizontal features. Another is the Asia Square, which is a combination of unitized curtain wall and window wall system with aluminum claddings. And the 30 Hill Street, which is also a fully unitized system with vertical fins and stone claddings. Through the years, designs of the architects are becoming more complex. The geometry and massing is now becoming, there's a change where from a flat walls or flat panels, now they're becoming into a single or multiple 3D curves. And this is an example of a CITIC tower in Beijing, where it looks like the form and the shape is a vessel. The bottom part of the CITIC tower is actually flaring, and what we have developed is we use the system of a step wall and cold bent glass instead of using the 3D curved glass. Another one is the Lotte World Tower in Korea with the vertical fins. And it has a tapered wall, and therefore there are different unique panels for this project. And another one, which is also the River 66, which is an elliptical shape. Now, not just the geometry change, but also the designs of the features. One of an example is the One Central Macau, which has an in and out facade wall, and it has a ripple effect. The Duo Towers, which is designed by Bureau Olay, which has an hexagonal fins, and which is one of the prominent features of this project. The Star, which is designed by ADAS, which is very complex in terms of the structure, shape, and features, where the ALT involvement is to provide the entire structural model of the facade so that we can ensure that the anchoring parts are in the correct position. And of course, the Burj Khalifa, which has a vertical fin features. And the challenge of this project is we need to reduce the depth of the mullion. And therefore, we use the vertical ball nose to be part of the structural framing. In terms of the constructability, one of the examples is the International Commerce Center in Hong Kong. This has a shingle wall, and one of the requirements of this project is basically to have a certain floors to be occupied, and other floors are still in construction. So instead of using a fully unitized system, we used the method of infill window system, where the spandrel panels are installed first, and then the vision panel were installed from the inside afterwards. And with this method, they can even install all the panels in any floors they want, and instead of the conventional type of curtain wall unitized system, which is from bottom to top. Now, with all these complex design considerations, we need to design in a practical and most efficient way. In terms of how we address the geometry, complexity of the geometry, is the use of the software Rhino and some scripting. So we studied the form and shape of the building and identify the different types of the unique panels. With those panels, individually they have their own dimensions, varying dimensions, and even angularity. And therefore, to come up with a solution is to have a varying joints so that we can further reduce the number of unique panels, and we regroup based on the parameters. So from more or less 19,000 unique panels, it was reduced by 96%. Similar approach we did on the Riverside 66, which is in Tianjin, where there are also a lot of unique panels. And as much as possible, the idea is to reduce the number of unique panels and group them together. And this is one of the examples of the details where it accommodates the varying joints. Redeveloping facade design is not just limited to new buildings, but also for existing buildings. Like there's a requirement for renovation, restoration, or recladding. An example is the Duo project. The architect is Bureau Ole Shirin, which the intent was to have the hexagonal look. And initially we thought of using a hybrid stick system. However, due to the labor cost in Singapore, and we wanted to have a good quality and workmanship, so we opt to use a different approach. And we recommended to use a fully unitized system where the horizontal fins will be integrated within the system. And this makes the assembly of the panel much easier, and installation is faster. This is an example of the hexagonal fin details, where we also designed the feature to accommodate the glass replacement without removing the hexagonal fins. And of course, because of the recessed part of the hexagonal fins, we've added weep holes at the corners to avoid water ponding. Now, how did we join the hexagonal fins, the junction? So what we did was to use the Y-sleeve cast aluminum brackets. And these are all interconnected together. Obviously, because of the building movements such as slab deflections and lateral deflections, we need also to accommodate those movements. So we designed the gaps to accommodate such movements. And the hexagonal walls has been realized, and therefore, visual mockup has been installed to provide value engineering and also glass selections and color of the finishes. Now, when it comes to recladding, one of the projects of ALT is the Centennial Tower. The Centennial Tower has a stone claddings and was replaced by a rain screen claddings and perforated metal sunshades, which also improves the SHGC of the building. Now, with all these simple or even complex facades, we still need to have considerations of the following aspects. Environmental factors like wind load, which also targets the structural integrity of the facade. Of course, we need to meet the client's budget, availability of the materials, and the sustainability. With all this latest technology, and I think it has been discussed in the previous presenters, there are a lot of new technologies and materials that will help improve the energy efficiency and sustainability. And for sure, these new materials will be a challenge and we'll be seeing in the future designs. With that, would like to thank you for your time. And if you have further questions, you may contact us or visit our website and our social media. Thank you.
Thank you, Nancy. I think she set up the next presenter very well. She mentioned about new technologies. ETFE was discussed this morning. Now we are at photovoltaics. Veronika Shabunko from Envelon will talk to us on the colorful side of photovoltaics. Over to you, Veronika.
Good afternoon, ladies and gentlemen. It's my pleasure to be in Zak. Last time it was, I think, in 2019, the last event. So I'm glad to meet with my colleagues. So today I would like to introduce to you a new design and possibilities of colored solar facades for net zero future by showing a few case studies and architectural design with award-winning solar active facades from Envelon. But before I do that, I would like to introduce you Envelon. We are a proud member of International Grenzebach Group, and we have a highly automated manufacturing facility located in Germany, Bavaria. Envelon founded in 2021 with 45 employees globally. Our office is currently located in Germany, Netherlands, United States, and Singapore. So feel free to approach me or our booth. We have a booth here to learn more about our technology, see samples, or visit our showroom. Okay. So how can we help? We electrify building envelopes with our sustainable and climate-friendly aesthetic solution made in Germany. We provide a customized project design and a full facade installation with our global partner network. We support the path to carbon neutrality by providing an active solar facade solution for on-site clean energy generation. In addition, our technology is economically viable. Currently, the ROI of financial returns is about 6 to 8 years in Singapore for new buildings. Our facades can provide about 30 to 50% of coverage in terms of energy consumption through activating facades. Here you can see some of the application where solar technology can be implemented, and we offer a great design flexibility. This is a solar module from Envelon. It's utilizing a high-efficient colored coating that creates a matte surface and a beautiful homogeneous look, whereby it's very hardly you can see the solar cells behind. It's a frameless glass PV module with invincible mounting system that we have implemented. So it's a crystalline-based technology and an award-winning product for Architecture Master Prize and German Design Award winner 2023 and 2022. As I mentioned, we have developed in-house installation technique, mounting of system into the facades. It contains the vertical profile, wall connector, back rail, and double agraf system. Here you can see how it works, if it works. So it's simple installation as you can hang onto the wall and connect modules by C4 connector. So this is how modules are installed into the wall. And now let's talk about color. Envelon provides a high-efficient color glass with a state-of-the-art PV technology. Currently, we have about 10 different colors and several dimensions that available so the architect can design sustainable buildings to generate on-site clean energy and reduce CO2 emissions. During early design phase of the project, we support and work closely with architects to provide feasibility study as well as solar potential analysis of the building. And this helps architects to make a sound decision to deploy such technology into facades. Here you can see a few examples of solar shading and solar potential analysis for several buildings. And here, different color represent level of solar insolation, in particular geographical location. Further, this information can be interpreted to energy yield estimation, how much energy can be produced by solar system, as well as system install capacity. Now let me share with you a few examples, case studies that we have completed for various type of the buildings. And first is office building in Netherlands. It's about 1,300 square meters of solar facades that deployed on spandrel area of the building facade. You can see here. So this spandrel area is all covered with photovoltaics. It's snowing. Yes, so this is one of the projects that we've done in, just have to go back, in Amsterdam. So as I mentioned, it's 1,300 meters of facade on a spandrel area. And if you look at it, it's about 10 times larger area than rooftop areas in Singapore. So potential for facades is really huge. So this system produces about 90 megawatt hour of electricity, clean energy, and saving over 60 tons of CO2 emissions per year. Oh, do we need to? No, we don't need to watch another time the video. So let's move on to industrial application. This is a project in Switzerland. It's a data center whereby for orientation of the facade surrounded, it kind of goes by itself. Yeah, so this is a... No, it's just a slide, but somehow it goes by itself, but okay. Yeah, so this is also, all four orientations are covered by solar. 1,200 meters square of the IPV. This system produces about 110 megawatt hour per year and saving over 70 tons of CO2 emissions. The next project is NEOM. It's a free city office building in Austria. This is recently completed project by Envelon. And this is how the design, our architect was proposing different designs of the building with utilization of photovoltaics. So the design ideas, actually, it's unlimited with photovoltaics, as we have different colors and areas how you can highlight the some areas. So this is how building look like. It's almost completed. As you can see, there are a few modules needs to be added. Yeah, it just goes by itself, but that's okay. So facade system produce 116 megawatt hour per annum and saving about 55 tons of CO2 savings. So another project I would like to share with you is also in Netherlands. So as you can see, most of the projects are in Europe, as Europe has more stringent regulations in terms of solar adoption. For example, in Netherlands, it's requirements that some portion of the energy demand needs to be coming from solar. So it's mandatory to have solar portion there. So this is a logistic center in Netherlands as well. 900 square meters of the buildings, of the building facade. Gray area is basically the photovoltaics. It's totally opaque technology. And the last project is in Switzerland. This is just a representation of various colors that company wanted to showcase. Yeah, it's just like jumping today. Yeah, so They just want me to finish the presentation. However, I'm not done yet, okay? So what I want to say is that designs and possibilities with innovative solar facade technologies are unlimited. Here you can see a few examples of how you can integrate solar technology on a car park with new designs and new technology, as well as logistics centers and even in urban applications, as example here, as like infrastructure deployment and the bicycle pathways. Yeah, and again, please feel free to visit our booth and learn more about BIPV, and we will be more than happy to support architects and building developers in their pathway towards net zero. Thank you very much.
Thank you, Veronika. So as you see, BIPVs have evolved. They're no more ugly. They have colored options. This was an opaque solution. There are also now transparent BIPV solutions, which will soon be coming out in the market. So energy generation via facades is going to be the next big thing. Okay, moving on. Next is probably my favorite topic, natural ventilation. I love fresh air. Stefan van Leynseele from Renson will be talking about natural ventilation in high-rise building facades. Over to you, Stefan.
Hello, everyone. Today I will talk about natural ventilation, sun protection in high-rise applications. So about Renson. Renson is a Belgian family-owned company. It's the 4th generation. Our core business is about ventilation, solar shading, wall cladding, and outdoor. The mission for Renson is creating healthy spaces. Renson developed innovative concepts for a healthy and comfortable living. In our product range, we focused on Southeast Asia for window ventilation units in combination with mechanical. Sun protection, it's about external blinds. There we have different kind of applications, corner solutions, horizontal and vertical. Structural solar shading, it's about our sliding panels. Outdoor is our pergolas with retractable aluminum blades or waterproof fabric. Our last product range is wall cladding, and that is based on our Continue louver system. Now I want to show you a video from what Renson stands for.
Man was once an outdoorsman, living in and with nature, in the open air, enjoying the sunshine, wind, and water. Being outside is in our genes, because we still feel better when we are outside, on the beach, in the mountains, in the woods, on a patio, at the campsite. Being outside gives us a sense of freedom and well-being. Being outside activates our senses. But today we spend 90% of our time inside. Inside our houses, homes, and apartments. Inside offices, hospitals, care homes, schools, and academies. Inside cars, buses, trains, and planes. We have been transformed into an indoorsman, but still with the same needs as the outdoorsman. Need for fresh, clean air, an atmosphere in which you can relax, with the right temperature and light in which you feel comfortable and protected.
So you understand well that we have a message to that, and we need to get the outside to the inside. We refer to Max Sherman, is a professor regarding ventilation. His study is about the big pollution inside. We need to take care of to remove the polluted air and get fresh air inside. How we do that? We mostly ventilation focused on remove the pollution air from the building, and then automatically you get fresh air that's coming in. Around the world, they consider about the air quality. The air quality that is mostly more polluted than outside. Inside, we have a lot of CO2 and VOC. And like you saw in the video, people spend up till 90% of their time inside. Also, they cover about the schools, how they can manage that in the schools. So I don't need to remind you about the time during the COVID. We all understood the time that we need ventilation. Around the years, the buildings become more air and watertight. So it means that they were in a plastic bag and they cannot breathe. What they need is to create more ventilation. So what we need to do is supply the fresh air that's coming in through the window. Then transfer to all the buildings and extract the polluted air from the wet rooms to avoid the circulation of the moist or unfresh air through the building. In the ventilation, you have two techniques. You have cross ventilation and you have stark ventilation. But you need to control that. In Southeast Asia, we focused on system A. We bring in the fresh air on the windows unit. That we don't want to have an extra opening in the wall and we don't want to have an extra air duct. So we bring it in on the window. And then, or in combination with mechanical ventilation to extract the polluted air. On the ventilation, we have how we integrated that in the curtain wall. We have two possibilities. Vertical, to have a high airflow and a high acoustic performance, and in natural ventilation, the convection opportunities. Or we have also horizontal. We integrate our trickle vent between two transits in the curtain wall. So by integrate the trickle vent, we bring in the outside to the inside. We improve the air quality by removing the polluted air. And we have a minimum impact on our air conditioning. We don't have any condense. And we have also the good feeling from fresh air. About the horizontal unit, we have a self-regulated valve. That is, if you have heavy wind on the outside, automatically the self-regulated valve closes, that you don't have a draft inside to avoid the condense on the aircon. Also, like in Southeast Asia, you have the tropical rains. We have an extruded rain cap. That avoids that the rain can come in, and also a still good function from the self-regulated valve. Also important is to damping the noise. If you have a sleeping room and it is on the street side, it's always good that you don't need to open your window, but that you have automatically a nice air that's coming in, and also reduce the noise. So that's why Renson, at the headquarters, we have our own test center. Also, for some buildings, for safety reasons, you cannot open your window, but it's more than safety reasons. It's also for the rain, for the insects, for the dust. All these things can be controlled by our unit. Also, to control the dust and the pollen, we have an electrostatic filter that we're putting in. Like I mentioned before, the air that's coming in through our unit, it's slowing down, and then the dust and the pollen stick on the filter. Also important is to control the units, that we have different systems with a cord or motorized. But, however, the closed position, that is only when there's fire outside, in exceptions, to avoid that the smoke can come in. Here I want to show you some nice applications that you see, like a condom in Auckland. What is important to avoid the overheating through natural ventilation, reduce the noise from outside, and still have enough air that's coming in 24 hours. Here you see an example vertical unit that you see on the right side, that the air coming in via a labyrinth to avoid that the water can come in. And then after that, the yellow market is the foam to absorb the noise from outside. Here you see some picture of during the installation. Here is a vertical unit as well, the THL 100 vertical on a Schueco facade, where we nice integrate it and control it on the inside. Also here, you see that the air coming in through a labyrinth and a big foam to absorb the noise from outside. Here is it a horizontal unit. They put it on behind the louver, and they attach to an air duct that the air can coming in 24 hours in the room on a natural way. Here as well, on the Schueco facade, on the outside, you find a small opening from 11 mm that the air coming in, and a still good function self-regulated valve who control the air that coming in. Continue 24 hours. So also important is the external blinds, external sun protection. So with our external blinds, we coming to reflection the sun till 90% on that, and still keep the view to outside. That's why we promoted to put the external blinds. With our zip technology, we can cover big surface till 22 square meters in one piece. With the zip technology and external blinds, is the important thing is that we block the heat before it heats the glass, that you can use it in every weather situation, and you still keep the nice view to outside. Here's an example that you can see some nice surfaces, big surfaces, and you can control the light inside. So you control more than that. Also inside the light, you control that. Here is an example from a project in Shanghai, a high-rise building, that you see that we cover big surfaces. For here was it important from the architect that the customer still can view to the outside, and he can use it in every weather situation, and also as a double function as insect screen. Also here in Singapore, they use it also for like a balcony to as more as rain protection as well. Here you see that it's nice integrated, and the product don't need any maintenance. Here we're coming at the end. I want to show you a video about ventilation, and what do you think about it? That happened without any ventilation. But, yeah, okay. So important that you know what happens if you don't have any ventilation. And you need ventilation 24 hours. Refer also to the residential market. Is it also important? Resorts, if they're closing the rooms, what happens with the mattress? So thank you for your attention. You can still reach me at the exhibition table, and for further contact, you can reach me as above. I'm located in Singapore. Thank you very much.
Thank you, Stefan. From ventilation, we move on to coatings. Franck Derouen, Global Segment Director, Architectural at Axalta, will be talking on sustainable solutions in powder coatings. Franck.
Thank you very much. So good afternoon, ladies and gentlemen. I am Franck Derouen from Axalta Coating Systems, and I'm going to talk about how powder coating can contribute to the sustainability of facades and buildings. Okay, just a quick update on Axalta first. So we are we are a US-based company, multinational company. We have been involved in coatings for the last 150 years, so we are not fresh. Roughly net sales around $5 billion per year. Yeah, I mean, we are present everywhere in the world. We are in the top 10 global coatings companies. Wow. No. So, sorry, I pressed the wrong button. It's confusing. Okay. Voilà. I'm lost, huh?
What's the issue?
I don't know. I was pressing this one. It was going backward.
No, it won't.
Oh, really?
Yeah.
Okay. Okay. First of all, so I mean, sustainability is a key topic for Axalta. I mean, we have, now it's coming to reality. We have been talking about sustainability for many years within the industry. Now we have clear objectives, and now we have to deliver. First of all, I mean, let me mention that Axalta has been audited by a third-party laboratory named EcoVadis. And this, let's say, a third-party company or auditor awarded us the silver, let's say, label, which means that we are in the top 25% of the company that, let's say, subscribe to this program. When it comes to powder coatings, we have, I would say, within powder coatings, I don't want to enter too much into the details because I'm sure you know about that. There are 3 types of powders, roughly. What we call AMA 2603. We name Alesta AP. We have Alesta SD for AMA 2604, sorry, and Alesta UD for AMA 2605. If we kind of rank all those series in terms of sustainability, I mean, we think that Alesta SD or AMA 2604 is the most sustainable quality. Why? Why super durable are the most sustainable qualities? Because first of all, compared to liquid paint, it does not contain any solvent. That's a particularity of powder coatings. So no VOCs emission during curing, no VOCs emission also on the building. There is also no hazardous waste during the applications, unlike solvent-borne coatings. No environmental hazard pictograms on the boxes, so it means that it is safer for the workers and for the environment. Longer life expectancy compared to standard durability powders. Okay. And compared to fluorocarbon powders, there is no, let's say, critical substances. Unfortunately, or fortunately, I don't know, but it's a concern. The European community now is putting the fluorocarbon polymers into the spotlights, and there might be, let's say, a ban coming up soon. So this is why we think that super durable powder coatings are currently the most sustainable systems. So moving on what this kind of powders can offer. I mean, of course, EPD, it's important to have the environmental product declaration, let's say, available, and we have it. So this explains, I mean, say this screen the whole process of manufacturing and sources of products up to his destruction, and we have APD reports for Alesta SD super durable powder coatings, and also LEED is important. LEED is is a voluntary specification. It's been now recognized worldwide, and powder coatings can contribute to LEED. Everybody talk about LEEDs now. There are several rating systems. There are 6. I will not go into the details because I'm sure you know. I mean, for powder coatings, the most relevant are, I would say, building design and construction, interior design, residential, and operation and maintenance. And we think these criteria, the most relevant ratings, are sustainable sites, indoor and quality air, so material and resources, and innovation in design. Okay, the maximum of points can be achieved in LEED is 80 points. And out of these 80 points, powder coating can contribute to up to 8 points. So Alesta SD can contribute to 8 points to a LEED, let's say, certification. Again, I will not go into the details here, but we can contribute in all the, let's say, rating systems. This survey has been carried out by an independent laboratory based in Italy named RENA. So 8 points. So Alesta, we can contribute to 8 points in the LEED certification. But performance is also can also have obviously a sustainability impact. Okay. Again, the 3 series we will focus on super durable Alesta SD. The performance in terms of durability is very important. We also have very good scratch resistance compared to other coatings. Lower energy consumption during curing. Longer lifetimes, this is also sustainability, and also lower maintenance costs because those products are kind of richer compared to standard quality powders. So the cleaning cycle or routine is less. Okay, durability comes with warranties. Okay, these products can be covered by a warranty up to 25 years. And this warranty is not a product warranty, meaning we don't warrant only the compliance to the technical data sheet, but we warrant the product performance on the building in terms of color fading, gloss retention, and coatings integrity, products integrity. Scratch resistance. We made a lot of research on this field because scratch resistance is an important topic, especially for fabricators. Better scratch resistance means less touch-up, less damage during handling, less damage during fabrication, less damage during mounting, meaning less touch-up. Less touch-up means that it is more sustainable. Qualicoat specification recently issued a new guidelines in terms of scratch resistance, and compared to Qualicoat specification, Alesta SD perform much better than the limit. You can see on this slide several examples of coatings that were scratched with the same process, with the same device, which is named Martindale test. So obviously, I mean, the glossier the product, the critical the scratch. You can see on the top a glossy effect, a lot of scratches, and if it is matte or even if it is fine texture, the toughness is much higher. But when compared to Qualicoat specification, those products perform much better. For Qualicoat, the minimum gloss retention is 30%, and with Alesta SD products, we are between 70 and 90% gloss retention. Fire resistance, also an important topic. Those products were assessed, and it comes with a fire resistance certificate. It's classified A2 according to EN standards. Sometimes we have to repair, and unfortunately, I would say, but as Axalta also manufacture liquid paint, we have repair system, and we can perform repair on site. sealant adhesions for structural glazing. Also, we have to make sure that the products will perform well, and there will be a good adhesion with the sealants. So this is also carried out in cooperation with sealant manufacturers. We talked about aluminium mainly when it comes to facade, but steel is also an important topic. And it's always kind of headache when it comes to durability. And again, durability is sustainability. We have unique solutions for steel, named Plascoat PPA 571. It's a powder coating, so it performs as a powder coating for aluminium, and it gives the same property as powder coating on aluminium, but on steel. Same finish and similar maintenance system, which means very less. Okay, those systems, powder coatings, can perform very well up to C5M environment, which is a marine environment, and we have a test report about that. It can be also repaired on field. Okay, the dirt and the graffiti can be easily removed. It can even be recoated, overcoated with a normal or traditional powder coating like Alesta SD. So if you want to have exactly the same color on fencing or on gates or on light poles or furniture made of steel, it is possible. We just have to recoat or overcoat, Plascoat with the same color as for aluminium. Otherwise, the product can be used as a single coat system. And as for Alesta SD, it's got also a good reaction to fire. We have also, of course, finishes. We invest also a lot of money in finishes, metallic finishes, fine texture finishes, because design is an important criteria. Track records worldwide. So we have these 3 buildings in the UAE. In Festival City, it's a neighborhood named Festival City. This is the Intercontinental Hotel, the Crown Plaza, and Festival Towers. So three buildings quoted in 2006 with Alesta SD. Closer to us, we have Exchange 106 in Kuala Lumpur. Closer and also quite recent in 2008. This building was also coated with Alesta SD, a gray metallic finish. In Australia, it's also an iconic building there in Melbourne. In Belgium, a new tower, Ensor Tower, with a metallic finish named Lunar Chrome. So in China, a nice building. It's a nursery. In Lyon, fine pearl also of metallic finishes. Metallic finishes are obviously very much in demand. But not only metallic finishes. This is also a building in Amsterdam with variations of grays, whites, and black. Okay, in the UK, the color is cotton, so it's cotton steel, but on aluminium. So it's a color matching the cotton steel. We can make that fine texture, and many others to come, obviously. So I'm done with my presentation. If you have any questions, feel free to come to our booth, just on the right in the dining room. Thank you very much for your time. And I will leave the floor to the next speaker.
Thank you, Franck. We move on to the last speaker of this session. This is on security glazing using advanced interlayers. Malvinder Singh Ruprai from Kurare will be presenting on this topic.
Okay. Thank you very much, Ahmed, for the introduction. So ladies and gentlemen, I'm the last hurdle that you have to cross before you get your coffee. And Ahmed loves to give me this spot always. Yeah. So my name is Malvinder from Kurare, and we are one of the leading manufacturers of different types of interlayers for different applications of laminated glass. And today I'm here going to talk about security applications, which is a growing topic of interest for many countries. And why I'm saying that, because even a country like Singapore, which is considered like one of the safest countries in the world, still it's making use of blast-resistant facades for its infrastructure buildings like airports. So definitely it's a topic of interest for other countries. And before, it's an obligation for me to talk about my company. So we have solutions, interlayer solutions for different applications of laminated glass. And as I mentioned, so today I'm specifically going to devote this next 15 minutes to structural and security applications. So this is a global map of various incidents of terrorism that have took place in the recent, since 2020. And you can easily imagine that no country in this world has been spared because of this rising incidents of terrorism. So there is a growing need for protecting the infrastructure buildings against these kind of attacks. So we can say that the specifications for the glass are becoming more and more demanding. Glass is expected to bear the kind of loads which was never intended in the past. You know, it is no more the wind loads and live loads, but it also blast loads which are coming into picture. And also there are some kind of civil unrest in the countries where people are trying to make a forced entry into the buildings. So the expectations from the glass are becoming more and more complex. So what are the situations when you may have to use security glazings? These are some examples, starting with ballistics, when somebody is carrying a firearm, and burglar-resistant blast. There can be facilities like detention of mentally challenged people, or then there could be incident of fire, flood barriers, forced entry, hurricane, and safety. Yeah. So the breakage pattern of the glass is something which is governing the behavior of glass in security applications. So we can see the glass on the rightmost side, which is laminated glass. It is definitely the type of glass which is the most safest one. But just making use of a safety interlayer, which is a PVB interlayer that is most commonly used, does not make it a security glass. Why it is so? Let's see the difference here. To make a safety glass, the PVB interlayer is the most commonly used interlayer. And whereas if you want to get a security performance from that glass, you need to make sure, first is the type of the glass that you're using. You can't use tempered glass for this application, which is a strict no, because as we know, tempered glass breaks into small fragments, so it does not have any post-breakage retention. And then you can't use just any type of interlayer, because it really depends on what is the anticipated threat level. So the basic intention is to increase the amount of break-in efforts and the amount of the time that is taken by the person to intrude into the glazing. So it can't be considered as a standalone solution. Yeah. So there have to be other means of, like alarm system should be there so that alarms are expected to go active whenever there is a barge-in happening into the building. Okay, so when we talk about security hazards, then the threat could be because of when a person is trying to enter into the building by carrying anything which is coming into his hands, maybe a sledgehammer, maybe a pipe, or it could be a more severe threat when the attack is happening when the person is carrying some firearms, or it could be more complex attack, like when a bomb blast is exploding outside a building. So we saw some years back, this is what happened in Lebanon, where a huge amount of chemical which was being stored in a warehouse, it exploded, and the buildings surrounding that place, they had a catastrophic damage. Yeah. So how do we rate the security performance of particular glazings? So luckily we have some standards available. On the left-hand side, you can see there are some standards, which are European standards, and the American standards are there. So these are giving a test method description, how the test has to be done. So the basic level is, you can see this is a pictorial depiction of the test, how it is done. This is a 4 kg steel ball, which is dropped from a certain height, and if it is able to break the glass and tear away the interlayer, then it is considered as a failure. And then there are higher threat levels, where you have the EN 356 standard, where the intent is to make a cutout in the glass using a mechanized X. Yeah. And on the right-hand side, if you want to rate the security performance of the glass in the framing system, then these are the standards which are commonly followed. Okay, so when we talk about forced entry standards, then ASTM 1233 is one of the most commonly followed standards, which categorizes the different types of weapons that could be used during the attempt made by the intruder. It could be a blunt impact. You can see the weapons are sledgehammer, and then if we get into more complex levels, then it could be a combination of mechanical and chemical deterioration of the glass. So on the right-hand side, I have a picture where a very recent incident which happened in the US. A man just drove into his this Apple store using a high-speed SUV car. So sadly, one person lost his life. So after this, the people who got infected because of this accident, so they tried to file a legal suit against Apple because the Apple designed the glass facade, which was strong enough to resist the attack of the car. So that, as I mentioned in the beginning, that the expectations from the glass are increasing, really becoming very challenging. And then I have a video over here. This is a real time video where you can see how people become innovative and they try to break the glass. This is from one of the incidents which happened a couple of years back in the US. So just in the interest of time, I will just cut it short. Yeah. So then we move on to higher threat levels, where the intrusion is being made by using a firearm. So this is a standard which is a European standard, starting with BR1 to BR7. These are the threat levels, EN 1063 standard. And then there is another standard which is a UL standard and the NIJ standard. These are American standards, and they have given different threat levels. So whenever you're designing a particular glazing against a particular threat level, we must know the anticipated threat level. So if you know the threat level, then we can give you a solution for that. And these are some of the expectations from the glazings, that it has to be durable, lightweight, transparent, and it is expected to have a long life, and shouldn't there be need for replacement of the glass because of delaminations. So then we make a comparison here between the bullet-resistant glazings, which are making use of conventional materials like polyurethane and polycarbonate. And I would like to mention here that the yellow line that you see on the left-hand side is making use of a polyurethane, which is a material which is used to bond PC with the glass. And this is the weakest link in the BRG constructions, which cannot withstand high temperatures. And that is the reason we have advanced interlayers using Sentriglass and Spall Shield that can withstand high temperatures like 100 degrees centigrade temperatures for a time period of 16 hours. So this is basically the high temperature test which is specified by the EN ISO 12543 standard. And this is a test report that we have. Whatever claim we make, we have proper test reports for that to back up our claim. And then we make a comparison of the weight reduction that is possible by using the advanced interlayers. So one of the leading glass company in India is promoting their BRG solution for BR6 threat level, which is almost 70 mm thick. And compared to that, sorry, not BR6, it's NIJ level 3. So our solution is just 37.9 mm thick. So there is almost a 40% reduction that is possible. Yeah. So I mentioned about one product which is CPET or Spall Shield. Just wanted to make you understand what's that. So this is a ballistic test video where you can see the bullets are being fired on a piece of BRG glazing. This is the attack side where you see lots of fragments of the glass when the bullet is hitting the glass. And this is the protected side. So the intent here is to not to have any, even the smallest of glass fragments can actually injure the person who is sitting next to the glazing. So we have a PET film which is bonded to the glass and which catches all the fragments and doesn't allow any injury. Yeah. So you see, even when the third shot is fired, there is no spall on the other side. Yeah. So this is absolutely safe. Yeah. Okay. So we did a test which we call as depth of penetration. So basically this is to measure the amount of resistance that is provided by the bullet, by the interlayer when a bullet is being shot. So we conducted this test on different types of blocks made of different types of interlayer. As you can see, we have a Trocifol B200, which is the PVB, and then middle one and the last one is, these are structural interlayers. And if you notice the amount of penetration of the bullet into the blocks, this is the minimum in the structural interlayers. Yeah. So basically our structural interlayers provide a very high degree of resistance to the bullet that is penetrating. Yeah. And here we have a comparison here. So you can see the bullet penetrated almost by 84 mm into the block of PVB, and in case of Sentry glass it was 41 mm only, which is almost the same as polycarbonate. Yeah. And then when a BRG is exposed to different types of chemicals, it may come into contact with some chemicals during its cleaning. So as you can see, the CPET beats the standard materials like acrylic and polycarbonate. It's extremely resistant to the attack of these chemicals. So I mentioned about the blast-resistant glazings. So we can support you there by optimizing the glass constructions that are desired for a particular threat level. So if you have idea of the anticipated threat levels in terms of the peak pressure, the impulse that a facade is going to bear, then we can do the blast simulation for you and help you optimize the glass construction for your projects. Yeah. So this is the pictorial depiction of the General Services Administration, GSA standards. So level 1, basically this is giving you an idea to choose the solution, because as you can see, the level 1 is the most safest solution, and level 4 is not really as safe. And level 2 is generally most commonly specified. So basically it's telling you how the glazing will behave after the explosion. So this is my last slide, and I'm just going to recap what we have seen in this presentation. So by using the advanced interlayer materials that we have for BRG applications and security glazings, you can high optical performance, high durability of the glazings, and you can make them lightweight because with the use of Sentry glass, which is an advanced interlayer, it is possible to make the glazings lightweight and thinner as well. And the most importantly, durability is the most important point which I want to mention here, that they can withstand very high temperatures. Yeah. That's all from my side. Thank you very much, and enjoy your coffee.
Thank you, Malvinder. Any questions for Malvinder or any of our other sponsors? They have a booth outside. We'll take a tea coffee break. Can I request the speakers of this session to come on stage? Can I request Mr. Benedict to come? The next session, we have two presentations, one from Agnes Colte, one from Florum. And then for the first time, I think we are attempting this in Singapore. We have a project discussion. We have a discussion from the architect, the investor, the facade consultant, the lighting consultant, from project to completion on the Lazada headquarters. And then we break for the networking after the event. So I'll see you back in 20 minutes. Thank you. Right, we'll start this session. Welcome back. This is the last session, as you all know. Some people call it the graveyard shift, but we've tried to keep it interesting. Our first presenter for this session is Agnes Colte. She's going to be talking on tips on how to design and build well-performing facades. She's flown in all the way from Dubai for this talk. And over to you, Agnes.
Hi, everyone. Nice to see you back. So my presentation is about talking about how to design well-performing facades. We are a facade consultancy. I started the company in Dubai 2011, and then 2016 opened an office in Singapore, and since then we have a presence in Southeast Asia and working on projects in this region as well. During COVID, it even expanded more to projects worldwide. Since you cannot really travel, it doesn't really matter where the projects are. So we started gaining footprint in Africa and more in Europe. We are only doing facade engineering and facade access consultancy. So it's very, very specialized. And of course, as first tip to how to design well-performing facades, I would say employ a facade consultant, and thank you very much for coming. This is my presentation. But I have a little bit more to tell. So first of all, let's start with buildings that are existing. And they may have performed well when they were new, but they aged and time has passed. They are up for a refurbishment, maybe even adjustment, alteration, addition. A lot of projects are coming up here in Singapore as well, and recently even in Dubai, buildings that are aged. That's one of the examples. It's a GW Marriott hotel. The owner of the building also owns the mall, which is connected to it. And we started this project with the promise that it will be the least interruption to their operation. And they wanted to close the hotel a little bit, but the mall wanted to stay operational phase by phase. So first of all, refurbishing, big topic. So on this project, it was all set up in a workflow. The team are removing, it's currently under construction still, removing the existing cladding. This is a mall portion from the outside the cladding, from the inside the glazing and the windows. And then a new semi-unitized system comes in place, which is prefabricated out of sight. So when it arrives, it's really quick to put together and to go on with. So they install that from the outside, and in the minute when it's installed, the building is actually air sealed, water sealed, so operation can go on and the business in the mall can continue. Then the prefabricated element of cladding arrives on site. We have these air ducts, existing air conditioning system, ventilation system. They are cladding over, and the building continues to operate. So I mentioned it's a semi-unitized system. On the vertical mullion, you can see it's a two-part mullion. That was the short part about existing buildings. For new buildings, we have to start with design. And when we talk about design, these days, almost every architectural office works with parametric design. And there is a problem with parametric design when it comes to talking about the end result and the quality, the performance of the end building. And that problem is that it's a bit too easy to design in those softwares, so-called crazy things. Even if it's not crazy, but it's crazier than reality, even if it's just tiny bit crazy. After that, we go to fabrication, delivery, installation, and the whole workflow may not be as sophisticated and as automated as the parametric software are. So commonly used parametric tools plus additional nice ideas about trying new materials, making it very energy efficient. And then it comes to fabrication. And for the fabricator, there are available BIM tools, all kinds of computational tools. But traditionally, it's not necessarily used. There's a small portion of contractors who are invested into this type of technologies, but the reality is they are tied to competitive pricing and trying to use the existing technology. It's so-called still not enough demand to change methods. But even if there are a number of contractors who can do more customized pieces, when it comes to delivery, it comes with logistics problems. So when a system is not repetitive enough, but each piece has its own location, own position, delivery has to be very well organized, and the labels on the units have to be very clear, and the people who are receiving it on site have to be very well informed about how to handle that arriving materials and where to put them. So as you see, a lot of things can go incorrect during this process, and that's unfortunately the problem with parametric design. There's a problem with BIM as well. BIM is an excellent tool, and it's more and more on demand. It's very good for the developer for many reasons, the building owner to start the design in BIM and then using that model all the way and keeping it for facility management. It's extremely good tool to coordinate everything. But then the problem with it, that it brings up an expectations that in that model everything will be coordinated, perfect, everything can be done faster, everything will be more detailed, and that documentation has to be provided. And that's basically the dawn of, or the born of specialists. And I have to admit, we are such a specialist as well. But basically, just look at what's happening in medicine. You look at this list. You find everyone here. You don't find a GP. You don't find a family doctor, because GPs don't heal anymore. They they can consult and then send you with your leg to the leg specialist, with your head to the head specialist, with your heart to the heart specialist. And this is something that's happening in architecture as well as I see. The architect does not have time to process everything and cannot allow the luxury of looking up everything himself or the team itself. There are these specialist teams who are very well experienced in a certain topic, but then that's it. And sometimes these interfaces in between the different teams could be risky. So that's kind of a re-evaluation of the role of the architect. It's not the person who knows everything. It's more like the person who has to coordinate everything in between the different teams. But I'm happy to hear your opinion about this. This is how we see from the sub-consultancy area. So yeah, when does engineering becoming architecture and when is architecture engineering? But let's say we designed the project and it's well coordinated, nothing is missing. Next step is testing it. And that's something important. And when we again talk about the end result and how well performing will it become, there is the testing that we all know, like laboratory performance mock-up testing. But beyond this, it's worth to spend time to allow for test whatever is interesting on the project. I don't think that we should shy off from something just because it's not tried and tested, or we should not do anything because there's not a standard for it. That's the beauty of facade engineering and architecture, that we can come up with new ideas, new setups, and then there are the tools. There is that laboratory. It doesn't need to be a standard test. It doesn't need to be a regulation. It could be something just common sense. How can that structure go wrong? What are the risks? And let's test for that. And this happened, for example, recently in the past couple of years. We designed a fully glass slide. It's a tourist attraction in Dubai. It's 14 meter long, and it's located on a high-rise building on the 53rd floor, and you are sliding up to the 52nd floor. And as you can imagine, there are no standards for how to design a glass slide. There are standards for playground slides, but they are not made out of glass, and they are not having the risk of falling 53 floors. So we had to improvise on it. First of all, we were not sure what would be the correct, the most optimal inclination of the slide. We could look at playground standards, water slide standards, but not necessarily glass slide standards as a tourist attraction. So we got a mock-up built, which was not out of glass, but the surface fraction coefficients matched, and tested different inclinations. It was an absolutely arbitrary made-up test, but it brought the result that we were looking for. And then each component of the slide was tested separately, and again tested to failure, and then more failure and more failure. Here you see this connection here. First, what it needs to do by design is still stand if one light of glass is broken. After this test, we went on to see where is the weak point, and we kept breaking more and more lights until all of them were broken. And we were very happy to see that it can still keep in place. Or, for example, here, definitely there's not a standard test which would say that me and 3 people has to stand on a piece of glass, but it's very relaxing to know that even if the lights are broken, it still has the capacity to keep up, and it will be safe. So we came to the half of the presentation. It's all design now. So you may say the dream has come true. We have a well-performing facade. It's coordinated, designed, and tested. So what it takes to manifest this dream into reality. On the designer side, from this point, the project will be taken over by the industry. So the more awareness the designer has on real-life practicality, and if it was injected in the project at the right time, the better the outcome will be. Cost awareness is quite important. Even if we are not cost consultants, the architect definitely doesn't want to be cost consultant, but to know what the client is aiming for and what can be afforded from that much in order not to have negative experiences. That's an important thing. So awareness of the prices, asking suppliers, contractors about pricing is a very important part of design. And then with new materials, new ideas, we can either wait until it becomes more mainstream, or we should do some testing in detailed design phase. And yeah, on the contractor side, please embrace the software tools and see how they can be implemented to help the production, not only the production that you can do, but the productions that the architects and developers would like you to do. And a few more very important things where the project can go incredibly wrong when it goes on site. Tolerances, adjustability, accuracy of the construction, and simplicity of the design, simplicity of the detailing. So these are all considerations which have to be watched all over during the design process. If there's no adjustability in the system, tolerances are off, it will never be watertight, it will be airtight, it will always just cause a problem. And then I put last one here, curiosity, which helps to push the limits, helps to find interesting solutions. It could be interesting in the aesthetic way, but it could be interesting in the cost efficiency way, or the practicality way, or the speed of construction way. Curiosity brings enjoyment in the profession. So the next three sections will be some examples, some interesting use of materials which we implemented recently in different projects, and I hope it gives a little bit of motivation to all the architects, facade consultants sitting here to be brave to use any material. So anodized sheet cladding in Singapore. So why is it more interesting in Singapore than anywhere else? That's because Singapore has a very strict regulation on glare, specular reflection. So there's already one problem with anodized sheets. The color consistency will not be the greatest within different batches, especially not the greatest within different or among different applicators, but sometimes even within the sheet there could be different patches. So a good solution of it, something like a design tool that this building uses, which was not our building, but it's a nice Jean Nouvel building in Paris, the Philharmonie, to use different shade of anodized sheets in a pattern where you keep that velvetness, velvety look of anodized finish, but then you have an interesting play with the colors. So anodized finish, interestingly, the glossiness of it is very much influenced by the base material that you start with. So different aluminum alloys can result in different level of glossiness. This was a project in Singapore. It was a supplier that had not had project in Singapore, but they sent to the local laboratory the samples, and the measurement was ready in a week. It's a very easy measurement. So the specular reflectance on this sample, as you see, is like 2%, 1.4 actually, which is really, really good. Brass. So brass is another material which is beautiful, and it's associated with some kind of elegance, but you know, more than a restaurant main entrance, it's very rarely used due to its price. And yes, the price is there. But even if you find someone who wants to pay that price, have to be very careful with the specification of it and the surface treatment and the care and the selection of it, because it can be tricky. So these are a couple of samples. Unfortunately, on this photo, nothing is visible. They are not yellow and purple in real life. They reflect the light differently as you go around. But basically, on the right-hand side, it's burnished finish. On the left-hand side, some of them are, no, actually, all of them are stainless steel, which try to look like brass finish. So it's like magnitude cheaper stainless steel than brass. But really, you cannot get the same experience, exactly the same experience. So brass is an alloy of copper and zinc, but if it's untreated, it goes very dull, matte, and very lifeless, very fast, within a month, depending on the environment. If it's a maritime environment, is it polluted or not? But like this building here, you see, it started off with relatively shiny brass frames, and it ended up very boring. It looks like an old powder coating rather than brass. So really the money that got paid for it was not a good return. There are ways to, to keep it live, basically wax is the best solution, but wax has to be applied and reapplied every 3-6 months, depending on the environment. What can you do with brass? It can be like an overcladding or around the mullion. It could be just the cappings, or it could be a complete brass door frame, depending on the use. These solutions are actually all used on a museum project that we are working on. And then another interesting material, cast glass. Well, I think it's wow, and if you look at these samples, I do think that it's wow for many of you. When you look at it, you don't really think that it could be applied on a building. It was a lot of testing, a lot of thinking, managed to do it. It's another museum in another country. This is a sample, which is relatively small size, like a meter by meter. It's every 60 millimeter thick, the slab, and it has this pattern, and the building will look like something like this. So these are very big piece of glass slabs, 2.7 by 3.5 around, and it's like a rain screen cladding. Outside, it's stepping back. There are some areas where it's vision glass, where the museum, it's an art museum, where the museum needs some lighting, but most of the museum, it's a very diffused, very nice light. So this is the second project in this presentation where I would say that we really feel that, or most of us in the company are architectural background. Some of my colleagues are structural engineering background. But, you know, even if facade engineers are usually following the architectural ideas, there are some special structures where we can really input with aesthetic ideas as well. So the glass slide was one of them. And the other one here, we are quite proud to the steel structure, how it's formed. This project is currently on tender, so hopefully it stays like this. But the steel structure here is designed to follow the architectural language, the steps, and the whole nature of the project. So basically, this is the end of my presentation. Just lost something thought for the, for your afternoon, for your evening. What about AI? These days, basically everything is AI. It's a very good buzzword. Suddenly, all the little software became like AI. But there's some real AI, which you may have heard, ChatGPT and Midjourney. So basically, in this presentation, every image which was not a photo or not an architecture render was done by Midjourney. I enjoy doing Midjourney. This is what Midjourney came up with when I asked him to give me high-rise buildings which are typical Singaporean. So typical Singaporean, it seems like noodles and the merlion. Merlion with some vegetation at the back. And somewhere it's true. On the other end, of course, if you ask an architect to give me an idea of a skyscraper which is typical Singaporean, it would not be a noodle building or a giant lion. But anyway, we have to think about using the technology and not letting the technology drive us. We have to be ahead, and other than having some nice images during my presentation, which were done in a matter of minutes, there are more practical architectural uses of these tools as well. It's not yet clear. It's not clear to me either. But definitely, we have to be ahead of technology, and manufacturers, as I said before, has to be even more awake to see where the trend is going. So thank you. These are our contact details. My Singaporean colleague Omar is sitting here as well. You can contact us anytime. Thank you for your attention.
Thank you, Agnes, for an interesting presentation. I love the AI part. Lots is happening with ChatGPT and others. Okay, we move to our last presentation for the day. We've got David De Petuco from Florum. He's going to be talking on the cladding product, which is a sintered stone. Ciao, David.
Thank you. Okay, hi everyone. My name is David De Petuco. As you can understand by my accent, I'm from Italy, as well as the company. But let me introduce a little better the company. The company is 60 years old. The turnover is around 480 million. And how you can see, the company basically spent 280 million, so half of the turnover 1 year in the investment in the last 5 years. That to show you the company is very keen on the novelties and the innovation. For 1,400 employees all over the world. The location, we have 3 manufacturing plants, one in the United States, which is only for the local market. Then we have 3 factories in Italy, and they serve the worldwide market. We are basically worldwide with our flagship store, as you can see. And of course, we are also in Singapore, in Mohammed Sultan Road, so River Valley area, Robertson Quay, where we have our flagship store, and we also show our real scale mock-up for facade. A great attention of the company to the environment. That's why in March 2020, we became a benefit corporation. So basically, we declare our commitment to the people and to the planet in our company statute. In December 2020, we did also an additional step. We became a B Corp, which is basically we are only the first and the only surrounding company having this kind of certification. And basically, this certification has score between 0 and 200, and to be classified as B Corp, you need to achieve at least 80 points. As break-even between the Italian and the American company, we achieve 90.9, and with from Italy, we achieve 98.1. But this process, of course, is an ongoing process, so every year we need to improve ourselves to achieve better results, let's say. Big attention to the environment. Basically, the company is self-sufficient in terms of electricity. We have cogeneration plan. We recycle 100% of the water, and we use only natural material. We do have all the worldwide certification in terms of green label, as well as the most important for Singapore, which is the Green Building Certificate, and we are classified as platinum. So basically, if you specify and use our product, you can achieve in an easy way the green mark of the building. But let me show you the production process of this natural material. So we start from natural elements like feldspar, kaolin, sands, but with the factory process, we develop these big slabs.
Everything starts with the soil, with the pursuit and selection of the finest raw materials nature has to offer. Precious ingredients are carefully mixed, ground, and dried. A conveyor belt leads them towards the rollers, where they are carefully pressed. They thus become an uninterrupted soft carpet, which continues on its way to becoming fluorine, magnum oversize, in its immense proportions, reaching a size of 320 by 160 centimeters. The cut slab is ready to be dried again and embellished with digital graphics. At this stage, it enters one of the many kilns that fires it at more than 1200 degrees. This process makes it solid and hard-wearing. Fluorine. Design is our passion.
Okay, so here we explain the factory process. So we start from raw material, and with the factory process, we develop these big slabs. But let's see the advantage of using this product for the outdoor application. First, you have seamless surface. That means that we can cut the number of joints. And we know that for architects, it's very important to minimize the joint as much as possible. Reduce the installation time because it's a very simple system, and after I invite you to have a look, we have a small mock-up, so we can explain you in the details how it works. Lightweight, easy to be handled, resistant to high low temperature, UV, weather resistant for Singapore. Many times I got the question from the architect, is suitable for Singapore weather, totally suitable, and later on in the technical specs I will show why it's suitable. Scratch resistant, completely waterproofing, and wide variety of application and graphics and sizes. The biggest one is 1.6 by 3.2 meter, but of course we have other sizes, and in terms of finishing, you can go by the concrete look, steel look, marble look, and so on. The advantages of using this system, this application, also called as double skin of the building. Aesthetical point of view, you can achieve the look of the natural material as marble or as the steel, but without the issue of the maintenance of those materials. As we know, marble is beautiful, but has limitation in terms of performances. It's waterproofing, and it protects the actual wall of the building from the rain, so the rain never touches the actual wall of the building. You have advantage in terms of energy saving, especially if you install also the insulation panels in the cavity, Is soundproofing as well, since the cavity can help in dissipation of the sound waves. Aesthetic, you can see, you can play with the shape, you can play with the finishing of the material, glossy, matte, velvet. You can play also with the light in the back, you can see in the first picture. So many different advantages, so it's just up to the, the creation of the architects. Maintenance, the color of the porcelain material won't change in the weather and the time. Porcelain tiles are resistant to the atmospheric agent. The porcelain tiles are not porous, so they don't absorb any stain, any pollution, and any humidity. That's why they are perfectly suitable for Singapore weather or anyway for the Asian weather. It's possible to wash the facade and also to replace easily the single panels. Here the technical specs, how you can see, the water absorption is very little. We are talking about 0.08%, so basically zero. Scratch resistance, the resistant, frost resistant, of course, is not the case of Singapore, but we did some project in Quebec, in Korea as well, in Japan, so that is a key point for the facade application. Resistant to the chemical, high concentration of acid and alkali, so that means for the acid rain. Sometimes we have this acid rain, so there's no issue with our product. And another advantage to use the panels on facade is the very small dilatation coefficient. So if you think to the biggest slabs, which is 3.2 meter wide, the dilatation is only 1.2 millimeter. So we can have a joint of only 7 millimeter, basically. But let me introduce our system. It's a patent system and suitable for the 6 millimeter thickness slabs. And it's a mechanical system approved by BCA in Singapore. So of course we need to start from the body structure of the building. It can be concrete, it can be steel, it doesn't matter. Then we install our frame with brackets and T-profile, aluminum profile. Then here you will see the application of the primer, because of course in the middle of the panel we need to avoid the vibration and the dilatation of the panel, so we also apply structural sealant. While all around the perimeter there will be hooks, mechanical hook. Here you can see the hook, and also the fiberglass mesh that we apply in the back of the slabs. So the hook is the mechanical fixing on the profile, while the mesh is the most like a safety element. So it's like the laminate glass. Basically, you can break the panels, but the mesh will keep all the pieces together. So you will have the time, the contractor, the owner will have the time to replace the panel. And then we screw the hooks on the profile. Here you can see the supporting plate. So this is very useful for the installer, because in this way they can drop the weight of the panels on these supporting plates, and they can do the installation of the hooks. Yeah, also we showcase different ways to install with the scaffold, with the elevating machine. And this is the final result. So you can also customize your product, your item, with whatever picture you want or whatever graphic you want. Okay, of course we test the system and we achieve 4.5 kPa, so 450 around kg per square meter in the pressure, so the wind pushing the slab down basically. And this was the maximum value achievable by the wind tunnel testing machine, but eventually we can go also higher than this value. Worldwide certification as the ETA, European Technical Assessment, BCA approval in Singapore, where we have different references as well. Fire resisting, as you can see, is classified as 82S1. So basically, limited combustible. The material itself is not combustible, but since in the back there is the mesh, the fiberglass mesh, then it's classified as S1, so limited combustible, so just the production of the smoke, basically. We test it also in terms of seismic load. Of course, it's not the case of Singapore, but we achieved 2.5 G, where G is the gravity acceleration. Basically, is the Sisma is the shake that you can have in Japan, just to give you an idea. And here is very interesting impact test. So 15 kg soft weight, cast it from 2 meter high on the panel. So this is the other example when they ask, is resistant enough? Let's go through a case history. So we start from the idea of the architect, the layout, then we develop the layout, structural drawings with, of course, engineering team and local P endorsement, details, corner details, and so on, and supervise the installation on the job site. You can also, of course, drill and do a wave installation on the panels. And this is the corner, so we can miter edge, so it looks completely as a piece of marble. And this is the final result, this project completely in Bangkok. Let's go quickly through all the references in Asia Pacific, Korea mainly, where we develop beautiful building, hotel, high-rise building, as well as residential bungalow, office tower. This is another example of nice application, and we have built this hotel in New York, United States, as well as this. As you can see, you can go from the marble look to the stone look to the concrete look. This one, Centura, Quebec. The architect wanted to play also with the light and with the custom-made shape, so we were able to produce it. And now Singapore, where you can see the curtain look alike, but this material doesn't stain. When it rains, it won't stain all around, and it won't change in the time. Good class bungalow, when we did feature wall as well. Another good class bungalow, just finished. I took this picture yesterday because I went on site to have a look and just finished, so I took the chance. This Croatia, also here is a custom-made module. Curtain steel in Switzerland as well. And that's all. These are my contacts. Of course, I'm based in Singapore, but I'm in charge of Asia Pacific, so wherever you have a project, you can refer to me. And then we have a local dealer in each country. And so we can assist you in terms of sample, in terms of specification, and so on. Thank you for your kind attention.
Thank you, Davide. So we are done with the presentations. We've got a project discussion, if I'd like to call it. This is recladding the formerly known Manulife Center, where they have used an existing building instead of breaking it down and building it fresh. I'd like to call upon our panel moderator for this, Matthew Mayer from DP Architects. He's going to be, from DP Facade, I'm sorry. He's going to be leading this discussion, and he will call his panelists on stage. Can you please switch the screen, please? Yeah, thank you.
Hello, everyone. I'd like to call my co-panelists on stage. We've got Lorraine Lai, who's the head of asset management at ARA. Thank you, come. Christine Chan of DP Lighting. It was Women's Day yesterday, so I'm doing the women first. And Tan Chi Yong, who's director of DP Architects. Thank you.
Oh, so you're going to sit?
No problem. I'll take the chair. All right, so this is a slightly different format to what we've done before. It has only been done twice before at Zak in New York and London, so we are going to hopefully make it as interesting and as good as it was there. We have here 4 different perspectives, 4 different takes on a project. So rather than a single point of view, we'll have everyone who was involved in the project, or at least some of the key players in the project on stage today. The building was
completed initially in 1986. We'll have a few key figures in a short while.
Yeah.
And in 2019, we embarked into in the journey to breathe some new life and really reinvent this building, you know. And as a sort of introduction to what was done and why it was done this way rather than any other way, I'd like to ask Lorraine first as, let's say, the developer's perspective, and maybe I'll share with you this little clicker here.
The one for?
Yeah, the big button.
Okay,
right?
great.
To share with us what drove Lorraine and Lorraine's company to acquire this asset and to transform it. You know, what were the key drivers? What was the reason? What were the reasons for that?
Yeah, thanks, Matthew. Good afternoon, everyone. So when we saw this asset, so that was middle of 2018, we were like, wow, we found a gem, a really good asset. So this was how it looked like. It takes a bit of imagination because, like what Matthew mentioned, it's a 30-year-old building. But what we found, it has all the attributes. It really ticks all the boxes for value add. For those who don't know what's value add meaning we have to go in and do a fair bit of works. So it really ticks all the boxes. Good location. For those who are Singaporeans would know this is right opposite the Singapore Management University, which is a city campus, at the fringe of Orchard Road, our shopping belt, directly connected to 2 train lines, huge floor plates, 23,000 square feet per floor. So the building was built ahead of its time. Credit to the original developer, City Development. They built a really good building, good bones. We saw the good bones, good structure. On top of that, about 70% of the building will be vacated. So Manulife was the anchor tenant. So Manulife is the Canadian-based insurance company. They were the anchor tenant. So 70% will move out, and they were paying rent below market. So we saw all these as good potential. So we're like, wow, this is good. Old building, but good. It really ticked all the boxes. And what we did was, along the way, we had to find a JV partner because this is a huge asset. It's reported we bought it at 555 million Singapore dollar. It's a huge ticket item. So we found a JV partner, and that's Chelsea. So Chelsea is a UK-based real estate private equity fund like us. So like-minded, we shared the same view, same vision for this asset. So that's how we came together to acquire the asset.
Right.
Yeah.
And one of the things is that, as you say, you need quite a bit of imagination to just looking at it to say that this is a very, you can see some of the images on the screen. You know, you need some pretty good imagination to see the value. But of course, all the indicators were there, the economic indicators. But at the same time, nobody wants to sit on an unproductive asset.
That's right.
And so could you share with us the timeline? You indicated 2018. I think we're going to see some indicative dates there on how quickly or how slow, maybe in your mind, things happened.
So Matthew, when we underwrote everything, and for those who know what's underwriting, you're like writing a research paper, like why do you want to buy this asset? So when we underwrote in, call it middle of 2018 to third quarter of 2018, we didn't know about COVID. There was no COVID. So it was done like per normal. All right, so when we underwrote was on the basis we could do the AEI within 1 year, 12 months. But before we did the, before we acquired the asset as an asset owner, we always want to enhance the revenue within the shortest possible time. So what did we do then? So prior to us acquiring the asset in January 2019, we had a lot of groundwork done. So 2 key work streams. One, we had to do pre-leasing. So before we acquired the asset, we knew that we wanted to bring in new economy tenants. We wanted a co-working tenant as well. So we ran a beauty parade with 3 co-working prospects. We finally found Schueco. So Schueco is backed by GIC, Government Investment Corporation, as well as Fraser Property Group. The other work stream, of course, is with DPA. All right, we also did a similar beauty parade. We invited 3 architects to come in to submit their proposal based on our scope of work. And DPA came in very strongly because they proposed, and I think later on Chi-Yong and Christine will share with you, the facade and the way they treated the whole building. So we did those two work streams. And we acquired and completed the asset in January 2019. So it's about 1 year before the pandemic. So 2019, we spent a lot of time working through the scope of work, fine-tuning the design, working with DPA and the consultants, so that we are ready to call for tender. And in that same year, for those who know the building, the ground floor used to be a food court. We had Ding Tai Fung, we had a pub, so there were retail tenants, so we had to terminate their leases and move them out. So 2019 was very hectic, and thankfully it was before the pandemic. We had 1 full year to do that, to bring in Justco, and 2020 was the year if you look at the screen, we actually awarded the tender in March 2020. And all happy, all ready, wanting to start work in April, and there goes circuit breaker. So what is circuit breaker? We were in a lockdown situation in Singapore. All right, so April, May were the lockdown months, and month by month just go past, and then we're like, when can we start work? We finally started only in August. And even then, it wasn't a full opening. At any point when there are positive COVID cases among the workers, we had to stop work. So it was a very tiring period. I think Chi-Yong is involved, from the beginning stage, and he can share more. But that was actually how, what we went through. We only completed the asset, the AEI, only in 2022 May last year. So in short, we were about slightly over a year behind schedule. But thankfully, the team worked really hard. We could still complete within budget, though the timeline has actually moved by about a year.
Right.
Yeah.
And not to spoil what's coming along, but after all is said and done, how do you feel about the result, and how, more importantly, do you feel that it achieved what you were trying to do with this transformation?
Yeah, so this is really one asset. So this is a photo to show the post-AEI. This is the exact corner where Starbucks was, for those who are familiar with the building. So this is the junction, Waterloo here, and Bras Basah along the main road. So after the entire transformation, I must say we are really, really proud that we could deliver our dream in spite of the pandemic, right? So we have an asset that's well leased. So from the lowest point at about 30% occupancy, we managed to lease it up to 93% at the point when we complete. At the moment, it's 98% leased. We still have about 2% because of the retail tenants. And then the WALE is the weighted average lease expiry from 1 year to 5 years. The longer, the better. So we have 5 years, which is good. And the rents, actually, I mentioned Manulife and the other tenants were paying below market at that point in time. We have a 40% jump in our rent with all this hard work, beautiful building, nice facility and all that. So very, very happy with the result. Our investors are happy as well. So that's actually, it's really to showcase the testament and the capability of the entire team, not just ourselves, DPA as well, in working through the pandemic. On the ESG front, we managed to get a 400 million Singapore dollar green loan from the lenders, so that's another good result. We have obtained the Green Mark Platinum Award, so that's the highest accolade in Singapore from the Building Authority. And just December last year, we received an award from MIPIM Asia. We won a bronze award, being the best refurbished building. So really, I think apart from ourselves saying that it's a good achievement, it's so good to be recognized, by an external body. Yeah.
Right. Thanks for that. I think that sounds very positive. And maybe I'll hand over to Chi-Yong, or you can pass on to Chi-Yong, the controller. So Chi-Yong, we hear that the outcome was obviously very, very satisfactory for the client, which is always something nice to hear. Perhaps you can share with us whether keeping the old facade and sort of bolting on a new over it, was that a deliberate choice? What were the considerations that came into this decision to add on?
Okay. All right. It's actually a very interesting project. As Lorraine has mentioned, in fact, there were 3 contenders
Yeah.
okay, to this proposal. And one of the key strategies that we were looking at, all right, is to look at this this building, even though it is built in the 80s, okay, but we have observed that the conditions of the facade, okay, is still in relatively, good condition.
Yes.
And what the client has actually also mentioned is that, okay, minimum disruptions, right? Even though, as mentioned, okay, the 70% of the lease would be ending, but knowing that this is in a very sensitive area, Bencoolen Street, Bras Basah, MRT stations, you have SMU, you have the Armenian so-called church behind, and Singapore Art Museum. Means that, there's a lot of restrictions, or rather constraints to your working hours.
Yes.
Right? Noisy works can only happen, I would rather say that works can only, all the hoisting orders can only happen at night, okay, when, you don't disrupt the traffic and things like that.
Yeah.
All right? So the key thing in this whole thing is that, okay, we need to control extensive work, all right? So that is one aspect that we have to look at, all right? Of course, the other thing is actually budget constraint, all right? In situations like this, when you buy an asset at 555 million, all right, you basically exhaust, okay, some of your resource, all right, financial resources. So how to turn around fast and quickly, within, I would say 12 to 18 months to get the building up and ready, start leasing, start collecting rentals. So I think these are very real and very practical aspects that as architects, we as consultants, I would say, okay, we'll have to work very closely with the client and understand their concerns and requirements, right? So we presented 4 options, like so of all design, proposals, okay? It's like, it's on the menu, all right? Okay, option 1, urban edge. Okay, because, why name all these fanciful names? Because this is actually in the museum district. So there's a need to, to echo and respond to the vibrancy, to bring vibrancy to this district. And that is what the building is for. I mean, how we envisage. So urban edge, okay, I'll just, reclad the GRP round columns, okay, to aluminum cladded panels, keep the building very streamlined, very simple, very sleek. You see the bottom 3 levels like this. First story is actually the current retail that we do some reconfiguration. But as of all AEIs, we always endeavor to find more leasable areas. So what we've done is that we converted 2 stories of car parks. Okay, because this asset is next to 2 MRT lines. So within 200 meters radius, there's a certain range-based discount in terms of the car park provision. So we are able to convert it into car parks, right? We free up 3 stories. So initially, the idea is that these 3 stories, L1 to L3, are our areas of focus. Spend the most money at, all right? So that's for option 1. All right, if you're a little more budget, okay, because initially we did not know what is the, what's the purse, all right? So city line, okay, a little bit more, all right, horizontal fins, to dress it up, Option 3, okay, the lattice, okay, a little bit more elaborate, all right, to give some vibrancy or some rhythm. Of course, our preferred option 4, all right, something more, I will not say complicated, but rather more, to us, it's actually more interesting. There are a lot of fins, glass fins, aluminum fins, right, to echo the downtown canvas because, as I said, museum district, you have art schools and all this, and museums, right? So 4 proposals, right, 4 options, but that, I mean, during this period of time, actually, we were also exploring certain aspects, or rather approach, how we do asset enhancement initiatives projects, AEIs, okay? We're looking at sustainability approach, right? Because for us, okay, instead of tearing down buildings, extensively removing facades, all right? how about keeping it, as a way to address low carbon footprint, right? And also retaining as much as we can, and reducing waste, right? And most important of all, how to improve the thermal comfort of the interior, okay, through facade, right?
Yeah, so the older glass, which was still good, in good condition.
Yes, correct.
Interestingly, it was a double glazed facade, which was surprising for a building of that age, still looking good. And so perhaps you can share with us what the improvements were after the idea.
Yeah, exactly. So we did some simple, in-house simulations, okay, modeling, energy modeling. Okay, so we realized that the existing facade, the average solar irradiation is about 485 kilowatts per hour per square meters. All right. So running through the options, obviously, if you look at the improvements, okay, with the various options, right? The most complicated option, option 4, downtown canvas, okay, can reduce up to about 40%. Okay, so this is how we, convince the sort of present to the owners. What it translates means that, okay, there's a significant reduction in terms of the aircon load, okay, the comfort and aircon load, okay, of the interior, energy saving, all right? So eventually, okay, we do a comparison. So various facades, because this building is essentially facing southwest and southeast mainly, all right? So essentially, it can reduce up to, I would say, average 35%, 30-35%, right, of solar irradiation, okay, by introducing the fins, all right? So, okay, hold on. It's just going backwards. Okay, all right. So we introduced a combination of aluminum panels, and to enhance the colorful aspect, okay, of the facade, okay, we put in glass fins, all right, to sort of to give it certain vibrancy and composition, all right. So I think Matthew will share a bit later, okay, on the so-called the detailing, right? But what it means is actually as you see, okay, the round columns were replaced by glass spandrel glass, okay, panels, okay, to sort of to remove the bulkiness, all right. So in that sense, okay, it helps to form certain kind of composition, all right, nice composition, okay, on the elevations, all right. So this is the end, sort of the end product. Okay, this is facing wait, hold on, Bencoolen. All right.
This is the corners.
Yeah, the corners, the
very
treatment.
elegant,
All right. Okay. It took us quite a fair bit of studies, okay, to sort of address the round columns, because it's actually really round columns and very bulky.
Yeah,
all right.
right,
And in fact, it's actually right at the boundary setback. All right. Anything that we added, okay, it will protrude. Okay. So we have to go through a lot of rounds, okay, to sort of shave and all this. Okay. So very challenging. All right. If you've seen the news, the golden monkey, this is just a balloon. Okay, it's not a real.
It's not, right. Inflated
right?
monkey.
Yeah. So it happens last year in April to August during Earth Day. Yeah. All right. Yeah. Okay. Some of the views are so actually quite nice. In fact, okay, looking out from the office, this is actually the floor level 2 converted from car park. Looking out. So the fins are arranged out, because the glass panels are about 1.44 meters interval, right, the existing panels. So when we design the fins, we ensure that, it sort of align with the current subdivisions, while we add, the intervals, also ensuring that, okay, it does not sort of blocks the view from the internal. Right, so there's a lot of studies done, and this is actually very comfortable. This is a gym, Lazada's gym. Right. So maybe over to you, Matthew.
Thank you. So I'll just dive a little bit into the details of how the facade came about and how we tried to put together the architect's vision into technical drawings. So first of all, I think someone mentioned this morning the difficulties of working on existing buildings and the inaccuracy of 20-year-old as-built drawings. So you can imagine the inaccuracy of 40-year-old as-built drawings. That's what we had to work from. And we did have facade drawings, and that was about the only thing we could extract, that one. So we went a little bit on an exploration journey to understand how the rest of the facade came together. But interestingly, even after 40 years, the existing facade worked, so we didn't want to disturb it too much. So what we did is we made use of the columns, the RC columns. We removed all these white rounded cladding that was there, and we deliberately only attached the steel structure that supports the external features to the columns and to some extent to the roof. So it's partially suspended and tied back, suspended from the top and tied back at every floor. This, I mean, I don't know if it looks simple, but anyway, it was a very complicated thing to work out because we had to fit in the new framing for the columns, the new framing for the fins. We had to interface a small bit of glazed facade, new glazed facade with the old. Matching the glass was quite a challenge, which we had to embark as well through visual mock-ups and all that with the team. So, and obviously integrate the lighting, which we'll see a little bit more on some of the other ones. This is a drawing that shows you the transition between the old facade above, the new facade below, the 2 stories of car park that were converted. And as you can see, the fins, which is the part on the top, is completely detached. It's not attached at all or tied back in any way to the original glazed facade. So what we had to do, if you look at the scale of this thing, 1 grid wide, 13.5 meters, and 9 stories tall steel structure. This was done through parametric structural analysis, where we combined the effects of the glass and the steel to optimize the size of the steel. And at the same time, the layout was tweaked as little as possible, not to disturb the view, but it was tweaked through parametric modeling to optimize the steel structure and make the members as small as possible because of that setback issue that Chiong was mentioning just now. This then was tendered out and had to be built. So again, a lot of constraints in terms of access. I'll just run through some of the images that show you how we had to build special hoisting platform from the roof, scaffolding from below. You can see the enormous scale of the steel elements that were spanning from column to column. And you can see it progressively coming together and being built. Then the various elements of the cladding were removed and the steel attached to the columns. The glass fins that are integral part of the system function as both a decorative and structural element, and there's integral lighting that goes with that, and we'll talk about lighting of the columns in a little, of the facade in a short while with Christine. One of the things that that's always challenging when you have lighting integral to the facade is how do you route the cables? How do you make sure that the fittings are accessible for maintenance? So we devised together with our DP Lighting colleagues a system of concealed openable hatch where the light fitting can be simply opened, or that little hatch can be opened up, the light fitting replaced, and then you close it back and you can't see that anymore afterwards. We'll talk a little bit more. I'm going a bit quickly on the facade, so I'll give a bit more time to Christine. She's the most nervous of all, so I have to give her a bit more time. But we'll talk about how the facade was lit up, and how, in particular, this being in the arts and civic district, the night lighting is almost as important as the day view. So it's very, very important. URA is looking at these buildings in downtown like hawks. And so perhaps, Christine, you can share with us how you dealt with these URA requirements and how this drove your design of the lighting system.
Sure. Okay, so quickly we skip through the existing building.
not particularly interesting as well.
Yeah, it's still very interesting. So when we received the proposal from our client and DPA, our architect, so how to ensure this building is well lit up in a district that is full of a museum and the school. So the way of lighting up, our approach will be is a low-key, subtle way, cannot be fanciful like a commercial retail mall, you know. So in respect to the museum that is on the right side and the school that is right opposite. So we did this Photoshop, which we call it a 3D render, which we have to make it as close as to the actual product as possible. So with our knowledge of the glass and the metal and how we understand how the light react to all this material, and we Photoshop it
in a realistic manner.
Which is on the architect's render.
We'll see about that at the end anyway.
Yeah.
Yes.
Okay.
We'll see how realistic at the end.
Yeah, so for the URA submission, which is the authority submission, they have a very stringent kind of submission to submit. So we have to, besides giving them the 3D perspective, we also have to come up with all the detailing for the facade element. So on here, we have 3 lighting techniques, which is the vertical fin, which is shown here, and how we conceal the light and light up this vertical fin.
So we design bespoke extrusions for that.
Yeah. So the length of the LED strip have to be custom according to the vertical fin. So URA will ask us to submit what is the brightness on the vertical surface. So we have to clearly demonstrate and do the using a Dalux. Over here we use a Dalux calculation to demonstrate how much we are getting within the fin compartment. So on here is about 88 lux. So for the URA submission, there is a guideline that we have to, for the contemporary building in the Bras Basah Bugis district, we have to comply with 50 to 100 lux. This is to control the brightness, the vertical brightness that is on the building. So then we did also the detailing for the glass panel and also the calculation on the glass panel. So on this simulation, we can, this is a column. So on this, we can use a solid surface because it's a color back glass, that kind of treatment. So you can see it's about 89 lux on the vertical surface. And then that comes to the glass panel, which is a bit of challenge because the light will go through the glass. So in order to light up the glass, we need to have the fritted pattern. So how many percent? We also have to negotiate with the architect.
We went through a very extensive selection process. We had countless samples from tinted, not tinted, bronze tinted. We tried interlayers with color, no color. We tried printed interlayer and ceramic frit, different densities, different diameters of dots until finally everybody was happy. I think I can say that for everyone.
Yes, I think we also cannot compromise the view from interior to the exterior. So
I think that's the
have
interesting part of working together as a team, within an office. I mean, this project, that is the advantage that we have.
Yeah, we can like quickly swing to the bay and ask, hey, can you do this now? So we did a calculation on the glass also. So it's about 50 lux because we have to balance it because it's a glass and it's fritted at the bottom only. So that's why it's not washing that whole piece of glass.
Yes.
Yeah. So,
So
yeah.
Perhaps you could tell us also in terms of the mock-ups, we're talking about the different samples. What about those full-scale mock-ups and how we validated the design?
Okay, so when we come to the mock-up, before the mock-up, we have to determine how the electrical cable going to pass through, go into the mullion and pass through into the building to get the electrical supply. So from this visual mock-up, what we need to see is not only the lighting effect, it's also have to determine all these cable entry point that run back to the riser. So on this mock-up, we purposely did a background light on and a background light off. This is to demonstrate that with the background lighting, the facade lighting is still visible. This is to ensure that because we understand that this is an office space and the lighting level behind it will be about 500 lux. It can be quite bright. Yeah. So from here, from this visual mock-up, we can tell that, okay, the LED strip have to be concealed properly because the contractor did not do quite a good job on one of the fin. And also the aluminum powder coat, we also have to ensure that is not too glossy. If it's too glossy, you will cast a hot spot on the surface.
The contractor is in the room, so I should add that eventually they did a good job. This was just a mock-up. The actual job is done very well. They're somewhere. I don't know.
But we understand you need to strike a balance, You can't be too matte because it will trap the dust.
Yes, but it does highlight the importance of the mock-up. Sometimes you look at things on drawings, it looks fine, and then you look at it in reality.
And things like post cabling, which it would be very unsightly. And also we have to take into consideration that when there's an occupant, right? Because this building is not pure, the office hours nowadays are quite irregular, all right? Some work all around, 24 hours around the clock in shifts and things like that. Yes. So you ensure that the comfort of the occupants, all right, not being able, not affected by the glare and things like that. Okay,
and also to take on this point, it's not a case of just hiding the items from the ground floor, which is pretty easy, but it's even making it look okay, acceptable visually from inside the building, because people can look directly at it from at eye level.
That's true.
Yes.
So this photo is taken when I'm standing inside the office space to ensure that you won't look that ugly.
Exactly.
Yeah.
All right. And so working on the live building, any specific challenges?
So the challenges is the electrical cabling, the power supply, to ensure that you won't affect the tenant within the space. And you have to be planned where is the LED driver going to place. You will not affect, you cannot go through the tenanted space. Yeah, so you have to run through the common area and go through the riser where they house all the LED drivers.
Okay. Yeah. So I guess the proof is in the pudding. We saw the renderings at the beginning. How do the renderings compare with the real thing?
Okay, so we come to the last part, our submission, our pre-POP submission to the URA. So we have so much experience with them, and we exactly know what they want.
Don't overpromise. That's
so
overpromise.
We know what they are looking for. So we send them photo of the what is installed on site, as compared to what we have designed, what was installed on site during the day and during the nighttime. Yeah. So there are some photos of the glass panel and even the column uplight. And then we go to the final result, which is we have to submit to the URA, which we need to tell them that our render is exactly what we have built. Yeah.
Very good. I think that's pretty close.
So this is from the view of Raswasa, and this is from SMU. Yeah.
Excellent. Right. So that sort of gives you a perspective of 4 different actors in. to the vision of the architect, the sort of technical inputs from the facade and lighting specialists. The difficulties along the way, I can't stress enough, not just because of COVID, but because of some of the unknowns working with an existing buildings and old buildings. Along the way, some of the difficulties related to working with authorities and justifying that the old buildings would be able to accommodate this new facade, this new design. At all levels, from URA, from BCA. We had some very interesting discussions along the way. And, but I think, as Chiong mentioned, this was not just a question of cost, but it was also a very interesting experience from a sustainable design point of view to just sort of bolt on a new facade, keep the old facade in the back, minimize the carbon footprint of the works we're doing, and optimize the operational, the sort of operational costs eventually. As you noticed, I have a piece of paper, which I normally never do when I'm on stage, but anyway, today I had one. And so this one is not on the paper, so I hope I won't surprise Lorraine with this question. But you know, we looked at, and it's a totally fresh question. It just popped into my mind. So I hope you can answer that. You know, we looked at the sort of savings that could be generated based on the computer simulations, you know, and the energy models. I don't even know if you have the answer, if there is an answer. Do you know if really you realized those savings? Do you have maybe numbers from before and number from after to compare?
See, the building was completed May 22, so we are still in the process of logging in 1 year. One whole year of, and the beginning part, May 22, when it was completed, the tenants didn't, or some move in earlier and then some move in later. So it's not comparing like with like. So we're still in the process of sorting out to see how to do a meaningful comparison.
Yes, and also the occupancy rate was vastly different.
That's
before
right,
and
from
after,
a 30 to like a 90-something, progressively. Because before we bought, the building was like 90%.
Right.
So we would have to literally, you know, see what's the most logical way to compare, so that you don't end up with comparing apple with pear.
Skewed or invalid comparison. Okay, maybe something to follow up and look forward to in the next
No, but
3-4
Matthew,
months.
that aside, and that's a very valid question, because as a building owner, especially the last, call it 2 years or so, the energy hike, the electricity tariff hike has affected all landlords. So I think any feature that can help shield or reduce solar radiation definitely would have a positive impact in terms of energy consumption. So on the high side, I think we did the right thing, you know, because we didn't expect the energy hike.
Maybe just to add on to that, something not directly related to facade design of this building, but we were quite happy, you know, quite pleasantly, you know, happy that, you know, some of the strategies that we adopted for this building. Other than facade, I think there are many areas that we are able to quite confidently say that save energy. Things like on the ground floor, previously the retail shop front is right up to the building edge. So right now we set it back, right, quite a fair bit, 3 to 4 meters, so that we free up the semi-outdoor spaces for F&B to spill out. And instead of, you know, so that logically, I mean, naturally reduces the aircon loading for the internal. All right, and we just installed fans.
That's right.
Right. So, and that aside, because this is a new building, and you see, after COVID, there's a change in terms of our so-called the work habits. Okay, other than staying indoors to work, we want to be, you know, a little more flexibility, go downstairs, cafe, coffee, you know, and do our so-called our work, you know. So that there's this kind of hybrid working, you know, style that, you know. So this building allows that to sort of happen. All right. So we, other than just savings from facade, I think other areas we are able to achieve that.
That's right.
On that front, we had to install a 10-meter long cantilevered canopy right? To be, we're laughing because we know where this is going. But anyway, we had 10-meter long cantilevered canopy. We had done all the engineering for it. We had done all the models, all the simulations to help with these things, the sense of arrival, the shadings. I mean, there's many things that this was intended to do. We had proven that the structure, the 40-year-old structure, could take the loads, but in the end, we could not convince the authorities.
Yeah.
So we had to put struts. Unfortunately, it was a minor concession, to the age of the building.
I think we do.
Yes. Yeah, I think it was in Chiong's slide. We went quickly because we didn't want to see those, but anyway. Yeah. Unfortunately, we couldn't avoid them because I think somehow, while we were confident, the authorities were not so confident.
That's right.
Anyway, so yeah, I mean, this is what we wanted to share with everyone. And I think this is a session where we can directly take some questions. Is that right, Ahmed? Or on whether it's on the design of the building, on the developer's perspective, on the lighting, on the challenges faced when working with older buildings, or the strategies that we adopted along the way to minimize waste, minimize embodied carbon in the facade.
Let me take one question.
Perhaps when you ask your question, you can state who your question is for, or is it for everyone?
I'm directing it to Chiong. Were you able to keep within the property line? Is there anything protruding beyond it that you have to negotiate with RA?
All within. All right. Other than the canopy connecting to the MRT, that was allowed by LTA.
That's right.
Yeah.
I think that is also a challenge for the lighting because of the property line and the horizontal mullion is being that narrow with the column. Yeah. So the lighting have to be set back right to the edge.
Yeah. Very steep, yes. Yeah. Very close.
So no waiver was requested?
No.
No, everything was kept to the original planning approval conditions. Yeah. Because as you all know, okay, we have to get all the approvals within a very short period, okay, so that the building can be up and running within 12 to 16 months.
Yes.
Any other question, or shall we end today's event?
Just other thing. You mentioned that you actually set back the shop front at the ground level. No, or I misunderstood. Was there anything set back?
No, the original shop front was right where the original shop front line was. Right, we set in. Right, so the shop line is still the same. Right, but just the shop glass line, okay, we push it back so that we free up 3 to 4 meters. Sort of a semi-outdoor space, but it's still within the shop tenancy.
Yeah. Okay. It's outdoors or indoors? The line is still there. The shop, the glazing line is still.
The glazing line is still the same.
Okay.
Yeah.
Right.
Thank you.
Thank you. I think this was an interesting discussion. I'd like to thank Mr. Matthew Mayer for this. We discussed on several projects, including a project, I'm coming there, including a project with a racetrack on top of the roof. But I'm glad that he picked this project. It is in line with the theme of the event and in terms of what's been discussed today with respect to should we build new or should we repurpose an existing building. Yeah. So thank you, Mr. Matthew. Thank you to our other panelists also for contributing to this discussion. I'll take a minute. We'll close the event. We'll take some photos and we'll join you outside. So this was the 114th edition of the Zak World of Façades conference. I hope you enjoyed it. We've recorded today's events. today's event. We will share the YouTube link with you a week from now with all the presentations we have permission to share with. And that's it from us until we return next time, maybe with the racetrack on the roof project. That's something which is interesting. So yes, that's it from us. I'd like to thank our event partners. I'd like to thank all of you for taking your time out and coming. And I hope you enjoyed today's event. Looking forward to hosting you next time around. Thank you.